is Dr. Louise Hull, and I'd like to thank the organisers for inviting me to speak today on artificial intelligence in clinical practice. I do have some funding that have supported the research I'm going to present today, but also some conflicts of interest. So firstly, what's our understanding of artificial intelligence? And artificial intelligence is a very broad term about machines that aim to mimic human cognitive capacity. And that can include very simple algorithms and patterns in data sets to very complex neural networks. And that's where machine learning comes in. Machine learning is where you use machines that can learn their processing without explicit programming. So they get better over time and they learn from the data they receive. Deep learning, however, is where you use machines that use artificial neural networks. And these neural networks are very much more complex and they mimic the architecture of neurons in the brain. And this work is by Kylie Dunning's group in Adelaide. They've also talked about how artificial intelligence might automate and standardize decision-making in ART. And there are several different ways we can look to automate and standardize our practice in ART. And it will only get as good as the best clinician. But it's a way of protocolizing and bringing everyone in the unit to a similar high standard. And the main things we've looked at in ART is gamete selection, and probably the most important gamete is in fact sperm, which we can select as we'd usually fertilize all the eggs we get. We look at both egg and sperm quality as the embryo grows, and we can use artificial intelligence, particularly with our time-lapse machines, to look at embryo selection. But also you can look at big data sets as long as they are consistently annotated to look at how patients in individualized ways would do better with a different regimen. So the kind of data that AI is very good at using is very much protocol data, and we can certainly look at predicting the chance of pregnancy.
Hi, my name is Tine Brønding. I am a medical doctor affiliated at the Department of Gynecology and Obstetrics at Copenhagen University Hospital, Hvidovre Hospital. Further, I am a PhD student at the University of Copenhagen. Today, I would like to talk to you about vaginal microbiota transplantation for treatment of vaginal dysbiosis without the use of antibiotics. These are my disclosures. I am under an unrestricted research center grant from the company Freya Biosciences. So before we talk about vaginal microbiota transplantation, I think I would like to stress the impact that the human microbiome has on the entire body. So bacteria, viruses, and fungi takes up more than 10 times the number of the human cells that we see in the body. It is up to 1 to 3% of the human body weight that is due to the microbes that we have in the body. So just to be more specific, a woman weighing around 50 kilo would have around 1 kilo of microbiomes in her entire body. So allocated to different body sites, the microbiome of the body takes up a lot of space and has a huge impact on a lot of functions in the human body. We have over the last years become more and more in depth with the microbiome in each body site, and that is definitely due to the massive development in the technology on how we can detect and see these microbes. So just to take you through a little history, it started with the microscopy and the culturing of microbes, so see who the microbes were and how big they were, and we could grow them. Leading to the qPCR methods, where we could see specific microbiomes and microbes and what they were doing. And today we have these sequencing techniques, which is the 16S sequencing and the shotgun sequencing, which also called the metagenomics sequencing. And these sequencing methods makes it possible to sequence the whole bacterial DNA we see in the samples, and that gives us a much greater vision into what kind of microbes are there and how many they are, and in what amount they exist in the body. So with this technology, we have more and more knowledge about the microbes in the body and in different in body sites, and what they can do to the body and how they can change as well. And to give a little overview about the interest in this field, which is of course very much due to the technology, we see that in 2021 there were more than 4,000 publications on the microbiome in women, and actually more than 1,000 in connection with the immunological link to the microbiome in women. So there's a huge interest, and it's only increasing over the years. So today I would like to focus on the body side of the vagina and the vaginal microbiome. And when we talk about the vaginal microbiome, we talk about either the dysbiotic vaginal microbiome or the eubiotic vaginal microbiome. The dysbiotic vaginal microbiome, also called vaginal bacterial vaginosis, has been a clinical diagnosis combined with microbiological diagnosis, and most often is used the Amsel's criteria or the Nugent score, but recent years we have the more molecular diagnosis, where we use the qPCR or the sequencing methods to see what kind of microbiomes do we see in the vagina. So to be specific, a vaginal dysbiosis is defined as a loss of the lactobacilli, and here we talk about the four most common lactobacilli that we see in the vagina, which is the crispatus, the gasseri, the jensenii, and the iners. And the iners is here highlighted in red because it's become more and more clear that the iners lactobacilli is more a pathogenic lactobacilli. I won't go deeper with that today. And then we see a presence of the bacteria most dominated by the Gardnerella vaginalis, Atopium vagina, and Prevotella bacteria. Those are the most common bacteria we see in the vagina, and the most common one is definitely the Gardnerella bacteria, which is due to this dysbiosis. It is important to talk about vaginal dysbiosis because around 20% of all women in the reproductive age is assumed to have this condition. This is seen in the literature. And what is more interesting is that up to 40 to 50% of these women, they don't suffer from any symptoms due to this condition. And why is it even interesting to talk about vaginal dysbiosis? It is interesting because it is associated with a lot of outcomes in fertility and in pregnancies. And we see in studies that there is associations between vaginal dysbiosis and infertility. There is associations between vaginal dysbiosis and early euploid pregnancy losses. There is association to late pregnancy losses, and as well in pregnancy to preterm birth. So it is a very interesting area, and it is very much has very much a link to both fertility treatment, but also to pregnancies.
Hello, everyone, and welcome to the annual conference of recurrent pregnancy reduction. Thank you for joining this pre-course on artificial intelligence, the future practice in reproductive medicine. You are in the right place. My name is Lorena Bori, and it's a great honor to be moderating this session. As you all know, artificial intelligence is a technology that's levels of our lives. We have to update ourselves. So in this pre-course, we are going to talk about artificial intelligence in different aspects. Will be discussed both at the embryonic level and at the endometrial level. Let's get to it. First of all, we have a talk on artificial intelligence and ploidy by myself. Just to introduce me, I'm in IBI Valencia. I obtained my degree in biology from the University of Valencia, then the master's degree in biotechnology of assisted human reproduction, and a PhD in the Faculty of Medicine. The main field of my research is the application of artificial intelligence in reproductive medicine and specialized in embryology. So without further delay, let's take a look at the presentation. Good morning, everyone, and thank you very much to the organizers for inviting me to participate in this course. I am Lorena Bori, researcher in IBI Valencia, Spain, and I'm going to talk about artificial intelligence and aneuploidy. I have nothing to disclose. First of all, I would like to introduce some terms about ploidy and artificial intelligence. Then I will talk about the relationship between the automatic score provided by different algorithms that are commercially available and ploidy. And finally, I would like to share with you our own algorithm. We are working on the development of a model to predict ploidy based on computer vision. So as all of you know, an aneuploid embryo is an embryo with an abnormal number of chromosomes and may lead to implantation failure, miscarriage, or congenital defects. Unfortunately, the aneuploid rate is remarkably high in vitro fertilized human oocytes, with up to 50% of the embryos diagnosed as aneuploid based on pre-implantation genetic testing for aneuploidies. This technique is the most reliable methodology now to assess the chromosomal content of the embryos. It seems that the best option is to biopsy 4 or 5 cells of the heteroectoderm and analyze them by next-generation sequencing. However, this technique there are controversies in the scientific community because the biopsy is an invasive technique and it requires specialized equipment and expertly trained operators to maintain the embryo viability. And also the mosaicism can have an impact on the accuracy of the diagnosis, as the biopsy of a mosaic embryo can have normal and abnormal cells. In order to address these two main limitations, new non-invasive approaches have been investigated in order to distinguish between euploid and aneuploid embryos. On the one hand, there is one non-invasive approach consisting of the analysis of cell-free DNA released by the embryo into the culture medium, whose results have coincided with the PGT-A results in up to 78% of the analyzed embryos. On the other hand, the behavior of the embryo in vitro has also been studied in search of variation in the behavior of the embryo in vitro between euploid and aneuploid embryos. So continuous monitoring of the embryo development have brought out morphokinetic parameters that have been used to try to distinguish among embryos with different chromosomal content in both early and late stages of the embryo development. For example, the speed of the pronuclear migration or the behavior of the embryo at four cell stage, or even differences in reaching the expanded blastocyst. As you can see, the expanded blastocyst rate was faster for euploid embryos represented as squares in the graph than for aneuploid embryos represented as squares and euploid as triangles. So these variables, whether morphological variables, morphokinetic parameters, or even measurements in the culture media, can be used to create embryo selection algorithm. And these models can be based on conventional statistics or based on artificial intelligence. Most of the algorithms that we know today were based on conventional statistics, such as logistic regression models. However, recently, the artificial neural networks have been proposed to create this kind of algorithms. The first example combines morphokinetic and morphological variables, and the second one includes some measurements of some proteins in the culture medium. So these models were trained with some variables, and these variables, either morphology, morphokinetics, measurements, can be manually annotated, automatically annotated, or even unknown variables, unknown annotations, without previous annotations, I mean. So although the introduction of time-lapse technology in IVF laboratories increases the objectivity of the embryo assessment, manual annotations are subject to disparity among the embryologists, and this is the main problem of this kind of annotations, because then most of the algorithms that have been created with this kind of annotations don't achieve the same results in other laboratories. Currently, there are few softwares for the automatic annotations, such as the guided annotations tool for EmbryoScope or the Connect and Assess for dairy incubators. These annotations are more objective than manual annotations and can also serve to develop embryo selection models such as the KIT score or the EVA system. And finally, there are models without previous annotations. They are based on deep learning. And as you can see, we can search for a specific patient. Here we have all the embryos in the cohort. We can see how the software is capable of scoring the embryos and ranking the embryos, considering only the time-lapse video with image analysis. So what's artificial intelligence? Artificial intelligence is the capability of a computational system to learn and exercise an intelligent behavior. Here you can see some artificial intelligence methodologies from lower to higher complexity. The first evidence of AI in the area of medicine was recorded in the 1960s with Bayesian classifiers, and here we have an example of Bayesian classifiers in embryology. This paper was published by Morales in 2007, and they wanted to predict pregnancy, yes or not, with some characteristics of the embryo, such as the size of the blastomeres, the presence of multinucleation or fragmentation, and the thickness of the zona pellucida. Then you can see the season trees. This example was developed to predict ectopic pregnancy. And then machine learning and deep learning are the most complex methodology. In the next video, you can see the differences between both of them. Okay, so we are moving on the second part of the presentation. We will talk about the relationship between the automatic scores and diploidy. And first of all, we are going to talk about the score provided by the KID score Day 5 algorithm in the last version, which is the third version. So this algorithm was created with a multi-center dataset. It was developed with more than 5,000 embryos with known implantation data. And thanks to the morphokinetic and morphological variables, a score is generated according to the cleavage regularity, the speed of the embryo development, and the blastocyst quality. And this automatic score ranges from 1 to 9.9 according to the implantation potential, from lower to higher implantation probability. In this video, you can see the guided annotations tool for the embryo scope and the KID score algorithm. So here in gray, you can see the annotations that were suggested automatically by the software. So the embryologist can confirm this annotation if he agree with this annotation, and if not, they can modify the annotations. As you can see, the video stops when it detects an event automatically, and then the embryologist can confirm this annotation. So this algorithm, the KID score, considers the presence of 2 pronuclei, the division time to 2, 3, 4, and 5 cells, blastulation, and the quality of the inner cell mass and the trophectoderm. Here, in compare and select, we can choose our algorithm, in this case, the KID score Day 5. In the table, you can see the values for all the parameters that make up the algorithm. And just below, we can see the 4 embryos that achieved the best score according to those variables. In this case, the first embryo here is the embryo in the second well, was the embryo with the best score. So now we are moving on the results that we obtained with this algorithm. We made a retrospective analysis, and as you can see, we found that the automatic score was higher when the morphological quality assigned by senior embryologists in the laboratory were better. As you can see, 8.3 for embryos graded as A to 2.2 for embryos graded as D. We are talking about conventional morphology according to a severe criteria, which is the criteria that we use here in Spain. In this slide, you can see the association between the automatic score and ploidy. As you can see in the table, the mean of the KID score for euploid embryos was higher than the mean for aneuploid embryos, 5.4 versus 4.7. And I know that it was statistically significant, although visually the difference is not very high. But you can also see that the euploidy rate increased as the embryo score was higher, for 34.20% for embryos with less than 3.4 to 58.20% for embryos with more than 6.5. Then I would like to show you an overall of the association between the automatic score and the clinical results. We divided our automatic score, the KID score, in quartiles of similar sample size, as you can see here on the left. And we found that it was correlated with clinical outcomes. As you can see, the pregnancy rate increased as the embryo score was higher, from 50.60% for embryos with less than 5.4 to 75.70% for embryos with more than 7.5. We saw the same trend for the implantation rate, from 41.70% for embryos in the first quartile until 67.90% for embryos in the last quartile. And the same trend for the live birth rate, from 32.80% for embryos with the lowest scores until 59% of live birth rate for embryos with the highest scores. So now I'm going to talk about another automatic score provided by other algorithm. In this case, the IDA score in the second version. It was created with a multi-center database with more than 22 clinics. It was developed with more than 180,000 embryos. This model was based on deep learning. We don't need a previous extraction of characteristics. We don't need annotations. In contrary to the previous algorithm, the KIT score is based on machine learning. The IDA score is based on deep learning, but also provided an automatic score from 1 to 9.9, from lower to higher implantation probability, according to the developers. This video is our experience with the IDA score. I saw it in the previous slide, but here we are going to see the IDA score in detail. Here we can search for a specific patient, and then we can see all the embryos of the cohort. And here the software is capable of scoring the embryos and ranking the embryos according to the image analysis in the time-lapse video. So we don't need previous extraction of characteristics, we don't need variables, but if we want to annotate something or see the KIT score, we can click on the embryo viewer. And now we are in the conventional screen of the embryo viewer with our annotations and other models like the KIT score that I showed you previously. Okay, so here are the results, the comparison of the automatic score with conventional morphology and clinical outcomes. As you can see, also the automatic score provided by the KIT score decreased as the conventional morphology was worse, from almost 8 for embryos graded as A until 1 for embryos graded as D or E. It was also related with the clinical outcomes. The mean of the automatic score provided by the IDA score was higher for implanted embryos than for non-implanted embryos. The embryos that achieved a live birth had higher automatic score than those embryos that did not. And also the embryos that ended in a miscarriage or an abortion had a lower automatic score provided by the IDA score. And in this slide, you can see the direct association between this algorithm and ploidy. Also in the table, we can see that the mean of this automatic score was also higher for euploid than for aneuploid embryos. And you can also see that the euploidy rate increased as the embryos had a higher score, from 31% for embryos with less than 3.4 to more than 63% of euploidy rate for embryos with more than 8 of score. And this is the last algorithm that I'm going to show you. This is the one from Light Whisperer. In this case, this algorithm is based on a static image, a single image of the blastocyst, concretely at 120 hours of development. So now we were introducing the characteristics of the patient, the date of birth, the patient ID and treatment ID, and then we can upload each image of the blastocyst. You can see that this software has like 2 modules, one for the assessment of the viability and another one for genetic assessment, as you can see here. So in the video now we are uploading the pictures of the blastocyst at 120 hours of development. And as you can see, the score ranges from 0 and 10 according to, in this case, the viability of the embryo on day 5. And then we can choose the genetics. It means that this score is like the probability of one embryo to be euploid. Okay, so we also have the opportunity to test this algorithm with a small sample size, with a small data set of embryos. But we also saw that the euploid embryos had a higher score than aneuploid embryos. And also the euploidy rate increased as the embryos had a higher score. We found 39% of euploidy rate for the first and the second quartile, And then for the third and fourth quartile, the euploidy rate was higher. And finally, I would like to share with you our latest study. We are working on the development of a model to predict ploidy based on computer vision. Until now, what we did was to find the characteristics that are different between euploid and aneuploid embryos. And we would like to measure those characteristics with computer vision. So, firstly, we found differences in the morphokinetic parameters in euploid and aneuploid embryos. The aneuploid embryos had a slower development than euploid embryos. So we calculated the mean of the division time to 2 cells, 4 cells, 8 cells, and blastulation for euploid, and for 3 groups of aneuploid embryos, monosomic, trisomic, and chaotic. And we saw that all the aneuploid embryos achieved these events later than euploid embryos. So then we calculated the proportion of embryos that reach each event later than the euploid mean of embryos, plus 1 standard deviation. And we did that to calculate then the relative risk, which is the risk of an embryo in one category reaching the event late compared to euploid embryos. And here you can see the results for this part, which is easier to understand. So we assume that the relative risk of an euploid embryo in green is always 1. And as you can see, all the aneuploid embryos had a higher relative risk to achieve this event later. The division time to 2, 4 cells, 8 cells, and the starting blastulation or the blastulation. Secondly, we found that the proportion of embryos graded as A, B, or C are different in both groups, in euploid and aneuploid. And the next characteristic is more difficult to explain. Our theory was that one biological reason, or a possible reason, for the delay in the embryo development in aneuploid embryos could be due to the inefficiency of the development in early stages. So we assume that this delay in the development could be reflected by a higher selectivity, in terms of higher rate of false mitosis, more cell movement, more pseudomitosis events, and more fragments. And we thought that these characteristics, we can measure these characteristics with computer vision with the measurement of the cell edges. So we wanted to analyze the cell borders as a proxy for the cell activity using computer vision. So we wanted to analyze approximately 160 frames of the time-lapse videos between the division time to 2 cells and the division time to 8 cells. But let me briefly explain how we did it, because for us as humans, it's relatively easy to find cell edges in a time-lapse image like this one. But actually, there could be 5 kinds of edges in only one frame, and this is not so easy to detect from a computer perspective. So we had to develop a computer vision code, and we wanted to measure the total length of the cell borders in micrometers in each frame, and also the difference in this length between consecutive frames. So here's like a summary of the computer vision code. The first picture is a time-lapse image, a raw time-lapse image. In the second picture, you can see how our model was able to detect those pixels that were darker than its neighbors in 2 opposite directions, but not darker in the other 2 directions. In the third picture, you can see how our system was able to join such pixels in short linear segments. This picture, the third one, was manually marked to facilitate this explanation, and the actual output is the last image, the fourth picture. You can see as most cell edges were correctly found, and few noise pixels were wrongly found or detected as false positive edges. And here are the results for this part. As we expected, the total length of the cell edges was higher for aneuploid embryos, 489 versus 450. And also the difference between consecutive frames was higher for aneuploid embryos. Then we performed a logistic regression model and taking into account all the full list of the cell edges between the division time to 2 cells and the division time to 8 cells, the total length of the edges and also the difference between consecutive frames. And we achieved an accuracy of 73%. And as you can see, we obtained a balanced separation between euploid and aneuploid because the sensitivity here and the specificity here and the confusion matrix were 73%. And then when we calculated the odds ratio, we realized that if one embryo was rejected by our model, it was 7.42 times more likely to be aneuploid than euploid. Okay, and the next characteristic is an approximation of the number of mitochondria. Although it's not possible to know that they are real mitochondria, but the size of these organelles is very similar to the size of 1 pixel of the embryoscope. So we analyzed those pixels that were different to its neighbors, but actually they could be organelles or they could be simply noise. So our theory was that we know that the embryos in the late stages had less mitochondria. I mean, there is a reduce of mitochondria in the late stages of embryo development. And there are previous publications that stated that the euploid embryos had less mitochondria in late stages than aneuploid embryos. So we thought that we can measure the pixel change over the hours from TM to TSV. And for us, our theory was that the noise would remain constant and actual organelles would be reduced. And this should happen more in euploid embryos than in aneuploid embryos. So we established as a threshold a difference of 40 points. So if there was a difference lower to 40, there would be too much mitochondria. And this happened in 38% of aneuploid embryos and only 10% of euploid embryos. And the last characteristic was the pumping or wake contractions. We analyzed this event with computer vision, measuring the diameter of the blastocyst. So we considered that there was a pumping event when the diameter of the blastocyst was 8 micrometers smaller than its diameter 40 minutes earlier. And we found these pumping events in 6% of euploid embryos, you can see in green, and in 30.50% of aneuploid embryos. And then we calculated the odds ratio, and we realized that the probability of being aneuploid was higher when more events of pumping. So finally, our aim was to join all these modules in one algorithm. And we found final accuracy of 90% in dividing between euploid and aneuploid embryos. So it was very high, and we didn't understand why it was so high when the accuracy of the characteristics, the models individually, were not so high. So we didn't understand. But then we realized that some characteristics have a high precision in a small population, discarding a lot of aneuploid embryos in the first steps of the hierarchic algorithm. So for example, the general accuracy for morphokinetics was 52%, But then in a small population of abnormal morphokinetics, 90% of the embryos were aneuploid. And the same happens with the pumpins. The general accuracy was 56% for the pumping event, but in the small group with pumpins, 82% of the embryos were aneuploid. So to sum up, here are our conclusions. Some commercially available models score euploid embryos better than aneuploid embryos. The embryo development was visually different between euploid and aneuploid embryos. For us, enough to deserve like a deeply analysis. In vitro development in aneuploid embryos was slower than in euploid embryos. The proportion of embryos of different morphology is different between the euploid and aneuploid groups. The measurement of cell borders as a proxy for cell activity, also the approach to estimate mitochondria and the pumping events revealed differences between euploid and aneuploid embryos. A preliminary complex AI system achieved 90% of accuracy in detecting aneuploid embryos in our small data set. So after achieving more robust results, the use of a non-invasive tool based on artificial intelligence could be generalized to prioritize euploid embryos for transfer. So finally, thank you for listening, and if there are any questions, I would be pleased to answer them. Hello again. I hope you enjoyed the presentation. Afterwards, we will have a few minutes for questions. But now let's move on to the next talk on artificial intelligence and endometriosis. We have the pleasure of listening to Professor Louise Hall. She has worked in fertility services since she graduated as a doctor. She has been delighted to help many couples conceive, as well as promote the development of improved fertility treatment through research and education. Professor Hall works at the Robinson Research Institute, University of Adelaide, Women's and Children's Hospital in Adelaide, and in private practice at Embrace Fertility in Norwood. She has conducted research exploring the immunology and biology of implantation and has participated in biotechnology and pharmacology-sponsored clinical trials in the IVF industry. Whenever you want, Professor Hall, the floor is yours.
My name is Dr. Louise Hull, and I'd like to thank the organisers for inviting me to speak today on artificial intelligence in clinical practice. I do have some funding that have supported the research I'm going to present today, but also some conflicts of interest. So firstly, what's our understanding of artificial intelligence? And artificial intelligence is a very broad term about machines that aim to mimic human cognitive capacity. And that can include very simple algorithms and patterns in data sets to very complex neural networks. And that's where machine learning comes in. Machine learning is where you use machines that can learn their processing without explicit programming. So they get better over time and they learn from the data they receive. Deep learning, however, is where you use machines that use artificial neural networks. And these neural networks are very much more complex and they mimic the architecture of neurons in the brain. And this work is by Kylie Dunning's group in Adelaide. They've also talked about how artificial intelligence might automate and standardize decision-making in ART. And there are several different ways we can look to automate and standardise our practice in ART, and it will only get as good as the best clinician. But it's a way of protocolizing and bringing everyone in the unit to a similar high standard. And the main things we've looked at in ART is gamete selection, and probably the most important gamete is in fact sperm, which we can select as we'd usually fertilise all the eggs we get. We look at both egg and sperm quality as the embryo grows, and we can use artificial intelligence, particularly with our time-lapse machines, to look at embryo selection. But also you can look at big data sets as long as they are consistently annotated to look at how patients in individualised ways would do better with a different regimen. So the kind of data that AI is very good at using is very much protocol data, and we can certainly look at predicting the chance of pregnancy and helping patients understand what their chance might be. We could look at which different ART method, like IUI or IVF or trying naturally, would be. You can look at the different types of stimulation cycles within your unit and decide which would best suit that particular patient. Optimize trigger timing, sperm selection, working out which fertilization method would work best, embryo selection, and timing of transfers and frozen embryo transfer cycles. And by looking at very large databases, you can look at individuals with very similar characteristics and see what happened best. But it's using very retrospective data to try and predict the future. What AI cannot do is comfort and care for patients. It can't provide that rationale to patients for decision predictions and why it's decided to do that. It can't discuss the pros and cons of the different treatment options. It doesn't take patient preferences into account or moral and religious restrictions on what they might choose to do. Nor does it take account the patient's autonomy in both their health and financial decision making. It doesn't account for individual skill set differences between clinicians, embryologists and operators. Or if things just don't fit in the box, AI doesn't know what to do. It will give you a standard response to a standard set of parameters, but it won't think creatively outside that box. And some of our patients need that creative clinical decision making. So is there a role for AI in implantation and placentation disorders, which is what we're talking about today? And I'm going to give you some examples where I think AI will be very beneficial and how we need to think about how to develop this going forward. When you look at implantation and placentation disorders, the kind of things we think about are structural abnormalities, and hysteroscopy is often what we use. Certainly in colonoscopy, we're using AI to identify small polyps and to aid less experienced clinicians to identify lesions that they might miss. And certainly you could look to do that with hysteroscopy. Autoimmune disorders, we have very poor testing and often need to test in different labs and need to develop different assays. It's a very complex decision as to whether someone has antiphospholipid syndrome, and we may be able to utilize some AI to look at helping that. Infection, again, is poorly diagnosed, and particularly with the microbiome, but potentially other parameters, AI may be able to give us a help with that. Endometriosis and adenomyosis, and that's what I'm going to speak about today. The imaging work that we're doing with endo is really helping us with diagnosis, and AI is becoming more and more valuable to us in those in assessing those images. And there are an array of more modern developing tests that we're getting better and better with in implantation and placentation disorders that may well be able to be put together and patterns recognised, particularly things like the receptivity arrays and potentially immunohistochemical staining or identification of plasma cells that could be automated to make things a lot easier. I'm going to talk about endometriosis because we are now finding and have been recognised by ESHRE, NICE and RANSCOG that ultrasound and MRI are valuable in diagnosing endometriosis non-invasively, and that we don't just have to rely on laparoscopy, which we used to have to do a few years ago, to visualise lesions. We performed a Cochrane review in 2016, and transvaginal scanning was very good at detecting ovarian and deep infiltrating endometriosis, but less good at superficial lesions. Whereas magnetic resonance imaging was quite good at both, and often you could see, particularly on the T1 images, the heme in an iron in the lesions would be detected by the scanner. So we wanted to look at working out how we could put those two things together. We looked at using ultrasound, MRI, combining those data sets, using an AI algorithm to look at patterns within that digital data and getting a good diagnosis. And that was our proposal. We were very lucky to work with Gustavo Carniero, who is a very experienced AI academic who has worked in imaging in medical technologies for many, many years. And he helped us put together our program and our AI paradigm to bring both ultrasound and MRI together and to classify them and look at their value, whether the diagnosis was valuable. We were also very fortunate to work with some of the world experts in endometriosis ultrasonography, and this is a very new field. Almost everyone who has an transvaginal ultrasound does not have endometriosis looked at because you do have to scan in the posterior fornix to identify endo. And George Condis and Matthew Leonardi again informed us about the kinds of scans we needed and how to get them, and indeed gave us a lot of scans which were very high quality. And our research question was, for proof of principle, we took one marker, which was pouch of Douglas obliteration, and it was, could we diagnose it using an AI algorithm at the level of an expert sonographer? We were able to get large numbers of endometriosis scans, and this is by far the most limiting factor for us. Overall, we had 646 normal scans and 103 that had pouch of Douglas obliteration, and we divided these into a training set to teach the algorithm, a validation set to be sure that the algorithm had worked, and then to test in a test set. And what we found was that the area under the curve was 97% and the accuracy was 95% using the AI algorithm. So it worked very well in this data set that we had with one of the many markers of endometriosis. So one of the main issues for us was getting the right scan. And if you have a look on the left side, there are 7 signs of endometriosis that you can pick up on an ultrasound scan if you do a specialised endometriosis scan, which very few people in the world are trained to do. The main difference here is that the 2 asterisk markers are the only 2 you may pick up if you do a standard scan. So we just could not use standard scans. We need specialist scans. The advantage of putting MRI and ultrasound together is that there are 8 signs on the MRI that can be added to the signs on the ultrasound. And by combining these two modalities, you have completely different markers identifying similar lesions in different ways. And this increases the diagnostic power of the test. And we wanted to digitally combine these two different modalities to improve our diagnostics. One big issue we had was we had to improve the quality of endometriosis scanning, and we looked at digital ways of doing this. And we needed sonographers with the absolute skills to perform endometriosis scans, and we needed to show how these scans made a difference to people's practices, to encourage patients to ask their doctors for the right scan, to encourage their doctors to understand what scan they needed and whether they'd actually received that from their sonography and radiology provider, and for people to spend the time and energy learning how to do an endometriosis scan, which does take longer. It's poorly rebated around the world, but 1 in 7 women in Australia in the last survey has endometriosis, so it helps so many more people. We developed a side arm of our project called EndoIQ, and this is where we want to improve the quality of endometriosis scanning. And the idea is that we can digitally look at scans and determine if they're of sufficient quality to be incorporated into our algorithm because they've looked for the signs of endo. This will help the community determine whether they've got the right scan. It will help our general practitioners determine if they've got the right scan, and it will help our gynecologists determine if they've got the right scan. And if we can do this digitally, we can look at credentialing and being sure that we are encouraging people to perform high quality scans, and potentially we can improve scanning in real time, so that people can do a scan and get immediate feedback. We have been exploring reporting with digital systems of reporting to improve speed and to look at quality. And we've got some very clever AI guys who are looking at how to look at the interface between the sonographer and the scan to improve scanning so that we get better data. And Ali Deslandes is a qualified sonographer who's doing a PhD with us under Dr. Tim Chen's guidance, and these other 2 AI PhD students and postdocs that we've got are helping them develop these tools. We also had to look at MRI, and Dr. Stephen Knox is a radiologist who specialises in MRI services, and we're very lucky in Adelaide because most centres either do MRI or ultrasound, but not both. And we were very fortunate that we had high-level skills in both MRI and ultrasound, as well as a very highly experienced AI group in Adelaide, and also people, we have a large endometriosis research group here as well. And the main issue with MRI scanning is the quality of reporting, and actually the radiologists identifying the lesions to be able to classify them. And this improves over time. It improves with better scanners, but we did need to do a lot to assess artifacts and mislabeling and misreporting and re-report some of our scanning, particularly older scans. The advantage of MRI is that you have 2 modalities, a T1 and T2. And the T1, which you can see in the top slide, often you can see lots of little bright white lesions, and these can be quite small superficial lesions that you can identify by the iron that's in those lesions that the magnet detects with MRI. And the T2 classification also gives you a different modality. So we have 2 different modalities on MRI that can be combined in an AI network. And we looked at 4 different signs: pouch of Douglas obliteration, ovarian endometrioma on the left, and on the right and also behind the cervix. So we have tried to identify various individual lesions and then combine them. And probably one of the more interesting things we've been able to do with our AI is to look at combining the ultrasound and MRI data. And we've done that with the sliding sign, which looks at Patch-of-Douglas obliteration, or we can actually see cul-de-sac obliteration on the MRI. You can see here when there's no disease in the green, there are pools of fluid that sit behind the uterus on an MRI, and you can see those pools of fluid and you can see that there's no adhesions there. On the ultrasound, we see that the back of the uterus slides very easily over the bowel, and there's clearly no adhesions there either. And that's a negative sliding, a positive sliding sign, which means that there's no disease present. When the disease is present, we find that there's no space between the bowel and the back of the uterus. And when we look on a scan, nothing moves. It's very stuck down, and indeed you can see an endometrioma in this picture as well. And that's a negative sliding sign, or positive that the disease is present. So we had two modalities with MRI and a third ultrasound modality. And we wondered if we could cross-train these modalities with MRI, which is an incredibly novel formulation to see if you could actually use MRI and ultrasound together to improve one of those modalities. And so we had an endometriosis data set, and for AI this was a fairly small data set. We had some ultrasound data sets which were of a reasonable size but not big, and we also had a public large data set that we could also look at. And we utilised these data sets to look at cross-training. So this, Yuan is one of our PhD students, and she won an oral presentation for her work here, where she looked at using MRI pre-training on her MRI data set, and then used ultrasound to train that same data set. And this was an independent data set. This was not in the same patients. But she used some pre-training with the ultrasound in addition to pre-training with the MRI, and found that the knowledge distillation was much, much higher. And when she did that, the area under the curve went from 65% to about 90%, particularly when there was some fine tuning as well. So utilizing another modality, imaging modality, ultrasound, to train an MRI data set was feasible, and it improved the area under the curve. And this is where AI can really help us look at new ways of improving our diagnostics. She won at the IEEE conference, which is a very prestigious AI conference in Colombia. She won the best oral presentation, and this was a great boost for us to think that a women's health initiative could be looked at across all different initiatives, but it was because we had both those modalities. It's important, and it's important in fertility, and the main reasons it's important is that we can get more people a diagnosis. In my fertility practice, it's been life-changing because we very rarely see unexplained infertility anymore, but it's not possible for all my patients to have a laparoscopy. It is possible for them to have an endometriosis scan or an MRI. And in Australia, we've had a Medicare rebate for MRI come in last year for endometriosis. So we've had better access as well. What we do know is the importance of diagnosing endometriosis before you have a fertility treatment. And we know that endometriosis also has an impact on miscarriage, and we can look to preempt that and look at different treatments for that if we know it's there. And 40 to 60% of people with unexplained fertility have endometriosis that we just don't diagnose. So it's not really unexplained fertility anymore, it's undiagnosed fertility problems. And we have the diagnostics, and we're developing the diagnostics. This particular study came out of Queensland. It's the Australian Longitudinal Study on Women's Health by Geeta Mishra's group. And they looked at a large group of people, 34.7% of which, of couples in the study had endometriosis. But 65% of them were diagnosed before they started treatment and 34% afterwards. And when you had a diagnosis before you started ART treatment, you were less likely to use IUI, less likely to have very high numbers of cycles, and more likely to report a birth. So as I put here, if you were diagnosed after you started treatment, if you hadn't had that scan, you were more likely to use IUI, you were more likely to have very high order IVF cycles, and you were less likely to report a birth. And that they did look at confounding for age, and this was quite a significant result because it's in everyone's interest to get that diagnosis before you start. But you don't necessarily have to have surgery if we can detect endometriosis. Endometriosis scanning is still not very sensitive, so a negative scan does not rule it out. But if you have a positive scan, you're in a much more powerful position going into fertility treatment. We're hoping to spread the word, so we're undertaking some research programs to improve the understanding of scanning and the ability of scans and imaging to help people with a diagnosis for endometriosis in primary care settings. So the GPs can understand what scan they should be getting, where to get it from, and often there's a real access problem at the moment because not many people know how to do it. And we want to evaluate the barriers for doctors to get the right care and the right scan. And we are undertaking a Triagendo program where we're looking at the barriers GPs face with a view to trying to look at some digital ways we can help them and potentially allow them to upload their patient scans and see if they've even got the right scan. And digitally assess the quality of those scans through the EndoIQ program. We also have a digital reach, the Australian National Action Plan. One of the funding initiatives was to put EndoZone, which is a digital platform that brings the endometriosis community, the medical community, and the research community together. And we've had more than 46,000 people use this program. And again, it's a place where we could potentially house digital ways of assessing scanning and improving access for patients in a way that they can find out where to go to get the right scans. We have won the Eureka Prize, which is the Australian National Award for this technology. Which we were surprised at because Women's Health, I don't think, has ever won this prize before, but it shows how many people need and want this kind of technology. And I have a lot of people to thank. So this initiative has come out of the University of Adelaide and the Robinson Research Institute, which is a reproductive health centre. We've had a lot of help from commercial and innovation services to get funding for this, but also a huge amount of help from our AI team, both with our diagnostic algorithm, but also with EndoIQ. And they've been incredibly innovative and fantastic to work with. And they're at AIML, which is the Australian Institute for Machine Learning. We've also had incredible support from our ultrasound and MRI experts, both in the way they've provided scans for us and the way they've helped and worked with us to get better and better at understanding how to improve scanning and reporting. They've done workshops at conferences. They have been very good at outreach and at bringing people on board and working with them across Australia. And we're in almost all states in Australia now, but also we're looking at a lot of worldwide collaborations. We have a lot of people from Europe and North America, South America, and Asia Pacific who are wanting to be part of this and to help for us to help them improve their scanning and reporting for MRIs, while also contributing to provide scanning for our AI guys to improve their algorithms.
Hello again. Unfortunately, Professor Hall cannot be here today to answer the questions, but we have Dr. Nasser Al-Asmar. I know that most of you know him. He doesn't need much more introduction, given his experience in reproductive genetics. Currently, he serves as the scientific director of the Genomics Academy, a part of the... So whenever you want, Nasser, we can start with the Q&A.
Thank you very much, Lorena, for the kind introduction. So I guess that I can ask you a few questions that I've got from your lecture. If there's any question from Dr. Hull, we can email her, so don't worry, you can the questions that you want. And please write your questions in the chats, and I can ask Dr. Bori. Regarding the model that you are developing for neuropleutic prediction with computer vision, some modules are really approximation, right? So do you think the association of this with ploidy is sufficient robust right now?
I totally agree that it's difficult to rely on this kind of approximation, but for us, we found that euploid and aneuploid embryos are visually distinct enough, at least for us to deserve further investigation. And it was that most aneuploid embryos would have, for example, a higher selectivity, which is one of the features that we measured, than most euploid embryos. And if it's true, it would manifest itself in a higher rate of false mitosis, more cell movement, more pseudomitosis events that create fragments. And these events are observable, but are very difficult to detect and quantify with automated techniques. So we thought can use another tool to measure these characteristics easier with a proxy. And it's true that the total length of the cell edges is clearly a proxy of the number of cells and their sizes. and it's relatively easy to find selects with computer vision with phi wearables. And in the case of the mitochondria, it happens the same, because we really don't know if those pixels that I talked about were mitochondria. But according to previous publications, they could be, but if not, they are also interesting because they are different between euploid and aneuploid embryos. But however, our next step is to implement a more robust and detailed AI function to measure these features, taking into account not only the length of the select pixels. So we are working on it to improve it.
Okay, so improving and improving, right?
Innovation always.
Innovation, okay. And regarding the automatic scores that are commercially available right now, do you think that if we have any of these scores in the clinic, could we avoid to do the biopsies on all the embryos, on some embryos?
Okay, not really. We are not using these automatic scores to decide which embryos to biopsy or not. That we could set a threshold in each clinic and decide not to biopsy those embryos that had a score lower than the threshold. But actually, we are not using this kind of models to avoid biopsy, because most of these algorithms were not designed or developed to predict ploidy. So until now, I think that we can only use this kind of algorithms to reduce the risk of transfer or selecting an embryo with an abnormal number of chromosomes, and prioritize to select those embryos that are more likely to be euploid, thus less likely to be scurvy.
Okay, because you know that I developed my career into the PGTA, chromosomal analysis, now with the Embrace, the non-invasive PGTA. So I do think that we still have a long way in order to do the ploidy with those kind of tests. And hopefully we can do it like putting together the different techniques in order to improve results for the patients. Okay,
yes,
perfect.
Totally agree. I think that the future is that, so if we want to replace the biopsy one day, both methodologies are complementary. Non-invasive measurements in culture media and also the image analysis.
And following this question, I would like to ask you, and again, about tradition to do trophectoderm biopsy in order to do a PGTA, or even the non-invasive PGTA, the Embrace that we are doing right now in the culture media to know the chromosomal status of the embryos. Do you think that the artificial intelligence-based methods are preferable to those traditional biopsies or measurement from the culture media?
Now the models based on artificial intelligence are starting to be in the place where was the measurement of culture media some years ago. I mean, the existing non-invasive techniques for PGTA, such as the measurement of cell-free DNA or metabolite media, are not now preferable to methods based on biopsy, as the tests that we have now, they are still insufficient. And I think intelligence, it now faces the same situation, and its predictive capability is still limited to replace the biopsy. So for the moment, I think that these models can only be used in, for example, those patients who live in countries where the biopsy is not permitted, or those patients that don't want to manipulate their embryos, or those patients that are not required to genetic testing by a predefined medical reasons, but not to replace biopsy in patients that need a genetic testing of their embryos.
Mm-hmm. So, and also regarding the different techniques, at the end of the day, I think it's a matter to combine, right? Because I always express that we are far away from the 100% of pregnancy rates. And well, in biology, in medicine, it doesn't exist 100% or 0%, but we're still far away from this 100% of pregnancy rate. And I don't think that we are going to get any innovation regarding genetic testing, AI, and predictional models in order to make a huge jump into these kind of rates. But my opinion is that we need to combine the different techniques, maybe the time-lapse system together with the AI that you were talking about, the culture media. So at the end, we will be in a position to have higher rate. What is your thoughts about it? Do you think that we should combine the different things? Do you think that you are going to develop something that on AI that can avoid to do the rest of the things?
No, I totally agree with you, because I think that AI alone, it's not capable to 100% one embryo is euploid. It's not possible. These techniques are in previous steps, the measurements in the culture media. We are working to try to find some features that are visible and the euploid embryos, and try to automate the way to identify and quantify this difference. But then when we will have the complex methodology with all the image analysis, I think that it will be, we need to support this image analysis with some related with the culture media. Well, you know very well that there are very promising results have been achieved with the measurements in the culture media. So I believe that they are complementary, and I think that they would add a lot of value in a complex technique in the future.
Yeah, I'm totally agree that we should combine the techniques in order to have better chances to have better results. Dr. Bori, but I guess that we have time only for one more. And the thing is that this is a question from every single Congress, right? When we talk about AI, and the question would be AI to replace the embryologist, or we still need the embryologist in order to perform the different techniques?
Yes, this is like the $1 million question. In my opinion, it's inevitable that the implementation of automated systems will reduce the demand of embryologists as we know them today. But I think that there should be an increasing demand of embryologists with additional skills. I mean, apart from having the basic knowledge of an IVF treatment, the complexity of an IVF treatment, they the skills for advising colleagues and patients on recommended treatment options, also an extensive knowledge in statistics. I mean, we will need to update ourselves, because if not, we will be left behind. Technology is advancing very fast, and not only in embryology, I mean, in many aspects of our life. So in my opinion, these kind of tools are not here to replace embryologists. They are made to support our work in the laboratory, to improve the work of the embryologist and optimize their time. I think that it kind of tools allow the embryologist to spend more time on other tasks.
This is the thing that we don't think, I have the same opinion. It's not going to replace embryologists or help us in order to optimize our time, and maybe to instead doing some things that can be done by the AI, we can do research, read papers, writing, go conferences, and so on. So I think that this is going to help us instead to steal our jobs.
Yes, totally agree.
Okay, so thank you very much, Dr. Bori and Dr. Hull, for your nice lectures and I guess that we should finish in order to start with the Congress. I would like to say to all of you for attending, and see you later. Bye-bye.
Bye. Thank you, Nasser.
Welcome everyone, dear friends and dear colleagues, to our 7th event, Eastern European Professional Meeting, and the topic is recurrent pregnancy loss. I just mentioned it's the 7th meeting, and I was really surprised to hear that so much time has passed since 2016, when it was just our first try to organize international profile lab on recurrent pregnancy loss. And we thought back at that time that we were going to meet once every 2 years if this topic appears interesting. But your interest toward this topic was so big, so high. So now we have it annually, we have it every year, and it's not only one-day event. Usually it's a 2-day event, thanks to your interest and your participation. And today this is possible, first of all, due to the armed forces of Ukraine. So I'm very happy to welcome, to greet everyone at this Congress. I'm sure these 2 days are going to be insurmountable, and you will hear everything about RPL, everything that you already knew or something that you haven't heard about yet. Everyone will find something interesting for himself or herself. So I wish you fruitful work.
Ladies and gentlemen, dear colleagues, it's a great opportunity to welcome you at the 7th annual meeting dedicated to recurrent pregnancy loss, and not only the problem of recurrent pregnancy loss. And today, and actually we will have 2 days of wonderful program, well-known speakers, which are the experts in the field of recurrent pregnancy loss, IVF, repeated implantation failure, and many other things which we are going to discuss during these 2, I hope, wonderful days. I wish you to spend these 2 days as so that's a tick, перепрошую. I hope that you will enjoy these 2 days, and I wish all of us to have a great pleasure of this possibility to make such a conversation, and to hear from the well-known speakers, experts in that field of science. And of course, I want to wish Ukraine the win and the peace as soon as possible. Slava Ukraini!
Hello, everybody. Welcome. You are very welcome to the 7th annual conference on recurrent pregnancy loss and human reproduction. We are very happy to have this continuity. And I remember the first congress that was in Ukraine physically. I was there, and I'm happy that we are still doing it. These 2 days are going to be fascinating with the leaders in the field all over the world. Everybody is coming and giving his knowledge and bringing his experience. And I'm sure all of us will have a lot of new knowledge and ideas and concepts about recurrent pregnancy loss. Let's having a great time together. And I also want to invite you to our next WCRPL I'm sure we met before in the other congresses. It's going to be also the seventh one, and the new location and date will be published very, very soon. Good luck, everybody, and come to the lectures.
How are you? I'm Joanne Kwak Kim. I want to welcome all of you to the 7th Annual Conference of Recurrent Pregnancy Losses and Human Reproduction. From today and tomorrow, we'll review various topics of recurrent pregnancy losses from world-renowned expertise. I hope you all enjoy the conference and gain valuable knowledge that you can apply to your clinical practice, research, and medical education in the future. Thank you again for your attendance.
Dear friends, dear colleagues, welcome to the 7th Annual RPL 2024 Conference. This conference will take place between Friday, October 27th and Saturday, October 28th, with so many fantastic speakers from all over the world, such as Professor Boris Atta, Professor Asher Basiri, Professor Mikola Grishenko, Professor Joanne Kwak Kim, Professor Nick Macklon, or Professor Attilio Di Spiezio, and many, many others. We will touch interesting topics such as artificial intelligence, RPL and infertility, reproductive genetics, uterine malformations, frontier research, and so on. So please, stay tuned and enjoy the Congress.
Colleagues, I welcome you with pleasure to the 7th Annual Conference on Recurrent Pregnancy Losses and Human Reproduction. I've been thrilled to be a part of the scientific committee with eminent colleagues, and the content, the meeting is fabulous with a great speaker lineup covering a wide range of topics with most recent findings, and most of it their own research on all the subjects. I'm sure we will all benefit tremendously by attending and joining into the discussions. And I'd like to share my wish that all the wars in Ukraine and elsewhere end promptly, so we can all continue to do our best to help our patients and humanity. And I'd like to take the opportunity to thank to the organizers, Professor Grishenko, Dr. Kazilenko, and Dr. Mikhailishin, and Dr. Kohn for putting this together. Please enjoy the program.
Hello, everybody, and welcome. You are very welcome to the 7th annual conference on recurrent pregnancy loss and human reproduction. This is really amazing that we are now in the 7th Congress. And for those, we started the World Congress on recurrent pregnancy loss, the WCRPL, the same time. And when we finished, the people from Ukraine, Dr. Kuzilenko, asked me to help to build the Ukraine Congress for the East. So it happened there, and it was very successful. I came to each Congress to help and to talk. But suddenly, unfortunately, last year, they have to do it virtual because the war that came to Ukraine by the Russian people, that was terrible. I remember before I started to talk, I was very, very sad for the Ukrainian people. I gave all my support and announced it very, very loudly that this should not happen and the world should help Ukraine and to win this unbelievable war. Now, let me please ask you to listen to me for a couple of minutes before we start. I must talk about the current tragedies now in Israel. 3 weeks ago, Israel woke up to the worst terrorist attack in our nation's history, the most deadly attack on our people since the Holocaust, since the Nazis. We have to understand and admit that those acts by the Hamas are nothing short of Nazis' behavior. 1,400 people were murdered in their houses, in their cities, settlements, here in Israel. 4,800 people were injured. 224 people are still held hostage in Gaza. Women, elderly. I don't want to think what's happening with them there now. Additionally, since that, all over 7,000 rockets have been fired at our civilian population all over Israel, every day, every morning, every night. Life has been very difficult in Israel since the morning of October 7th. Schools, daycares, universities have been put to halt. Everything is closed in Israel. Hospital at Soroka University Medical Center, I have been operating in a bomb shelter, and all births are done in similarly protected areas. Can you imagine? These are realities in Israel, and they are not ones that anyone should have to live with. This affects everyone. And if we don't condemn this together, we will see this terror more and more all over the world. It is already happening. We all remember September 11 years ago with Daesh. People, the same concept, the same ideology. Nowadays and before, it's Nazism. It's the same. The people of Israel, the people of Ukraine are fighting for our independence all over again. Fighting for peace and fighting to protect our people. We pray for a long-lasting peace. I ask you as colleagues and fellow doctors, fearing for the safety of Israel, do not be ashamed in your support of Israel. Do not ever be ashamed of your support for peace. Do not be ashamed to be against Hamas, to be against terror, against Nazism. I want to spend an extra minute talking about the hostages. You can help them. You can help us to help them and make a difference. We, the medical community, cannot be silent on this issue too. Our silence says everything. Our silence lends strength to Hamas, to the terror. We should not do this. We cannot bring back the people who were murdered, hundreds of people, but we can save in Gaza. We can bring them back, and we must from Hamas immediately, without any preconditions. I turn to the participants of this conference, your universities, your hospitals, and the which you belong, that you not be silent, please. Do not be afraid. Show your support for Israel and to condemn the terrible acts of terror committed by Hamas Nazis. Thank you for listening. Now we have to make the shift. So I'm happy to open the first session. First, I will apologize on behalf of Professor Baris Atta, who had something urgent and could not run the session. So I'm here for this session. 4 talks and then the discussion. And we are going to start with the first lecture, Unexplained Infertility, Diagnosis and Treatment. And this will be given by Professor Baris Atta. Baris Atta is a professor of obstetrics and gynecology at Cork University School of Medicine. He is a reproductive gynecological endocrinologist and infertility subspecialty with a master's degree in clinical trials. He in all his studies in America Hospital in London with his master's degree. He was honored several awards from different societies. Also, he took role in editorial boards of various international and local scientific journals like the Human Reproduction and others. And he was also the second chairman of Turkish Society of Reproduction, Endocrinology and Infertility, and many other titles. So I'm happy to start with Professor Baris Atta talk, Unexplained Infertility, Diagnosis and Treatment.
Dear chairpersons, dear colleagues, it's a pleasure to participate in this meeting. My talk is about the evidence-based guideline on unexplained infertility prepared by ESHRE, So we will be reviewing this guideline in the next 20 minutes. Here you see the guideline development group, which represents a multidisciplinary, multinational, and even intercontinental group, because we prepared the guideline together with our Australian colleagues. We followed the well-established evidence-based guideline preparation methodology by ESHRE, which is available on ESHRE's website. What we first do, we describe the questions to be answered regarding effectiveness or safety, and then our research associate at the central office, Natalie, does a literature search by the identified keywords, categorizes them, then we assess the quality and prepare the evidence tables, include our own opinions in hours and days-long discussions, and we prepare a draft of the guideline, which is presented for stakeholder review worldwide for 2 months, and then the comments are reviewed and the final form is given and it is published. You can access it free of charge at the ESHRE website, as well as a summary of it published in the Human Reproduction Open, which is the open access journal of ESHRE. So let me review the terminology we've used in the guideline. If there's a strong recommendation in favor, that means from a patient perspective, the patients will want the recommended course of action mostly, and for clinicians, most patients should receive that recommended course of action, and for policymakers, it means it can be adopted as a policy in most situations. You can apply the same in the other direction when there's a strong recommendation against a course of action. And when there's a weak recommendation in favor or against, let's say, it would apply to majority of patients, but still a substantial proportion may not agree with it. And for clinicians, there may be different choices available, and they would need to spend greater effort in making their own decisions and helping make their patients to join this decision, make their own decisions. And for policymakers, it will require a lot of debate with the other stakeholders. So we divide the guideline to 3 sections. One about the definition of unexplained infertility. The other is how we arrive to a diagnosis of unexplained infertility, and then what's the recommended route of action for management. Let's start with definition. Here you see, when we first started working on unexplained infertility, it is a diagnosis of exclusion. So the diagnosis we came up with was infertility in couples with apparently normal ovarian function, normal fallopian tubes and uterine anatomy, including cervix and the pelvis. To rule out age-related infertility, we limited our work on women who are 40 years or younger, and to couples who have adequate coital frequency. The definition may vary slightly, we'll discuss later on. And the male partner should have normal testicular function, genitourinary anatomy, and a normal ejaculate. So the definition of infertility follows the ICMAR and WHO, 12 months of regular unprotected sexual intercourse before investigations are initiated. And we regard the regular menstrual cycle as one that lasts 24 to 38 days, up to 8 days in duration of bleeding, and shortest to longest cycle variation was less than 7 to 9 days based on this reference. And what we recommend to see, for seeing if a couple meets these definitions, in every case, routinely a medical, reproductive, and sexual history should be taken from both the male and the female partners, and there should be at least one basic semen examination using the WHO criteria by an accredited laboratory. If the results from this first basic semen analysis is below the lower 5th percentile, which is presented as a reference limit in the WHO manual, a second analysis should be performed like 3 months later to see if it's a personal abnormality, because semen analysis values fluctuate enormously. So there was the definitions we used to call a couple with unexplained fertility. Here, it's a couple's problem. Then how do we make this diagnosis? How do we decide if a woman is ovulatory? So which tests would be required? Actually, in a woman with regular menstrual cycles, tests for confirmation of ovulation are not routinely recommended. It's called as a good practice point because there's no studies looking at this, and there's probably no equipoise to conduct such a study. And as the guideline development group's opinion, that's our conclusion. If a woman has predictable normal menstrual cycles based on the former definition, then we don't think additional tests to confirm ovulation occurred is necessary. If for some reason you think it is required, you can use folliculogram, you can use urinary LH measurements, or a mid-luteal progesterone measurement. Is there a test that tells us the quality of corpus luteum? Quality is a pretty vague term, which I don't like really in the context, but in women who have regular cycles, who are assumed to be ovulatory, we do not recommend measuring serum progesterone levels to make a decision about, or to make inference about corpus luteum quality by progesterone measurement. Again, progesterone levels vary, and they don't necessarily translate to clinical outcomes. And there is no need to do an endometrial biopsy in the absence of another indication. Obviously, if you have reason to think she may have endometrial hyperplasia, if you need biopsy, that's a different story. But in a couple looking at unexplained infertility, there's no recommendation. Actually, there's strong recommendation against doing an endometrial biopsy. There are many studies showing that in phase, out of phase, etc., assessments are not relevant in the context. So how about ovarian reserve? There are always discussions about whether a low oocyte quantity reflects a lower quality per oocyte. Now, in terms of fertilization rates, fluctuation rates, reploidy rates, implantation rates, etc. Actually, when we review the available data, that association is not apparent. And decreased ovarian reserve per se, in most cases, does not explain the cause of infertility. So, from a diagnostic standpoint, an ovarian reserve test is not required. However, when someone does a pelvic ultrasound, you obviously see the antral follicle count. It may be on the lower side, but I don't think it justifies terrorizing the patient or blaming the woman just because she has low number of oocytes, follicles. It doesn't mean her oocytes are of lower quality, and that is necessarily the reason for the infertility problem they're going through. So, diagnostic standpoint, no indication for ovarian reserve assessment. Planning management is a different story. I'll come to that later. So, about tubal factor, imaging studies are required. We can't see normal tubes, and HSG, the former standard of care, it seems the new sonographic contrast, hysterocontrast sonographic assessment of tubal patency provides us equivalent results when done properly. So, strong recommendation, you can choose any of them depending on your clinical conditions. And the selection depends on yours and patient's choices. In settings where these are costly or not easily accessible, in the absence of a risk factor for tubal occlusion, like history of pelvic surgery, in presence of severe endometriosis, you can use a chlamydia antibody testing, which would be the most common reason for tubal blockage in the absence of these other risk factors, as a screening test to identify which woman would require an imaging test for the tubes. So it depends on your clinical condition. But if there's a risk factor for tubal occlusion, then chlamydia antigen testing is not recommended. We need visual demonstration of tubal passage by one of these methods. Uterine factor. Uterine anatomy should be normal, and a proper vaginal ultrasound shows us all relevant aspects of uterine anatomy. If you have access to a 3D vaginal probe, it's easier to see, it's easier to show someone else. It can be preferable, but you wouldn't need additional imaging methods unless there's an indication of suspicion. And if the ultrasound assessment is normal, there's no need for routine assessment of cavity like saline infusion, hysteroscopy, etc. But if there's a risk factor for intracavitary problems like history of pregnancy losses, intracavitary instrumentation, then it's a different story. It should be a case-by-case basis, but routine diagnostic hysteroscopy or routine saline infusion sonography are not recommended in the absence of risk factors and a normal ultrasound assessment, proper ultrasound assessment of the uterus. A routine diagnostic laparoscopy is not recommended, but we think the evidence is strong in that regard. And is there any additional female lower genital tract tests that could be required today? Don't see a role for the postcoital test. And while vaginal, possibly cervical or uterine microbiota may play a role, the available evidence is short of showing it. The optimal diagnostic of testing method is not agreed upon. So it could be done in a research setting, but for directing clinical practice, we strongly recommend against microbiome testing for explaining the etiology of infertility or planning any treatments for that regard. For the male, as the definition of unexplained infertility requires a normal WHO semen analysis, then if the coital function is normal as reported by the couple, there's no need for testicular imaging or further examination. There are a variety of sperm and semen tests that are being actively marketed or used. You come across them in most meetings. Research setting aside, for routine clinical practice, we recommend strongly against anti-sperm antibody testing, sperm DNA fragmentation, sperm chromatin condensation test, or sperm aneuploidy testing, or male hormonal testing, or HPV testing, or a microbiological analysis of the seminal fluid. So academically, they can be all discussed, but currently available evidence does not suggest a benefit for directing clinical management, so they're not indicated for the diagnosis of unexplained infertility. Any additional tests, autoimmune tests, we do not recommend to explain the etiology, either thyroid antibodies or anti-sperm antibodies. The recommendation about celiac disease is there are studies suggesting that couples with unexplained infertility, female partners, may be more likely to have celiac disease. It's a very simple test. It may be low yield or high yield depending on the population, but it may be considered at least questioned and offered to the couple, not to treat their infertility, but to identify an accompanying problem. And the TSH measurement, as long as the patient is ovulatory regularly, there is no indication for TSH testing, but in most guidelines, a preconceptional TSH testing to identify, to diagnose obscure hypothyroidism, which may affect fetal development, is good clinical practice. That's why we said it's a good practice point to do a TSH measurement in any woman contemplating pregnancy, regardless of fertility, infertility status, or the planned route of action. But if TSH is normal, we don't think additional tests, either hormonal or imaging, is required. Thrombophilia is irrelevant in the context. No tests are required. We recommend strongly against them. Oxidative stress tests may be relevant for research. Anything can be relevant for research. But measurement of oxidative stress or the overall inflammatory status of the female partner is not recommended for clinical practice, routine clinical practice. While in the future, I strongly think genetics will explain most of the unexplained infertility, but at the moment, from a therapeutic or diagnostic perspective, it's not recommended routinely at this stage. And testing for vitamin D is not recommended to explain the etiology of infertility problem. Again, in a regularly ovulatory woman, there's no need to do a prolactin test. And BMI, again, is part of physical examination and preconception assessment. It's good clinical practice to measure BMI. So here's the diagnostic summary: menstrual history, uterine anatomy assessment with preferentially 3D, but mainly with ultrasound. A tubal passage should be assessed with HSG or HICOC, and the semen analysis should be assessed using WHO criteria. Now, how to manage a couple with unexplained infertility after these assessments? The first thing is, pregnancy and live birth requires the healthy egg and healthy sperm. It doesn't happen in every cycle. While 12 months are required to make a diagnosis, just hitting the 12-month benchmark does not mean this couple has no other chance of spontaneous pregnancy. So expected management can be considered in based on the couple's prognosis, which can be calculated by the Huno model, which is freely available on the internet. But in general, when intervention is justified, required, or by definition unexplained infertility per se, the first-line treatment that can be offered to any couple, is discussed with any couple, is ovarian stimulation with intrauterine insemination. Under the age of 40, nobody is ruled out directly. And there's strong evidence behind this, multiple RCTs showing that ovarian stimulation with IUI increases the chance of pregnancy in a certain time period. It makes it faster. And we didn't mention the ovarian stimulation protocol, but most parts of the world, strict cancellation criteria in some form are employed. The risk of multiple pregnancy is important in IUI cycles, ovarian stimulation IUI cycles. Once you limit the number of growing follicles, you can use oral antiestrogens or gonadotropins. If you're using gonadotropins, we should be particularly cautious about ovarian hyperstimulation and multiple pregnancy. Low-dose regimen, low-dose step-up regimens with proper monitoring is recommended. IVF is not necessarily better than IUI. It depends on how you compare how many cycles of ovarian stimulation IUI versus how many IVF cycles, or how long a period for spontaneous pregnancy attempts. So that's why it's conditional. It's not necessarily prioritized. So IVF as a first or second choice should be individualized. ICSI is not routinely recommended if the couple chooses to undergo an IVF. Mechanical surgical procedures. Intracavitary pathology like polyps or fibroids may affect fertility, may affect the chance of pregnancy. But as per the definition of unexplained infertility, if the initial ultrasound does not suggest the presence of these pathologies, routine further imaging is not recommended. Tubal flushing as a treatment is mentioned as conditional. Here's the reason. Studies consistently show if an oil-soluble contrast is used for HSG, it may increase the chance of spontaneous pregnancy for the cycle and even the next cycle. Perhaps over a water-soluble contrast. But oral soluble contrast are more allergic, and HSG is mainly done as a diagnostic procedure, not as treatment, so the risks and benefits should be considered and discussed with the patient while for choosing the contrast medium if an HSG is to be done. About minimal mild endometriosis, we recommend it against routine diagnostic laparoscopy. But if the patient underwent laparoscopy for a different reason, the beneficial effect of ablation of minimal mild endometriosis is controversial. And then the patient would be diagnosed as having endometriosis, so wouldn't be a case of unexplained infertility so far. That's why we did not elaborate any further on that. You can refer to the ASHA endometriosis guideline. Clearly, there's no indication for endometrial injury or scratching to improve the chance of spontaneous pregnancy as a treatment for unexplained infertility. There are a lot of alternative medicine practices around the world, antioxidants, so it's conditional, it's not routine, we don't recommend testing for it, so necessarily, by implication, treatment will not be prioritized. Acupuncture is an umbrella term, it depends on how it is done. While few studies looked at it, the data is not strong enough to suggest it as a treatment. Nutraceuticals, psychotherapy, they do not necessarily improve fertility, but psychological support is important and it may be recommended to the patients, and diet, exercise, and behavioral therapy. So good diet, exercise is recommended for anyone anyways, so they are included. And we should always consider the quality of life and not stress people and not subject them to a lot of unnecessary, unproven interventions. And here's the summary of the management: consider prognosis, then discuss expected management. If prognosis is good for a certain period, then IVF should be individualized. And if it's not good prognosis for spontaneous pregnancy, the first line would be overstimulation IUI. And you see like 3 to 6, we say because there's no data. After a number of failed cycles, the couple can opt to go for IVF, and healthy diet, regular exercise is recommended for anyone. Behavioral and psychological interventions may be useful. So these are the research priorities we've come up with. Okay, so how to do best ART protocols, and how can we have better predictive models to assess the chance of spontaneous pregnancy and pregnancy with other interventions. So these are our conflicts of interests, and thank you for your attention. I'm happy to answer any questions.
Yes, so thank you to Professor Barisata. We will have everybody in the end of the session, in the end of the talks, with a discussion. Now we move to the second talk. This is going to be given by the well-known Professor Ole Christiansen from Denmark, a very good friend, who is part of the World Congress on recurrent pregnancy loss, the WCRPL, for many years. Professor Christiansen will give us the overview on RPL guidelines 2022 by the ESHRE. Professor Christiansen is a clinical professor in obstetrics and gynecology at the Aalborg University Hospital and consultant to the Department of Fertility, to the Julian Maurice Center in Rigshospitalet, Copenhagen University Hospital. Please.
Good day, my name is Ole Christiansen. I'm a professor at Aalborg University Hospital, and I thank the organizers for having invited me to give this presentation about the recurrent pregnancy loss guideline produced by the European Society of Human Reproduction and Embryology, ISRA. I have nothing to disclose. The Guideline Development Group started its work in 2013, and originally it comprised the persons listed in the upper part of this list. And later, when the guideline was updated in 2021-22, some new members listed below were added. Each member focused on a specific area of recurrent pregnancy loss. I took care of the topics of RPL and immunology and unexplained RPL. However, the final guideline was approved by all members and also by the ISRA Executive Committee. It's a huge work to perform such a comprehensive guideline. The work started in 2013, and after a lot of meetings in the guideline group, the first version was published in 2017, and after further virtual meetings in the group, the updated guideline was published in January of 2023. For me, the most controversial statement in the guideline was that RPL was now defined as only 2, not necessarily consecutive pregnancy losses. I was very much against this definition because it will include a lot of women who had 2 pregnancy losses just by chance due to embryonal aneuploidy, including such women in the guideline is not good. I think we should concentrate our limited resources on patients with a higher number of pregnancy losses, and including such women with a good prognosis in clinical trials, such as case control trials, will clearly dilute the associations between risk factors and RPL, and including such women in treatment trials will clearly dilute the effect of the treatment being tested. However, the majority of the guideline group voted for this new definition. However, the definition is not approved by several specialist societies such as the Royal College and the German Society for Obstetrics and Gynecology. A good aspect of the new guideline was that biochemical pregnancy losses, so-called non-visualized pregnancy losses, were now included in the definition. The updated guideline comprises 177 pages with 77 recommendations, and I have no time to go into all these recommendations, but have to concentrate on the most controversial recommendations and significant changes in the updated guideline. When the first guideline was published in 2017, my impression was that many researchers and clinicians thought it was very conservative because it rejected a lot of investigations and treatments already implemented in clinics and laboratories. Here is listed some of these investigations deemed to be useless in the guideline. Routine genetic testing of aborted tissue should not be undertaken. You should not do parental karyotyping. You should not test for hereditary thrombophilia. You should not test for NK cells, cytokines, HLA polymorphisms, and you should not routinely test for PCOS, androgens, prolactin, ovarian reserve, or luteal phase defects. The reasons for these non-recommendations were that too few and small relevant studies existed, the results of the studies were divergent, and if you had an investigational risk factor that had proven validity, no proven therapy existed for the risk factor. In the new updated guideline, some new recommendations were included. Now it's recommended to evaluate the woman's prognosis based on both age, number of previous pregnancy losses, live birth, and now also their sequence. This change was based on a large population-based study by Colte et al., finding that the sequence of the pregnancy events were very important for future outcome. It was now also recommended that you could consider testing for antinuclear antibodies, and you should also consider a 2D ultrasound scan to rule out adenomyosis. And in recent years, there have been increased focus on the male contribution to RPL, so therefore now also it's recommended to assess lifestyle factors in the partner, and you could also consider assessing sperm DNA fragmentation in the male partners. In an ever-changing world, it's important to emphasize that some investigations were still recommended in the updated recurrent pregnancy guideline. Is still recommended to screen for lupus anticoagulants and anticardiolipin antibodies after 2 pregnancy losses. You can still consider to screen for beta-2 glycoprotein 1 antibodies after 2 losses. You should still screen for thyroid stimulating hormone and thyroid peroxidase antibodies in RPL women. And if the findings are abnormal, you should screen for other thyroid gland factors. And you should still make an assessment of the uterine anatomy, preferable by 3D ultrasound scan in these women. When the first guideline was published in 2017, many were shocked to see all the negative recommendations concerning treatments of RPL. It was recommended not to use progesterone treatment or HCG treatment, not to treat with metformin. It was recommended not to use PDTA or PDT-SR. It was recommended not to use anticoagulation treatment except in antiphospholipid antibody syndrome. It was recommended not to do surgery on the uterus. Immunotherapy was not recommended. It was recommended not to do endometrial scratching or use antioxidants in the male partners. And the reason for all these non-recommendations were, again, that too few and too small relevant studies were published and the results were too divergent. Due to publication of some high-quality multicenter randomized control studies, some new recommendations were included in the updated ISRA guidelines about treatments. 2 multicenter randomized control trials have been published testing the use of levothyroxine to women with TPO antibodies who were euthyroid. And none of these studies found that levothyroxine increased the live birth rate. So therefore, this treatment is not longer recommended to euthyroid women with TPO antibodies or subclinical hypothyroidism. A large, high-quality Japanese randomized control study tested the use of high doses of intravenous immunoglobulin to women with 4 or more pregnancy losses when treatment was started in very early pregnancy, and it found that the live birth rate was significantly increased after this treatment. So this treatment can be considered for women with 4 or more pregnancy losses. Combining results of 2 multicenter randomized control studies in the UK showed that treatment with vaginal progesterone weakly but significantly increased the live birth rate in women with recurrent pregnancy loss, 3 or more losses, and vaginal bleeding in the pregnancy. So this treatment can also be recommended to these women. And lastly, a couple of studies showed that a special variant of ICSI called PICSI, where sperm are selected by special methods, can decrease the risk of pregnancy loss in infertile women. It's still not documented that this treatment is also beneficial in RPL women, but it should be tested in the future. In the updated guideline, some treatment recommendations were maintained from previous time. Still, women with antiphospholipid syndrome and a history of 3 or more pregnancy losses should be treated with low-dose aspirin from before conception, and they should be treated with heparin in prophylactic doses from the day of a positive pregnancy test. Also, women with overt hypothyroidism should be treated with levothyroxine from before conception or during early gestation. For researchers, the most interesting parts of the updated recurrent pregnancy guideline is the sections about which research areas should be prioritized in the future in recurrent pregnancy loss. And concerning the definition of RPL, which is controversial, studies should be performed assessing whether associations of risk factors or effects of treatments changes will change definition, whether effect of treatments are stronger in women with 2 pregnancy losses compared with women with 3 or more, as an example. Also, in the area of organization of care, it's important to develop better models that are better than previous models, can predict the chance of live birth in an individual couple with RPL. And such new models should include sequence of pregnancy events and also some validated biomarkers. It's also important to develop online tools for support to couples with RPL and staff. In the area of genetics, there is a need for more research in several areas. It's important to clarify whether performing PTTA in couples with RPL will enhance their prognosis, and it's important to clarify whether genetic analysis of pregnancy loss tissue provide information that can improve the pregnancy prognosis for the couple in the next pregnancy, and it's important to do cost-effectiveness analysis of parental karyotyping. In the area of thrombophilia, there's a lot of important research areas that should be explored. I here highlight the two most important areas that should undergo research. Randomized controlled trials should study the effectiveness of heparin treatment compared with placebo or no treatment in patients with antiphospholipid antibodies. No such really placebo-controlled trial have been performed. In these patients, it's also important to evaluate the effect of hydroxychloroquine to patients with RPL with and without antiphospholipid antibodies in randomized control studies. In the area of immunology, I think the most important research areas are performing a randomized controlled trial of use of moderate dosages of prednisolone in recurrent pregnancy loss. And it's also important to do studies, prospective studies, or randomized controlled studies of the effect of immunotherapy in women with RPL with or without selected immunological biomarkers that could be specific HLA class 2 alleles. Concerning the area of metabolic factors in RPL, I think that there's no need to do more studies of levothyroxine to women with subclinical hypothyroidism or TPO antibodies, because two large high-quality studies have clearly shown no effect of levothyroxine in these women. In the area of uterine malformations and recurrent pregnancy loss, almost no randomized studies have been undertaken. Only one randomized study have been published. It was of poor quality, but it showed no effect of removing uterine septum by hysteroscopy. I think in the future, uterine surgery in RPL women should only be undertaken in the context of randomized controlled trials. There have been increasing focus on male factors in recurrent pregnancy loss in recent years, and there's a lot of important research areas in this area. I think the most important is prospective studies studying the impact of male lifestyle alterations with outcomes both of sperm DNA damage per se and also of pregnancy outcome after RPL. And I think it's also important in randomized controlled trials to study the effect of combinations of antioxidant and vitamin therapy for men on the protection against sperm DNA fragmentation and also with regard to pregnancy outcome after RPL. I think it's also important to do randomized controlled studies of the use of PIXI as a treatment to improve pregnancy outcome in women with RPL and where the husband has increased sperm DNA fragmentation. And finally, in the area of female factors in RPL, I think there's a strong need for prospective study of the effect of preconceptual weight loss on live birth rate in these women. And there's also a strong need to do prospective studies of the role of chronic endometritis in women with RPL. And there's also a strong need to do randomized controlled trials of antibiotic therapy to women with this diagnosis. And finally, I thank the ISRA for the huge support for producing this guideline and for the good collaboration between all the members of the guideline development groups in all these years the work have been performed. Thank you for listening. Thank you.
Yeah, thank you, Professor Christiansen. This was really an excellent overview, and everybody can see that we are still struggling controversies, looking for evidence-based medicine. But this is the way. We still will focus, do research, and of course improve our recommendation. And now we move to the last talk in this session. We are going to hear Professor Tom Bournet. He's going to speak on psychological impact of recurrent pregnancy loss. What should we be aware of? This is becoming more and more very critical part in all the evaluation and treatment of recurrent pregnancy loss. And we will go into it in the discussion. I can say right now that I really hope that this will be a clear path for all the evaluation of those couples. So Professor Bournet is currently the chair in gynecology at the Imperial College in London and hand consultant gynecologist at Queen Charlotte and Chelsea's Hospital in London. Professor Bournet has an international reputation for the use of ultrasonography in gynecology, including assessing early pregnancy problems, miscarriage, or ectopic pregnancy. He has extensive experience in the use of ultrasound to assess the ovaries for the presence of cysts and to either diagnose or exclude ovarian cancer. In general, he offers a one-stop approach using ultrasound to make a diagnosis and plan management. Let's go, please.
My name's Tom Vaughan. Just want to thank you all for inviting me to this important meeting on miscarriage. I've been asked to talk about the psychological impacts of miscarriage with recurrent pregnancy loss, but I'm principally going to describe some data on sporadic miscarriage. However, I'm absolutely sure this applies to recurrent pregnancy loss as well, and I'll show you a little bit of data to support that view. So I'm just going to share my screen and go to full screen. And there we are. So once again, thank you for having me again. I enjoyed the meeting last year and look forward to the one this time round. I'm struggling perhaps to be there in person this time, but hopefully you'll find this lecture of interest, though I will try and get online for questions if possible. So we have here Frida Kahlo, one of the greatest artists of the 20th century. And you can see she was a tough woman. She had a bus crash when she was younger. That meant she had surgery. She had metal rods put into her spine. And you can see these pins stuck in her body for her represent the pain that she went through throughout her life. So this is someone who's pretty resilient. And I think that resilience comes through in this self-portrait. However, here we have a picture again by Frida Kahlo of when, unfortunately, she had a miscarriage at the Henry Ford Hospital in Detroit. And I think this tells you everything you need to know about how someone or woman feels following a loss. And I don't think any data that I show will be as eloquent as this Frida Kahlo here lying in a pool of blood on her bed. This is the perfect baby she never had. The snail pace, the doctors she felt moved when trying to help her, the pelvis that had failed her, the flowers her husband Diego Rivera gave her, and the machine that took her baby away here. She was a fabulous artist, and I think in this picture she really does evoke the raw emotions that people feel when they lose their baby. However, we don't deal in pictures. We tend to try and deal a bit more in science. When we first looked at this, as we do, we did a systematic review to try and look at what the evidence base was when we were considering doing studies on the psychological impact of early pregnancy loss. And here is our systematic review published in HR Update back in 2018 now. But what was striking at the time was that there were not that many studies. In fact, there were only 2,500 women included in studies who had had a miscarriage, very few partners. And essentially, the systematic review identified that there did appear to be a significant risk of psychological morbidity following miscarriage, but there are large prevalence and variations in prevalence. We knew nothing really about the likelihood of post-traumatic stress, and most of the studies didn't control for future losses or having successful pregnancies in the follow-up period, and most of the data was pretty old. However, it did show relatively high levels of anxiety, depression, and possibly high levels of post-traumatic stress, of which one study was actually one of ours. Lower anxiety and depression in partners as well was identified. So not a huge amount of information. So we went on and did a pilot study. So 186 women, 128 with early pregnancy loss and 58 who had ongoing pregnancies as control group. And we're only considering here in the results moderate to severe psychopathology. And we used the HADS and the post-traumatic diagnostic score. And essentially, these are the results. We looked at the prevalence of post-traumatic stress, anxiety, depression at 1 month and 3 months after a loss compared to controls. And you can see that there were significantly high levels of anxiety at 1 month. And this does reduce a little at 3 months. Depression is relatively high at 1 month, but actually goes down pretty well to what you might to control levels 3 months after the loss. But the standout message of this pilot study was very high levels of post-traumatic stress, 1 month, and then very high levels at 3 months. So this appeared to be a persisting problem. And I'll come on to post-traumatic stress and what it is in a moment, but it is extremely debilitating and a major, major issue if you want to get on with any kind of normal life. So this, when it was published, hit the newspapers in quite a big way. It was picked up from the North Korean Times here to in France, in Delhi, and so on. And it seemed to strike a chord. It wasn't that we didn't push this paper out, but and it did evoke a lot of response from women who were commenting in the newspapers. There were magazine articles. And it seems as if people had almost been given permission to talk about their experiences of miscarriage and how it haunted them for years and years afterwards, despite the fact this was actually quite a small pilot study. And we were concerned also that the very high levels of post-traumatic stress that we found were in some way anomalous. So we went on and did a larger study. This is published in the American Journal. Again, looking at post-traumatic stress, anxiety, and depression. It's a multi-center cohort study. A bigger study, we approached over 1,000 consecutive women, and 737 agreed to be recruited. And we also recruited 171 consecutive women with a healthy pregnancy and 192 partners. And again, we used the HADS and the post-traumatic diagnostic scale. And there was a certain amount of dropout, as you would expect, but I think still the results are meaningful. And again, you can see it. Now, we scored these scales, particularly for post-traumatic stress, as in as tough a way as we could. In other words, to try and have the least amount of pathology. But despite that, if you look at anxiety, there is a significant increase in moderate to severe anxiety. 1 month, as you can see here in green, that persists to 3 months, but still is present over control levels 9 months after the event. Depression, as we've seen before, does increase, but tails off by month 9, albeit it's about 3 times higher than in the control group. But it isn't a major proportion of the population. However, post-traumatic stress, once again, 29% of these of the women had moderate to severe post-traumatic stress symptoms 1 month after a loss. 21% persisted at 3 months, and still 9 months after a loss, women still had post-traumatic stress in almost a fifth of cases. 21% for ectopic, 16% for miscarriage. And this is a very high number, in my view. It's quite shocking. So you can see, and it seems that there's just a group of women who do not get better. And just remember this number of about 20% not resolving and continuing to have problems 9 months to a year after their loss. And we have controlled here for future, I can tell that this is persistent even if we control for future pregnancies or not getting pregnant. In terms of risk factors, are there people who are particularly at risk of this type of morbidity? Well, how they feel, do they feel responsible, or do they worry about well-being, having a previous psychiatric disorder perhaps, but none of these are deal breakers when you look at the AUCs. I mean, they're not over here at 0.9. Previous losses, time to conceive, and the final management does appear to have an impact, how the patients are managed, how long it took them to get pregnant. So I think this is these are not super important, but actually do matter. And you can tell in the context of recurrent pregnancy loss, previous losses are a risk factor, but they're not overwhelming when you look at the AUC result. I think it's important that you remember what post-traumatic stress is. It's really intrusive. You know, it can be accompanied with intrusive events, nightmares, flashbacks, sort of stuff you see on television relating to people who've been in the army. Avoidance of distressing memories, problems concentrating, irritability, aggression, risky or destructive behavior, lack of interest in activities. I mean, really, really difficult to live with. And this is associated, of course, with finding it difficulty to work, losing your job, relationship breakdown, and so on. So I think it's something all of us who are looking after women who suffer from pregnancy loss have to be very, very aware of. You know, if a fifth of the people you are treating potentially have a cumulative post-traumatic stress, then this is something that we really need to be taking some sort of interest in. And I'm just going to show you this paper, which has it's not relevant in terms of being to do with miscarriage, but this is a paper from Jerry Vista's group, and they looked at post-traumatic stress using slightly different measures. But this is following termination for fetal anomaly, following women up at 4, 8, and 16 months. And again, you can see massively high levels of post-traumatic stress at 4 months, 8 months, and again, the same number, 16 months, almost a year and a half after this event, 20% of these women still had post-traumatic stress symptoms. So in other words, this 20% number seems remarkably consistent and actually chimes with experiences in the armed forces, where people estimate about 20% of soldiers will have post-traumatic stress symptoms. So, you know, I think this is likely to be a number that comes up again and again. And even perhaps more worryingly, this is perhaps somewhat methodologically weak. The same authors looked at the people in the present study, remember, 40 down to 20% at 16 months, and retrospectively, subsequently, they went back and looked at the levels of post-traumatic stress 2 to 7 years after the event, and this 20% had not changed. In other words, these people did not get better. And post-traumatic stress, as I've tried to describe in terms of the symptoms, is a baleful, really difficult problem to live with. And you can see this is in post-traumatic stress in a general population. So again, this is not related to miscarriage. But again, if you look, persistent post-traumatic stress, 1 year, 2 years, 5, even 30 years after the event, you can see that you can get persistent post-traumatic stress years and years after the event if there has not been any type of intervention. So you can see how, if you have, for example, in the UK, 400, 500,000 women having a miscarriage each year, how each year you're accumulating more and more people, potentially, who are quite significantly impacted psychologically. So what about partners? We looked at our subgroup of 192 couples. All, it so happened, all the partners in our study happened to be male. Remembering that other studies suggested that men are less likely to have negative psychological outcomes. Excuse me, sorry. And you can see, look, how it turns out. Post-traumatic stress, as we remember, the 21%, 9 months after the event, moderate to severe post-traumatic stress symptoms. 4% in partners. So 7% of partners have post-traumatic stress symptoms at 1 month, 8% at 3 months, and 4%. So let's just call that about 5. So that's 1 in 20 partners have moderate to severe post-traumatic stress symptoms. 9 months, so almost a year after the event. So it's not insignificant. It kind of looked like a small number, and it's definitely less than in the women in this study, but it's certainly significant. And they do have a certain amount of anxiety, not as much depression. So partners do have problems following miscarriage. But you'll see there's a big difference between the women and their partners. And this can also be problematic because they are grieving in different ways, potentially. I'm not saying this is the last word, because there are probably other things going on here that we're not measuring with the measures that we've used. I also think it's worth pointing out to you that just because people haven't crossed the threshold to make a diagnosis of post-traumatic stress disorder doesn't mean that they're not having problems. So if you look, for example, at women and look at the variables when we ask people, you know, are you helpless, terrified, sorry, hang on a minute, having problems with your relationships with family, etc., etc., you can see that in the women, 79% are having all these symptom clusters for post-traumatic stress. They're having problems dealing with their work, relationships with family, friends, sex life, very high proportion. And actually, a fair number of the partners as well. You can see overall functioning 20%, satisfaction with life, you know, and so on. All of these are being interrupted in both the partners and the men in a substantial number. And many, many of these will not cross the threshold to sort of have moderate to severe post-traumatic stress symptoms, for example, as we've discussed in the previous data. So not meeting a threshold does not mean that you're not ill or struggling a bit. You're just not probably struggling quite as much. Just want to tie this in to recurrent miscarriage, which is obviously the topic of this conference, because there's not quite as much work on that. But here we had 2023, relatively small paper. As you can see, it's in the German literature, but 105 couples and 17 women with recurrent pregnancy loss. And in this study, post-traumatic stress, 14% present and 4% of men. So slightly lower than us in our study, but significant. And so I think you can see from this study, albeit in relatively small numbers, that, you know, 1 in, you know, in sort of 1 in 15 or so, women will have a significant psychological problem. And you can see here that they found that high levels of premorbid anxiety, depression, lack of social support was positively correlated with post-traumatic stress as well. For women, and that was in the partners, for women, number of curettage, number of losses also correlated with the severity of post-traumatic stress. So you can begin to perhaps, in this particular group of women, start looking at a higher risk group that you need to screen or be aware of for post-traumatic stress in your clinic. And they conclude, as we would, that post-traumatic stress is an issue, and recurrent pregnancy loss clinics should consider assessing the post-traumatic stress risks and also diagnosis as part of routine diagnostic process. And that's something I think all of you should think about. If you look at problems from a societal point of view, marriage and cohabitation outcomes after pregnancy loss, we know that there is a significant difference between women who have a good pregnancy outcome and those that have a stillbirth and a miscarriage. There is a gap. And that gap is probably, in my view, because of post-traumatic stress, because we know post-traumatic stress is associated with relationship breakdown. So I know that's a bit of a leap and I can't prove that, but again, it just plays into the fact that this illness can have a huge negative effect on the individual, but also on relationships and therefore on society. And just saying something about numbers, if you look at the States, about 4.5 million confirmed pregnancies each year, 900,000 or so will be lost. If you say that 20% of women might have moderate to severe post-traumatic stress symptoms that may last this long, just imagine how many women are accumulating each year over time who are potentially not getting better if there's no intervention. It's a big deal. So just a few things about what we can do to impact on this. Well, first of all, we can talk about language. This is Katie Linterman, who's a commentator and writer. And I thought she wrote a really good article. Doctor, don't call my lost baby a product of conception. And she made the point that a lot of the nomenclature we use in the pregnancy is about failure, incompetent cervix, failed pregnancy, blighted ovum. Think about language. And I think we need to start using different words. So we must stop using these and talk about miscarriage. We must stop spontaneous abortion is freighted with emotion. Pregnancy tissue, the baby, embryo, but not products of conception. Stop using evacuation of retained products. We talk about now surgical management of miscarriage, and so on. Think about slightly more sensitive language. Women do not like these terms. Everything we do when we're dealing with women potentially can impact on the psychological on how they're impacted psychologically. And so when we're seeing people and giving bad news, if we're talking about their baby, we don't talk about products of conception. We don't talk about evacuating their retained products. We talk about their baby. We talk about surgical management, and we talk about miscarriage. And I think people who, for example, are editing journals should start making sure that this language is changed and standardized everywhere. Language that minimizes the loss as well is not helpful. Women are not or do not like being told, well, it happened earlier, you're young, at least you know you can get pregnant. This is unhelpful. Just sometimes it's better just to say, look, I'm really sorry what's happened. You don't need to say the extra thing which you think sometimes makes them feel better. What about counselling? Well, there's a big Cochrane review, and interestingly, the Cochrane review showed following pregnancy loss, there's insufficient evidence that psychological support is beneficial. But the problem with this is that most studies, counselling is not specific and is probably not directed towards the people who need it. Because a lot of women obviously will be fine with non-specific counselling, support from pregnancy loss charities. However, if they have post-traumatic stress, they need specific intervention, for example. And so if we consider how we might impact on that, Interestingly, this is a pilot study of reducing intrusive memories using a brief cognitive task. And this brief cognitive task is playing the computer game Tetris at an interval after the trauma has occurred. So this is trauma-exposed emergency department patients. And you can see the number of intrusive memories are reduced in the intervention group compared to the control group. So this is specifically targeting intrusive memories. So we have a situation here where, where using Tetris as a cognitive task can stop these intrusive memories being embedded. We're carrying out a trial now using Tetris. So you have to speak with the patient, remind of the memory. They play Tetris, which I know sounds ridiculous. They have to mentally rotate the shapes on the screen in their mind. And it seems that this has an impact on how these memories are embedded. And 43% of women report, 43% of women report having unwanted intrusive memories following a loss. So far in the trial that we're carrying out, we found that there has been a significant reduction in intrusive memories and therefore a reduction in post-traumatic stress. So we can intervene potentially and actually reduce the likelihood of some of these post-traumatic stress impacts. CBT following miscarriage. This is an internet-based intervention, because if we're going to give cognitive behavioral therapy to women after a loss, it's got to be practical. And I think the only way to do that, given the numbers of women involved, is if it's internet-based. And you can see in this study, there was a significant improvement in post-traumatic stress and prolonged grief, which was sustained over 12 months. So in other words, we can try and prevent this with interventions such as the Impel study. And then if we screen women and we find that they have post-traumatic stress, an internet-based intervention and cognitive behavioral therapy can show significant improvement, which is sustained over time. And so we do have a probable intervention. I'm just going to say one thing about you, actually, about people who are looking after patients who have early pregnancy loss. This is a study we carried out about burnout in doctors or obstetricians and gynecologists in the UK. And I just want to make the point that we found that 36% of gynecologists in the UK met the criteria for burnout. We've just repeated the study after COVID, and it's now 70%. And this is a problem. And it's a problem because you need to be aware that you need to look after doctors who are looking after patients with pregnancy loss, because if they're burnt out, they are unable to empathize. You have an increased incidence of patient safety incidents and an increase in unprofessional behavior. But more than anything else, people with burnout struggle to show empathy. And I think when you're looking after people in early pregnancy or who've lost pregnancies, this is an issue. So I'm just putting it out there that you should be aware of burnout, perhaps even assess it in your units and take steps to make sure that this does not become a problem, because you can't provide the best care if the clinicians are burnt out. You get lack of empathy, it impacts on quality of care, patient safety, and patient experience. So just to summarize, an awful lot of women will have moderate to severe psychopathology after a loss. Post-traumatic stress is the big issue, anxiety, depression, and probably other things as well. At the moment, really, it's not taken as seriously as it should do. And I think the message I want to get across to you, and I'm just going to move on. The message I want to get across to you is that, in my view, clinics should take post-traumatic stress particularly seriously and be aware of the psychological impact of losses in the women that you're seeing in your practice. I mean, just to emphasize the point, here we have Frida Kahlo. Frida Kahlo sadly never successfully had a successful pregnancy. And in paintings, a doll here represents her baby. So here you have Frida Kahlo here some years later, and she's sitting here symbolically with the baby that she never had. She never, ever moved on from the loss of the losses that she had. And I think we can't always help women who sadly either can't have children or recurrently have miscarriages, but we surely can try and pick up the women who have severe psychological problems and make sure that we do the best that we can to treat them and make sure that they can, at least, we can manage the grief and potentially the post-traumatic stress that they have. So that I'm going to stop sharing my slide and just come back and say, so what can we do moving forward? I think we have to think in the future about how we manage every aspect of the care of these people. Is surgery better than expectant management for miscarriage? And how do we individualize that care? Is MVA going to traumatize some people? Will it be okay for others? How do we reduce the impacts of these things? How can we best make what is an awful experience for many women, at least as reducing the trauma as much as possible? I think we are now beginning to see interventions where we can maybe reduce the trauma by reducing the intrusive memories, by stopping these memories being embedded. And I think we'll find studies being published soon that demonstrate that, but it won't work for everyone. So the question is, what about the rest? My feeling is that women who suffer loss need to be screened for psychological distress. We know that many will resolve with peer support without formal treatment within 3 months. So I think at 3 months, I think there's an argument that they should be contacted and have either an online survey where they are scored for psychological distress. And if they score above a certain threshold, which is likely to be about between 15 and 20% of them, they should be offered an online structured clinical interview. And if that confirms moderate to severe psychological distress, or certainly post-traumatic stress, we should be offering them intervention, probably in the form of an online-based cognitive behavioral therapy. I think we need to start thinking about this type of approach to managing the women who we care for. So I hope you found this of interest. I think this is a major part of the care that we need to be, of the care for women who have pregnancy loss, and obviously those with recurrent pregnancy loss have a particular burden that they have to carry. Thank you once again for having me. I'm a little unsure whether I'm available for questions tomorrow because I'm recording this on Thursday, but I'll try and be there. But I hope you found this talk of interest, and please do consider the psychological impact of loss in your patients and their partners moving forward. Hopefully I'll be available for questions shortly. Thank you very much.
Hello, everybody, and happy to see you again. So we just finished the first session, which was really amazing with 3 excellent talks. We move now to the second session. So at the end of the second session, we will have the discussions for first and second session all together. This is because some of the speakers are busy in some emergency issues, and we don't want to miss them. So we will have all the talks of the second session and then the discussions together. So the second session will be special lectures. This is Navigating Hope, Controversy in Diagnostical Approach and Treatments Options. We will have 3 speakers, Professor Siobhan Quimby, myself, and Professor John Joachim. Before I invite the first speaker, I want again to remind you and to ask you to help and to support Israel with the tragedy we are facing now, not to be silent, to be clear and condemn the Hamas, terrorism, Nazism, and do whatever you can with your universities, societies, countries, colleagues to support and to help right now to bring back all the hostages, 224 who are now in Gaza, hoping they are alive. Thank you very much for your support. Now I am happy to start with the first talk by Professor Siobhan Quimby. She will talk on thrombophilia and miscarriage after the Alive 2 trial. Professor Quimby is a professor, a consultant in obstetrician based in the university. She holds clinics in recurrent miscarriage, preterm labor, heart disease in pregnancy, and obesity in pregnancy. These involve preconceptual care and intensive care, both in early pregnancy and antenatally. Professor Quimby and Professor Brosens in London also run a self-funded implantation clinic where women can self-refer or be referred by a medical practitioner for world-class opinion and recurrent reproductive failure, in pioneering endometrial tests for natural killer cells and other features. Professor Quimby is a well-known doctor in the field of recurrent pregnancy loss, and let's have her talk.
Hello, my name is Professor Siobhan Quimby. I'm Professor of Obstetrics at the University of Warwick and Honorary Consultant at University Hospitals Coventry and Warwickshire NHS Trust. I'm going to finish this conference by trying to explain to you how far we've got with recurrent miscarriage research and what is the future. So I'm going to go over what do we need to do to prevent miscarriage. I'm going to try and expound to you and encourage you to think of the concept of personalized care. That means giving the right care to the right patient according to their history and test results. I want you to try and think of miscarriage as an opportunity to offer the patient preconceptual care. And for those people who excellent preconceptual care still leads to further miscarriages, I'm going to suggest to you the future will be an endometrial test that determines future treatment pathways. There's 2 endometrial tests I'm going to talk about. One you've just heard about. that to detect excessive senescence or stem cells deficiency, and the other one to detect a condition called chronic endometritis. So first of all, how are we going to personalize care? Well, we need to personalize care by things that we already know. So we know that age is very important in predicting miscarriage, and there's a J-shaped relationship between age and future miscarriage risk. So that if you're very young, you have an increased risk of miscarriage, and also if you're over 40, you have a significant increased risk of miscarriage. The other thing that we know that's very important in determining miscarriage risk is the number of previous miscarriages. So we know there's a stepwise increase in your miscarriage risk with each miscarriage. So if you've had no previous miscarriages, you have 11% chance of miscarrying in pregnancy. If you have one previous miscarriage, that goes up to 20%, 2 previous miscarriages, 28%, and 3 previous miscarriages, 42%. So one way of personalizing care is by number of previous miscarriages. And that's something that we've expounded in our recent Lancet series. So we say that 1 previous miscarriage, remember that increases your risk of miscarriage from 11% to 20%, does deserve some care. The care that should happen is basic preconceptual advice. So that means if you've got a raised BMI, to be directed to weight loss services, to get any comorbidities optimized. So asthma, hypertension, diabetes, epilepsy should all be optimized. 2 previous miscarriages, perhaps you should have some blood tests, definitely thyroid hormone or TSH test, a very cheap, easy test to do, and possibly antiphospholipid syndrome. If you've had 3 previous miscarriages, then you should have more tests. So we've just done this suggestion of personalizing care on the basis of number of miscarriages, but clearly she would also personalize on age. So if someone's over 40 and they've miscarried, it may well be it was because the pregnancy was aneuploidy, but some people over 40 miscarry normal pregnancies. Hence, every effort should be made to make sure the next pregnancy is successful. So what happens if you do that? Well, you've just heard some very good data from Rebecca Shields, and I'm just going to show you again, make no apologies for that, to point out that if your body mass index is less than 30 and you conceive, in fact, nearly everyone goes on to have a live birth. So that's something we should all be working hard to sort out. Also notice that if you've had 1, 2, or 3 previous miscarriages, nearly everyone who conceives ends up with a live birth after a couple of years in our care. Those people need a lot of support. However, the people who have more than 3 previous miscarriages, despite excessive support in my clinic, still continue to miscarry. You can see there's a gap between the blue and the green lines. So those are the people that we need to find new treatments and to prevent miscarriage. So what new treatments are we going to think about for those people? Well, I think it's now clear that those people should have treatments based on the lining of the womb. So in these conferences over the years, you've heard a lot about NK cells, and we've actually found, being able to look at the endometrium in people who lose normal pregnancies compared with those who lose abnormal pregnancies, that's mainly trisomies, and compare that with the NK levels of people who have live birth. You can see the first problem, there's a massive overlap between these patients, so a single test result's not all that helpful, but the people who lose normal miscarriages has a significantly lower NK result than those who lose abnormal pregnancies or live births. If you then add that finding to the test that Joe Mutter has helpfully described to you, the test for excessive senescence, we found that if you add the excessive senescence to the NK deficiency, you actually get far more of those who lose normal pregnancies, whereas those who lose abnormal pregnancies or live births are more or less the same. So look at this, it's looking like we're going to have a test that tells us who needs some treatment to prevent the loss of a normal pregnancy. And what are we going to do with that test result? Well, previously we did a thing called the Simplant trial, and here we randomized people to sitagliptin or placebo for 3 months. And our primary outcome measure was clonogenic assays, or the number of colonies. This is a marker of your endometrial mesenchymal stem cells. We found that sitagliptin significantly increased your endometrial mesenchymal stem cells and significantly reduced your number of senescent cells. However, that was only a small study. It only had about 35 to 40 people in it. So it wasn't significant to change clinical practice. So the answer to that is that we need a large-scale randomized controlled trial with good clinical outpoints. But what trials are going on at the moment? Well, at the moment, the most commonly researched topic in this area is a thing called chronic endometritis. Chronic endometritis is persistent inflammation in the endometrium, and it was originally described as an infiltration of plasma cells seen on hematoxylin eosin staining. So this was a pathologist looking at a slide and saying, I think I can see more plasma cells than I should. They didn't quantify the cells, and it was a pathological opinion as opposed to a repeatable diagnosis. This is asymptomatic endometritis. This isn't the endometritis you get after you have a baby, when you have the classic signs of infection, bleeding, and pain. This is no symptoms, just silent inflammation. It's been associated with recurrent miscarriage, implantation failure, infertility. The problem is there's no gold standard for diagnosis. And the most commonly used method at the moment is to use CD138 to highlight the plasma cells or the positive cells. There's lots of small studies showing an association between chronic endometritis and miscarriage. There's never been a randomized controlled trial. These studies are all non-randomized. So this is what chronic endometritis looks like down the microscope. The brown staining is cells that have stained positively for CD138. And you can see this patient has a very high level. And this patient, there's only a few brown cells, and this patient has a mild level of chronic endometritis. So just to show you how much confusion at this topic, I'm now going to show you some results of a systematic review done by excellent research fellow Josh Adental. Here, he looked at the techniques used to diagnose chronic endometritis, and you can see there's lots of different techniques, including H&E, hysteroscopy, CD138, and culturing the endometrium. And look at the massive difference in results. There's a massive change in the prevalence by diagnostic type, whether you use hematoxylin eosin, immunohistochemistry, hysteroscopy, or endometrial cultures. If you look at it by condition, again, you get this massive scatter of results. Whether you look at it in recurrent implantation failure, infertility, recurrent pregnancy loss, mixed gynecological or mixed reproductive conditions, you have a huge scatter in the prevalence of this condition. Clearly not much agreement between sites. So we have been looking at using a CD138 immunohistochemistry. 24 studies of this was identified, but there's often a lack of important variables in the reports. So method of qualification was sometimes not stated. The diagnostic threshold, how many positive cells did you have to have in those pictures I showed you to count as chronic endometritis? That varied hugely from 0.25 to 5 per high power field, and quite often not even stated. Also, the timing of the biopsy, whether you did it in the proliferative or the luteal phase, was sometimes not stated and did seem to have an effect on the results. But what there was a bit of a consistency of is that if you had chronic endometritis, you were less likely to implant after IVF, you were less likely to have a clinical pregnancy, and you were more likely to miscarry. You're also less likely to have a live birth. So we have a consistency in the outcome, but a massive variation in diagnosis. I'm just going to show you why that happens in more detail. So we have noticed two types of staining with CD138, this kind of diffuse staining here, and this other, which you can see this sort of brown smudge, and this other thing which we've called punctate staining, which is kind of more of a circle or a fried egg appearance. Now this fried egg appearance looks more like plasma cells stained with CD19 or CD56 or NK cells. So we think these are more immune-like cells, and these are more like inflamed stromal cells. We then compared the CD138 with the NK percentile. So you can see people with very high numbers of brown smudges had very low NK cells, and people with this punctate staining had high levels of NK cells. So this is work done by Rebecca Sweetman as part of her master's degree in the University of Warwick. She's also compared the severity of staining, CE staining, with the pattern. So people who had very high levels of staining had lots of this diffuse, whereas people with only mild levels had more of the punctate methods. Another way of looking for plasma cells is to stain it for CD19. And here you can see that the people who had the punctate staining had more CD19 cells. So we think we have discovered two different types of chronic endometritis. One has the high CD138 diffuse low NK cells, and this represents low decidralization, failure to clear senescent cells. A second one had the high CD138 punctate, high CD19 cells, and this seems to look more like an immune reaction to infection, stromal inflammation, and less favorable environment. So this all matters because of the excellent work done up by colleagues in Peel College, and they have found by looking at swabs of people before they miscarry that miscarriage is associated with a different microbiome. Miscarriage is associated with depletion in your lactobacilli. So lactobacilli are bacilli who should be in the vagina, and they should be there. And we think that if you have a reduction of that and a lot of different kinds of bacteria, then you have a lactobacillus deplete state, and this lactobacillus deplete state has been associated with miscarriage. So the big question is, which kind of endometritis has the abnormal microbiome? That's something we're going to be able to answer with the SERM trial. There have been all sorts of non-randomized studies suggesting that antibiotics are helpful in people with chronic endometritis. But these are non-randomized, and they're quite odd because, look, they've compared persistent compared to resolved CE. So if the chronic endometritis disappears, your miscarriage rate gets better, no randomization whatsoever. And the live birth rate of CE is comparable to the live birth rate in treated CE is comparable to live birth rate in women without CE, but there's no live birth rate in people that are randomized to the placebo, except for our pilot data for our grant. So no randomized data. We don't know how much this CE persists, how it's related to lactobacilli, and whether or not it will get better with doxycycline. These are all critical treatments, critical questions, and we're going to answer them all with this SERM trial. So the SERM trial is an adaptive design trial where we're recruiting people with 2 or more recurrent miscarriages who have high levels of CD138, both types of staining. Our intervention is doxycycline 100 milligrams for 14 days, and our comparator identical placebo tablets. We have 2 primary outcome measures. One is an ongoing pregnancy rate at 12 weeks. That's to help us get results more quickly to work out whether it's a good idea to carry on with the trial. And the second one is the live birth rate. So in conclusion, the future of miscarriage care is to personalize care. You can all personalize care today. You can personalize care from everyone you see on the number of miscarriages. Every miscarriage matters. Everybody needs some treatment. After one miscarriage, you need to optimize your lifestyle, stop smoking, optimize your BMI, sort out comorbidities, and have the necessary support for the mental health mobility associated with miscarriage. We need to be aware, and people need to be aware of the very strong relationship between age and miscarriage, so that they're mentally prepared for their own miscarriage risk, and we can do as much avoiding action as possible. The future will be the endometrium. The future is going to be take a test of the endometrium, find out if there's a problem. If you have this pro-senescent endometrium, this exciting science that you've heard from Joe Mutter, there isn't a treatment yet, but we will need to be able to do a randomized control trial in the future to find a treatment, and that will be the entry criteria for the trial. If you want to be part of this resolution, please join our SERM trial. We are desperate for new sites. If you join our SERM trial, your patients will be able to have an endometrial biopsy. Your patients will be known whether they've got chronic endometritis, and your patients will have the opportunity to be randomized to doxycycline or placebo. If anyone's interested in joining this trial, please either email myself or serm@warwick.ac.uk. So thank you very much for listening. Thank you very much for your contribution to the Association of Early Pregnancy Units. It's a really active society. We've made massive difference in research between us. I hope you've enjoyed the meeting. And I'd particularly like to thank all the people who work in the Warwick team, the Tommy's charity, the hospital, the funders, that's the NIHR and the MRC, and my fantastic reproductive Health Research Unit. So the work I've shown you today has been done by Joshua Dentel, Amelia Hawkes, Rebecca Shields, Komal particularly, and Joanne Butter, you've heard speak herself, and Rebecca Sweetman. Have you got any questions?
Now.
Hello again. So now we move to my talk. And basically, I'm going to touch a very not easy, controversial issue. Is the low molecular weight heparin in recurrent pregnancy loss. I will just remind for those of you who don't know or did not meet me. So I'm working in Israel at Soroka University Medical Center in Beersheba in the south of Israel. Yes, this is the place when we have hundreds of measles every day now, specifically in the south, but it's all over Israel. In my medical center, we have more than 1,700 deliveries a month, which is the biggest one in Israel. We are two like this. Since 2016, I am running the World Congress on Recurrent Pregnancy Loss. This is really an amazing meeting. Last one was in February in Bangkok. And it was very, very successful. And I've got many questions. Where is the 7-1 going to be and where? So I'm sure in about 2 weeks, I will announce. I can tell that it is going to be around November 2024. And venue will be announced very soon. I will ask our Congress people and organizers to introduce it with their systems. So yeah, and I decided to give this talk because I am having questions every day about yes or no to use low molecular weight heparin. And you will see that we have different categories or indications and literature accordingly. So let's start, please. Hello, everybody, and welcome to our session. I'm very happy and honored to give this talk. We will have at the end of our 3 talks discussion. I'm sure it will be very interesting and many things to learn. I'm Professor Bashiri. I'm the Director of Recurrent Pregnancy Loss Prevention Clinic and Maternity Seaward at Soroka University Medical Center at the Faculty of Health Science in Ben-Gurion University of the Negev in Israel. My talk is on low molecular weight heparin for women with recurrent pregnancy loss. I have nothing to disclose. So my talk is going to be including 4 parts. The first will be very briefly on the coagulation system. I'm sure everybody knows how complex it is, but I want just to put some very quick facts. Then we will talk about the antithrombotic agents that are existing, and we will focus on unfractionated heparin, low molecular weight heparin, and also a little bit on aspirin, but just to make sure we know the drugs that are existing in our topic.
And the main will be on thrombophilia and recurrent pregnancy loss. This will include acquired and hereditary thrombophilia. And we will emphasize the guidelines and screening as well as treatment. The last part will be on unexplained recurrent pregnancy loss with low molecular weight heparin. Relevant, not relevant, we will see. Yeah, so let's start with the coagulation system. As you can see here, it is very complicated, yeah? I can tell you that every time I have to ask myself if I know exactly which one is what, I have to open it and see again, because it's hard to remember. So we have the intrinsic pathway, the extrinsic pathway, and the common pathway. We see all the players all around, and at the end of this system, basically what will happen is the clot formation. Once it's balanced and everything is controlled, we will have clot formation, and in parallel, we will have also the clot breaking. So during physiological normal condition, there will be no clot formation in our body. However, if something is wrong, we will have more clot formation, and this balance will be disturbed. So once there is a disturbance in this clot formation and the imbalance is interfered, we will have thrombophilia. We will have two different kinds of thrombophilia. The hereditary one that includes a problem with protein S, protein C, antithrombin 3. All of this will be deficiencies. We will have factor V Leiden mutation or factor 2 mutation, prothrombin mutation, or combination of them. On the other hand, we have the acquired thrombophilia, namely antiphospholipid syndrome. And there is a probability that there is another thrombophilia that we cannot really diagnose so far. Maybe it is the unexplained thrombophilia that existing, but we don't really know what characterized it. So let's go back to the cascade of the coagulation system. So as you can see here, in each part of those players or those factors, that protein S, protein C, factor V Leiden, factor 2 mutations, or antithrombin 3, in each case, when we have abnormalities, so everything will go through more coagulation. Clot formation will increase. And again, this is because the factors that are involved are either abnormal or deficient. And this is why we will have abnormalities in the clot formation. So once we understood those conditions, the question will be, what can we offer? What drugs we have? What antithrombotic drugs are existing? So we can divide them into three categories: the antiplatelet drugs that inhibits platelets, and the most important one for us that can be given in pregnancy is the COX inhibitors, the aspirin. We have those drugs that are anticoagulant, that attenuate coagulation. This is the unfractionated heparin, the low molecular weight heparin. Those are the two that can be used in pregnancy and generally. And we have the other category, the thrombolytics, that you can see here. So the discussion in my talk will be basically on low molecular weight heparin, and I will mention some studies that were used years ago, the heparin, and some of the protocols were using in combination aspirin. But we will go through this step by step. So, as I said, we will focus on low molecular weight heparin as the drug for recurrent pregnancy loss and when we should use it, or when it is effective. let's just make sure that we understand the mechanism. So both of them, unfractionated heparin or low molecular weight heparin, are working through antithrombin connection. So once they connect to antithrombin, as you can see here up and down, so they cause inactivation of factor 10A that stop the coagulation system. Additionally, heparin is also working through attachment to thrombin. It can cause the same, but in less significant. It's important to understand that low molecular weight heparin, with its connection to factor 10A, has much more significant effect in the inactivating of factor 10A and in stopping the coagulation cascade. So we will move now to the use of low molecular weight heparin in recurrent pregnancy loss, and we will divide it into 3 categories. In cases of acquired thrombophilia, namely antiphospholipid syndrome, in hereditary thrombophilia, and in unexplained RPL. Let's see what the literature is telling us. So antiphospholipid syndrome is well known in its classification. It started with, we have here the Miyakis categories, which includes the clinical criteria. We have it in the red and the orange lines here. In the pregnancy morbidity includes unexplained deaths of morphologically normal fetus more than 10 weeks of gestation, or premature birth before 34 weeks of gestation with placental abnormalities or insufficiency, or 3 or more consecutive spontaneous pregnancy loss below 10 weeks of gestation. So this is the pregnancy morbidity. We can also have the vascular thrombosis in the history. And this is the clinical criteria, one of them or more, with laboratory criteria, as we can see here. Once we have at least 1 autoantibodies that was measured positive twice, at least 12 weeks apart, and the antibodies can be anti-cardiolipin IgG or IgM, anti-beta-2-glycoprotein 1 IgG or IgM, or lupus anticoagulant. So we have laboratory criteria. We need 1 of them to be positive in 2 or more occasions, and we need 1 clinical criteria. And let's see what ESHRE published in the last recent guidelines 2022. So they recommend to screen for antiphospholipid antibodies after 2 pregnancy losses, which is different from what I just showed you before by Miyake's criteria. But this is the new guidelines. And for anti-beta-2-glycoprotein 1, they said that it can be considered after 2 pregnancy losses. So I think there is a change that we all know, that after 2 pregnancy losses, we can do the screening. And what about treatment for antiphospholipid syndrome according to the ESHRE guidelines? So they recommend to give low-dose aspirin, 75 to 100 milligrams per day, starting before conception, and a prophylactic dose of heparin, unfractionated or low molecular weight heparin, starting at date of a positive pregnancy test, over no treatment. So it's the combination is the treatment of choice. Now it's a little bit strange, but the guidelines offering anticoagulant treatment for women with 2 pregnancy losses and APS only in the context of clinical research. So there is some controversy. From one side, they recommend to screen after 2 pregnancy losses, but treatment should be given after 3. So what will happen if we find it positive after 2? I don't really have the answer, but this is not our point. Let me just go now to the studies. And I think the most important one is by Hemuliak in Cochrane 2020. So they compare the combination, as we just saw by Miyakis and ESHRE guidelines. So this is heparin plus aspirin versus aspirin alone. We can see it in the top, and the risk ratio for live virus is 1.74, which makes it very clear that this treatment is very effective. If we go to low molecular weight heparin with aspirin versus aspirin, it's still very effective, but the risk ratio is lower, is 1.20. And this is basically the conclusion for the first question. Low molecular weight heparin is very effective with aspirin to increase live virus among women with antiphospholipid syndrome. And it's important to see the numbers. We are talking about around 500 cases, more than 500 cases in each category. But the conclusion is very clear. It's very significant, and this is why this is the treatment of choice. Now we can go also to another meta-analysis asking the same question that was published 1 year later. And we see that low molecular weight heparin plus aspirin versus aspirin has a risk ratio of almost 1.3, a little bit more than what we just showed before in the Cochrane. So the same conclusion, of course, those studies, some of them were also included in the previous Cochrane that I showed you, but the conclusion is very clear. Here we have 11 studies, more than 2,000 patients, and this is why the gold standard for antiphospholipid syndrome with recurrent pregnancy loss should be the combination of low molecular weight heparin versus aspirin. So for the first question, the answer is very clear. Low molecular weight heparin is important. Let's move now to another thrombophilia, the hereditary one. I showed you in the beginning the 5 factors that including this hereditary thrombophilia. This was the protein S, protein C, protein S, and antithrombin 3 deficiencies, or factor 5 or factor 2 prothrombin mutations. So ESHRE guidelines based on BETS, published on CHEST 2012, and the Jong Cochrane Database Systematic Review 2014, saying very clearly, we suggest not to screen for hereditary thrombophilia, just in context of research and so on. And they also suggest not to use antithrombotic prophylaxis, or just unless it's in the context of research or indicated for VTE prevention. So they found no evidence of a beneficial effect of anticoagulation treatment for those women with RPL and recurrent pregnancy loss. So I want to show you, first of all, the Dijon from 2014, that on this one, ESHRE based is its recommendation. So what was it? It was, there were 9 studies, including around 1,200 patients, and the treatment was low molecular weight heparin, aspirin, or a combination of both. And the effect was on live birth rate. And the conclusion that was made in this paper was that anticoagulants did not have a beneficial effect on live birth, regardless of the presence of inherited thrombophilia. So this was with thrombophilia, inherited or not. So let's go to the numbers and see what was there. So if we see this forest plot, all women here in the top, we see that the relative risk was 1.01, confidence interval, including the one. So 300 patients, all of them all together, the live birth rate was not different with this treatment, with low molecular weight heparin and aspirin. But we wanted here in this part of my talk is on inherited thrombophilia. This is here, this part. So there were only 27 patients, and the conclusion was the same. Yeah. So inherited thrombophilia with low molecular weight heparin plus aspirin versus no treatment, no difference. But the more precise question was not on the combination of treatment. I'm talking about low molecular weight heparin and inherited thrombophilia. So let's go ahead in this forest plot. And this was only, see, 6 patients. The same conclusion, but those are the numbers. And this is why I think it's very dangerous to look at this as the same population. It's very, very heterogeneous populations, including in this meta-analysis and systematic review. Now, if we want to include more patients with inherited thrombophilia, but with high risk of bias, we may have around 400 patients, the same conclusion, no effect. So if I summarize this, De Jong Cochrane on low molecular weight heparin and hereditary thrombophilia, and I just show you the problematic issues with the numbers, no effect, no advantage. So this was 2014. 2022, the ESHRE summarizing the same conclusion. And now I move just very quickly to what we have just heard by Professor Quinby, the study ALIF2, they published in the Lancet. And basically, they came to the same conclusion. So we see those 2 groups, 2 or more pregnancy losses with inherited thrombophilia. And basically, it's very hard to believe that it took around 9 years to recruit all those patients. But the treatment, the live birth rate in the low molecular weight heparin group, 71.6 versus standard surveillance group without low molecular weight heparin, 70.9. So low molecular weight heparin treatment did not result in higher live births, and this is why they recommend not to treat and not to screen, not to do testing. So if I stop here, well, I have nothing to say about inherited thrombophilia, but I do want to go through the literature during the years and show you all the other information, because I do believe and think that it's not the last point, and we still need more studies. So as you see here, although we saw the ESHRE guidelines, the De Jong and Quinby study, let's go and see what happened in 1992 by Minardi. This study was quoted in the literature more than 200 times, and they look for the risk for fetal loss in carriers of factor V Leiden mutation. Now, those patients, these 228 were recruited because they had VTE or first-degree relatives had venous thromboembolism. Now, if you see the pregnancy that ended with fetal loss with factor V Leiden mutation, heterogeneous, homogeneous, or ended in miscarriage. So the numbers, the rate was almost double in all the groups in carriers versus non-carriers. And the conclusion was that factor V Leiden mutation carriers have a greater risk for fetal loss. And this was 1992. It's a very important study, a big one, showing clear association. So this is very important one in the literature. Now, if we go to 2019, Clavijo published their study in the risk factors and the role of low molecular weight heparin in obstetric complications among women with inherited thrombophilia. This was a retrospective cohort study, 250 pregnancies, 88 women with hereditary thrombophilia. What we can go to the conclusion and see that high risk for inherited thrombophilia for fetal loss was almost odds ratio of almost 5. So we can say that a significant relation between inherited thrombophilia and pregnancy loss was found in this study with odds ratio of almost 5. So another important study showing the association. 2022, we have a systematic review and meta-analysis published in Human Reproduction. Almost 90 observational studies, more than 30,000 patients with hereditary thrombophilia, as you can see here. And the question was if there is association between the risk of RPL and factor V Leiden mutation. So here we see very clear association, odds ratio of 2.44. If we go in the same study on prothrombin gene mutation association with RPL, odds ratio 2.08. And if we go to protein S, odds ratio 3.45. Women with protein S deficiency had the higher risks of developing RPL. So in this Human Reproduction meta-analysis and systematic review that published very recently, at least 3 inherited thrombophilia were highly associated with the risk of recurrent pregnancy loss. So although the study by Professor Quimby in the Lancet, and as I said, what published in ESHRE guidelines, I just show you the studies, other studies showing the relationship, the positive association. Let's go now to see what about treatment for those cases. So Greece in Blood in 2004 looked for the treatment of low molecular weight heparin versus aspirin in women with fetal loss and thrombophilia, and they found a very, very dramatic improvement with low molecular weight heparin versus aspirin in those cases with factor V Leiden mutation, factor 2 or protein S deficiency. So you see that live birth in the low molecular weight heparin was almost double here, almost 3 times here and double here. And what was important is they also compare it. You can see here high rates of live birth in all women with low molecular weight heparin with odds ratio of 15.5. And all 3 and the higher rate of healthy live birth in all 3 subgroups, which is factor V Leiden mutation, protein gene mutation, and protein S deficiency. So this study was dramatic in its findings that thromboprophylaxis was very helpful in hereditary thrombophilia. 2015, in the Journal of Maternal Fetal Neonatal Medicine, we see again comparison between early pregnancy loss and low pregnancy loss in a group that were treated with low molecular weight heparin or no treatment. And again, the improvement for live birth was very, very dramatic. We can see here that the miscarriage rate was 4% in the low molecular weight heparin group versus 22, and this was very, very clear. This was statistically significant. Very importantly, in this study, they also compared to the previous pregnancy outcome in those patients. And as you can see here, 15 times less early pregnancy and late pregnancy loss compared to previous pregnancies. and 4 times more term births compared to previous pregnancies. So again, this is a study that was published 2015, showing different findings than what was found in the Lancet recent study and the others. 2022, 10 meta-analysis and systematic review. They included 10 randomized controlled trials, 12 cohort studies, thousands of patients. If we look in the forest plot about association between low molecular weight heparin and live births, just the cohort studies, we see a very clear improvement with risk ratio of 1.86. So low molecular weight heparin treatment significantly increases the rate of live births in this category. And after having those results and differences during the years, I want to move to the last part, which is the unexplained recurrent pregnancy losses and whether low molecular weight heparin is effective or not effective. This is a meta-analysis of randomized controlled trials about the efficacy of low molecular weight heparin for recurrent pregnancy losses, published 2019. There are 6 randomized controlled trials, more than 1,000 participants. As you can see here, the risk ratio was 1.06, and the conclusion is that enoxaparin, low molecular weight heparin, shows, and the conclusion is that low molecular weight heparin shows no significant impact in this specific study. Okay, 2019. I bring it here because I do want to show you that studies are, with the results, conclusions are controversial. So this is one about treatment with low molecular weight heparin in hereditary thrombophilia. If we go to Fei 2020, the same question, the role of low molecular weight heparin on RPL, very clear effect, positive effect, significant difference in live births with risk ratio of 1.19 on live births. So, and if we go to see the other side of the spectrum, the miscarriage rate before it was live birth, risk ratio was 0.62 in Fei meta-analysis and systematic review, significant lower miscarriage rate. So in this study, we have increased live birth rate with low molecular weight heparin and decreased rate of miscarriage rate. Another systematic review and meta-analysis showing that low molecular weight heparin in unexplained RPL has a positive effect. You see the blue bars are the RPL and the orange are the control. Again, more than 1,500 patients, clear in most studies, clear positive effect with this treatment. And another one published 2020, we see 8 randomized clinical trials, but we go to see the likelihood of live birth among women with unexplained recurrent spontaneous abortion with heparin and aspirin versus aspirin alone. We see in this study the inclusion criteria were not really clear enough. They included also APLA. APLA in RPL is explained, so I don't know why they included them, but let's see all the results. So first here we see odds ratio with 2.09, which makes it clear that there is a higher live birth chance among women with treated with heparin plus aspirin. If we go and we see now here just the first plot of the likelihood of live birth among women who tested negative for antiphospholipid antibodies, which means the real unexplained, we see that the odds ratio is 2.25, the subtotal, and the overall is 2.09. But those specific group is the odds ratio is 2.25, which is makes it very clear that there is a very positive effect with this treatment in unexplained RPL. So I'm sure we got a little bit confused, but I'm not. I still think that low molecular weight heparin has some place in hereditary inherited thrombophilia and also in unexplained RPL. And I think the reason is because the last part of my talk is the anti-inflammatory properties of low molecular weight heparin. So first, let's just mention that low molecular weight heparin, which is synthesized in the industry, but at the beginning, or the physiologic molecules of heparin, you can see the history of the discovery during the years. And what is the physiological action of heparin? So it's usually first stored in the mast cell secretory granules. It's released into the vasculature at sites of tissue injury, and it may play a role in defense against invading bacteria and other foreign materials. We can see and we can tell that heparin has a very clear anti-inflammatory properties. This study published by Daniel in Thrombosis and Hemostasis 2020, it is very involved as anticoagulant and non-anticoagulant in many processes in cancer, metastasis, coagulation, cellular hemostasis, and you can see, and in immune system, as you can see, the summary of all these processes. We can see also that this illustration of the anti-inflammatory polypharmacology of heparin. Besides its use as an anticoagulant, the anti-inflammatory properties of heparin are widely recognized and well described in this study. These properties depend on the overall effect of heparin affecting many different ligands. These ligands can be either found in plasma, they are surface bound, or present in the intracellular compartments. You can see them here very nicely. Of course, it's very complicated processes, and you can go to this amazing paper and read it. We can see also here that the low molecular weight heparin is connecting in a very high affinity to interferon gamma. And by doing so, it causes inhibition of the intracellular receptor. So if we take it here, the natural cells and low molecular weight heparin in the cell, you see the blue is predominant. If we put interferon gamma, you see red. And what happened once we increase the low molecular weight heparin with interferon gamma, less red, more blue, like natural cells. So what we can say is that low molecular weight heparin is fully inhibit the interaction of interferon gamma with its cellular receptor. So in the presence of low molecular weight heparin, there is no intracellular activity of interferon gamma, which is a very good characterization of anti-inflammatory processes of this low molecular weight heparin. And we can see also here the distribution of nuclear intensity of the STAT1. Low molecular weight heparin bind interferon gamma and inhibit the interaction with the cellular receptor. And you can see that with high dosage of low molecular weight heparin, we have a very clear inhibition like natural cells. So blocking the interferon gamma signaling pathway and the expression of interferon gamma induced proteins very clearly done by low molecular weight heparin. And the last will be this study by Lito of 2021 showing that heparin impairs the IL-6 and IL-6 receptor interaction. You see here the red is heparin and the yellow is IL-6. The blue will be glycoprotein 130, which is a membrane receptor, and the orange is magnesium and some others. So just to summarize that we can see very clearly that the heparin impairs the IL-6 and IL-6 receptor interaction. It also blocks binding site 2 of IL-6, preventing binding of glycoprotein receptor. And it also breaks the cytokine signaling pathways, inhibiting the formation of the IL-6 and IL-6 receptor complex, which means that IL-6 cannot work once we have low molecular weight heparin. And we all know the relevance of IL-6 to the inflammation processes. If I summarize, so in APLA, it's important to do the screening and treatment with low molecular weight heparin. In hereditary thrombophilia, we have controversial findings. Studies showing significant increase in live weight when treated with low molecular weight heparin, although very recent randomized clinical trial in the Lancet showing no effect and no advantage. In unexplained recurrent pregnancy loss, controversial approach, but studies show that there is significant increase in live weight when treated with low molecular weight heparin in some studies, including systematic review and meta-analysis. And the fourth point is that once low molecular weight heparin is working, there may be that it is doing so by affecting plasma surface bound or intercellular different ligands, inhibiting cytokine release pathways, all of this basically working through anti-inflammatory properties. Thank you very much for your listening and participating in our Congress and this specific session. Thank you very much.
Hello, everybody. So we now move to the last talk in this second session. This is going to be given by Professor John Kwakim. Professor Kwakim will talk about recurrent pregnancy loss. What are the lessons in immunological factors? What we learned so far? Professor John Kwakim She is Agents Latimer Professor of Obstetrics and Gynecology and Clinical Science in the Chicago Medical School at Rosalind Franklin University of Medicine and Sciences. She is the Director of Reproductive Medicine and Immunology in this institution. Professor Kwa Kim started her career in Seoul, Korea, and then she had her residency and fellowship in the fellowship in reproductive immunology and obstetrics and gynecology in Chicago. Professor Kwa Kim is a world-renowned clinician and scientist. Her studies are basically focusing on reproductive immunology, particularly in recurrent pregnancy losses and repeated implantation failure. Her studies are very focused on T helper 1 and T helper 2 immune responses in women with recurrent pregnancy loss and recurrent implantation failure. Recently, she published a textbook, namely Immunology of RPL and Implantation Failure. Professor Kwa Kim is the former president of the American Society of Reproductive Immunology, and she is the president-elected of the International Society for Immunology of Reproduction and the chairman of the Fellow Clinical Reproductive Immunology Board in the American Society for Reproductive Immunology. So after having this introduction, let's hear her talk.
I'm Dr. Joanne Kwa Kim. First of all, I would like to thank all the organizers, participants, and speakers to make the 7th annual conference, Human Reproduction and Recurrent Pregnancy Loss, possible, even with the ongoing war. Furthermore, I want to recognize the Ukrainian Medical Society with the reverence for their resilience, enthusiasm, and commitment to serve for the citizen during this challenging time. I don't have any conflict of interest for today's talk. Currently, recurrent pregnancy loss is defined as 2 or more clinical pregnancy losses by multiple professional societies, although it used to be defined as 3 or more consecutive pregnancy losses prior to 20 weeks from the last menstrual period. This is the old recommendation by American College of Obstetrics and Gynecology. It used to recommend thorough physical exam and testing after 3 repeated miscarriages. Now it is recommending thorough physical exam and the testing after 2 miscarriages. Why is the recommendation changed? I'll review the pertinent findings supporting current recommendations. There is a lack of difference in prevalence of abnormal test results between 2 versus 3 pregnancy losses regarding the prevalence of uterine abnormalities and antiphospholipid antibody. That could be one reason. As you can see in this plot, there are no difference in uterine abnormalities between women with 2 versus 3 pregnancy losses. This analysis has no risk for the bias. This is an analysis for antiphospholipid antibody syndrome in women with a 2 versus 3 recurrent pregnancy losses. Again, there is no evidence that the prevalence of antiphospholipid antibody syndrome in 2 versus 3 recurrent pregnancy loss is different. There is insufficient evidence for a difference in prevalence of abnormal test results in chromosomal abnormalities inherited thrombophilia, including factor V Leiden, prothrombin gene mutation, protein C and S deficiencies, and thyroid disorders after 2 versus 3 pregnancy losses. Therefore, the result of this systemic review may support investigations after 2 pregnancy losses in couples with recurrent pregnancy losses, but it should be stressed that the additional studies of the prognostic value of test results used in the recurrent pregnancy loss women are urgently needed. This is the parental chromosomal abnormality analysis between 2 versus 3 pregnancy losses. Again, there is insufficient evidence to support the difference between women with 2 versus 3 pregnancy losses. However, when we review the chromosomal abnormalities in products of conception, there is fewer chromosomal abnormalities detected in recurrent pregnancy losses than sporadic pregnancy losses. The incidence of chromosomal abnormalities in sporadic pregnancy loss was significantly higher than that in recurrent pregnancy losses. The incidence of chromosomal abnormalities in women with 2 pregnancy losses was significantly higher than that in women with 3 or more pregnancy losses. There was no difference in the distribution of abnormal types between sporadic and recurrent pregnancy losses, or between 2 and 3 or more pregnancy losses. Therefore, the prevalence of chromosomal abnormalities detected in product of conceptions was lower in recurrent pregnancy losses than in sporadic pregnancy loss, and decreased with an increasing number of pregnancy losses. This is the analysis of consecutive or non-consecutive recurrent pregnancy losses regarding chromosomal abnormalities. The result of this study showed that a history of consecutive versus non-consecutive miscarriage in couple with 2 or more miscarriages or 3 or more miscarriages is not a risk factor for carrier status of structural chromosomal abnormalities. Therefore, offering karyotyping only to couples with consecutive miscarriage is incorrectly excluding couples with non-consecutive miscarriages who are also potentially at high risk for carrying a structural chromosomal abnormality from a relevant diagnostic test and appropriate counseling. When we look at the incidence of recurrent pregnancy losses, the incidence of recurrent pregnancy losses indeed has been increased. In a study of women aged 18 to 42 years old, incidence of recurrent pregnancy losses was significantly increased by 74%. In a study of women who had achieved pregnancy in the same period, the incidence was increased by 58% during the same period. This increase might be associated with the environmental changes, as the increase was fairly rapid. There is a significant proportion of women with recurrent pregnancy losses with immune etiologies for the losses. Additionally, when we look at them, they tend to have multiple immune abnormalities. So 55% of women with recurrent pregnancy loss have antiphospholipid antibody, other autoantibodies, and aberrant cell-mediated immunity. 31% of them may have antiphospholipid antibody and aberrant cell-mediated immunity. And indeed, they have an increased NK cell levels and cytotoxicity, increased NK1, particularly TNF-alpha producing cells, increased T helper 1 and T helper 2 cell ratio, increased T helper 17 cells and decreased T-rex cells, and increased T helper 17 over T-rex cell ratio. Therefore, the women with recurrent pregnancy loss and implantation failure have increased cellular immunity, including innate and acquired immune responses. Maternal immune activation is also evidenced by the genetic polymorphisms in cytokine gene polymorphism, since interleukin genes play important roles in the expression of the seroproteins and are further involved in the immune response to pregnancy. So you can see the IL-1 beta, IL-6, IL-10, and IL-18 gene polymorphisms are significantly associated with the recurrent pregnancy losses. IL-1 is produced by cytotrophoblasts at the fetal-maternal interface during early pregnancy and involved in trophoblast invasion and tissue repair. IL-6, secreted by decidual cell population, is a potent pro-angiogenic cytokine that stimulates the proliferation of endothelial cells and regulate the behavior of female reproductive tract and gestational tissues. IL-10 is produced by cytotrophoblasts and decidual T cells. It protects the fetal-placenta interface by reducing the cytokine secretion of T helper 1 cell and macrophages. IL-18 induces interferon alpha, leading to the activation of NK cells, which is important in uterine vascularization and implantation. IL-17A, IL-21, IL-1 beta, IL-6, and IL-10 gene polymorphisms have been also associated with recurrent pregnancy losses, but with limited studies. As a pleiotropic cytokine, TNF-alpha has attracted attention because of its involvement in the promotion of inflammatory response, autoimmunity, endocrine, and neoplastic disease. Furthermore, there is convincing evidence that the TNF-alpha induced apoptosis of cytotrophoblasts, which is suggested that aberrant expression of TNF-alpha may have a harmful effect on placenta development and function. Indeed, TNF-alpha 308G2A polymorphism is associated with susceptibility to recurrent pregnancy losses. Hence, this polymorphism might be a risk factor for recurrent pregnancy losses. So I just reviewed the background, why we have to start to investigate the women after the 2 miscarriages and some of the genetic polymorphism. And when we diagnose the women with the recurrent pregnancy losses, we tend to use multiple biomarkers. So diagnostic testing with significant scientific evidence are crucial to performing evidence-based diagnosis. Interestingly, evidence-based diagnosis is not consistent with what we understand as diagnosis. It considers the uncertainty for a particular disease causing illness and describes how to apply test results to update this probability while assuming the costs and benefits of both the treatment and the tests are known. And these are the relevant biomarkers for women with a repeated implantation failure, unexplained infertility, and recurrent pregnancy losses. Cellular immune abnormalities, autoimmunity, and endometrial molecular gene expression markers have been intensely studied and nowadays utilized clinically. When the biomarkers are utilized for diagnostic investigation, we have several objectives for the testing. The objectives of the diagnostic testing include detection of or exclusion of disease, contribution to management, assessment of prognosis, monitoring clinical course, and measurement of general health or fitness. In addition, tests must be evaluated in accordance with their intended objectives. To evaluate if the test can increase certainty of the disease, the test should be supported by scientific evidence of mechanism and has an adequate discriminatory power. So what is the scientific evidence of mechanism, such as for the NK cell biomarker in reproductive failure? 20 years after the first NK studies in recurrent pregnancy losses from our lab, a meta-analysis was performed revealing peripheral blood NK cell percentages and numbers were significantly higher in women with recurrent pregnancy losses than controls. In fertile women, NK cell numbers were significantly higher than fertile control. In a recent study of 63 immune cell phenotypes in the peripheral blood by multi-parameter flow cytometry, women with a history of recurrent pregnancy loss had decreased immature NK cell and increased mature NK cells compared to non-pregnant women and women with a history of normal pregnancy. NK cell cytotoxicity reflects universal functional status of NK cells rather than a simple enumeration of NK cells. When NK cell cytotoxicity was measured by flow cytometry analysis, non-pregnant women with recurrent pregnancy loss and repeated implantation failure had significantly elevated NK cell cytotoxicity than non-pregnant controls, which is blue bar in here. Again, pregnant women with recurrent pregnancy loss had increased NK cell cytotoxicity than pregnant control. The same results were presented, the effector to target ratio of 25.1. So recently, NK cell cytotoxicity meta-analysis was reported. In this report, NK cell cytotoxicity was significantly higher in women with unexplained recurrent pregnancy losses than the fertile controls. And the heterogeneity of the population was insignificant. Therefore, the risk of bias is significantly low. The ROC curve analysis of NK cell cytotoxicity revealed that the NK cell cytotoxicity assay can significantly differentiate women with reproductive failure and fertile controls. At the cutoff value of 17.8% of NK cell cytotoxicity at the effector to target cell ratio of 50:1, odds ratio was 9.3. So NK cell cytotoxicity testing and NK cell levels are indeed good diagnostic testing for the recurrent pregnancy losses. In recent meta-analysis of uterine NK cell levels, women with a recurrent miscarriage and repeated implantation failure had significantly higher uterine NK cell counts than the controls. There was wide variation in studies conducted on uterine NK cell activity. However, the most studies found lower expression of inhibitory receptors and increased expression of angiogenic factors in women with the recurrent miscarriages. So total 57.2% of women in my clinic with idiopathic recurrent pregnancy loss had either elevated NK cell numbers or the cytotoxicity or both. So to evaluate if a diagnostic test is fulfilling these objectives, the capacity of therapeutic application and treatment outcome can be measured. So this meta-analysis was performed using 7 studies out of 1,025 studies investigating recurrent implantation failure women with abnormal NK cell levels and activities. The meta-analysis of non-randomized controlled trial of IVIG study showed live birth in favor of intervention. However, there is a medium degree of risk of bias in this study. However, when we look at their subgroup analysis, women with recurrent pregnancy loss have significantly improved live birth rate with IVIG treatment. Heterogeneity of the study population was insignificant, and therefore the risk of bias was low. Again, the women with repeated implantation failure also have significantly improved live birth rate with IVIG treatment. However, heterogeneity of the study population was significant, therefore the risk of bias was high. When all the death data are put together, live birth rate was also significantly improved by IVIG treatment with a moderate risk of bias in this study population. This is another meta-analysis including women who had immune abnormalities. So not only the NK cell abnormalities, they include the women with a T helper 1, T helper 2 cell ratio elevation, and the positive ANA and anti-thyroid antibodies. The clinical pregnancy rate in both cohort and cross-sectional studies were significantly higher, and the live birth rate in both study populations were also significantly improved with the intervention. However, there was significant heterogeneity and moderate to severe risk of bias was present in these studies. So in summary, immunotherapy selected on the base of abnormal NK cell measurement may be beneficial. There is a paucity of high-quality studies. Meta-analysis of non-randomized controlled trial IVIG study showed live birth in favor of intervention in recurrent pregnancy loss women. So we reviewed our clinic data. So we have 197 patients undergoing IVF, ET, or FET cycles, and all had a history of recurrent pregnancy losses. So they were divided by their history. So this group of women had a recurrent pregnancy losses in non-ART cycle, and this group of women had a recurrent pregnancy losses after the ART cycle, and each group were divided by the absence and presence of repeated implantation failures. And before the index IVF-ET or the FET cycle, their peripheral blood NK cell cytotoxicities were suppressed, and NK cell levels were suppressed, and T helper 1 and T helper 2 cell ratios were significantly decreased by using prednisone only or prednisone and the IVIG protocol. Average age of the last trial prior to the index trial was 37.9 years old, and the age of index trial was 39 years old. Historical pregnancy rate of this group was 33% in total. The pregnancy rate for the index trial of the total group was significantly increased to 48.2%. Live birth rate per embryo transfer cycle was significantly increased from 1.8% to 39.6%. Live birth rate per pregnancy was significantly increased from 5.3% to 82.1%. Recurrent pregnancy loss after ART cycle and repeated implantation failure group, which is the pink bar in here, had the worst reproductive outcome among the study population groups. When we compare the treatment protocol, the IVIG and prednisone protocol had significantly higher pregnancy rate than prednisone only group. So yellow bar is historical control, orange bar is prednisone with the index cycle, light blue is historical control, and dark blue is the prednisone IVIG treatment group. The live birth rate was significantly improved in both protocols. However, the IVIG prednisone combination protocol had a significantly higher live birth rate per cycle. Live birth rate per pregnancy were comparable in both prednisone and IVIG protocols. Per cycle and cumulative pregnancy outcomes are compared in this plot, and pregnancy rate per cycle tend to increase when we have a first, second, and third cycles, and live birth rate per cycle tend to increase when we add up the more cycles, and as a result, cumulative live birth rate was increased with a stepwise pattern. This is the front cover of the Times magazine. It noted the surprising link between inflammation and heart attack, cancer, Alzheimer's disease, and other disease, perhaps the reproductive failure. We saw women with a recurrent pregnancy loss has activated cellular immunity by the presence of NK cell activations and T helper 1 and T helper 2 immunity. And today we didn't have a time to review the T helper 17 over Treg, but T cell activation and NK cell activations are keenly associated with the recurrent pregnancy losses. So women with a recurrent pregnancy loss have a pro-inflammatory immune response with activated cellular immunity. Hence, these women have a higher risk to develop the second and the third trimester inflammatory obstetrical complications. And as you can see in here in this table, women with a recurrent pregnancy loss have an increased risk to develop pregnancy-related complications during the first gestation after they're referred to the clinic. Their pregnancy should be considered as a high risk and deserves special attention and care, even though caution is needed before drawing the firm conclusion on this relevant issue. The particularly risk of threatened miscarriage, spontaneous miscarriage, pregnancy-related liver disease, and preterm PROM were reported to be significantly increased when women had more pregnancy losses from 2, 3, and 3 and more recurrent pregnancy losses. Meta-analysis of preterm birth after recurrent pregnancy losses revealed a pooled odd ratio of 1.60. There was a trend toward higher odds of preterm birth with the increased number of pregnancy losses. However, the risk of bias was medium to severe. In unexplained recurrent pregnancy loss, pooled odd ratio was 2.05 for the preterm pregnancy. The mean incidence of preterm birth among the recurrent pregnancy loss group was 7.2 to 11.9% ranges versus non-recurrent pregnancy loss group was 5.8%. Therefore, women with recurrent pregnancy loss may benefit from additional counseling and more intensive monitoring during subsequent pregnancies. So in summary, a significant proportion of women with recurrent pregnancy loss have immune inflammatory conditions evidenced by the activation of innate and acquired immune effectors. Proper investigation and treatment should be initiated when 2 miscarriages were experienced. Meta-analysis of the non-randomized controlled trial IVIG studies showed live birth in favor of intervention in women with NK cell pathologies. Women with recurrent pregnancy losses have an increased risk of developing pregnancy-related complications. Hence, their pregnancy should be considered at high risk and deserves special attention and care. And women with a special history of recurrent pregnancy losses have an increased risk of inflammatory and thrombotic conditions such as coronary heart disease and the stroke. Therefore, proper counseling and follow-up should be established for them. Thank you for attention.
So, hello everybody and welcome again. Now we are in the discussion part of the first two sessions of our Congress. I want to welcome Professor Baris Atra, Professor Ole Christiansen, Professor Tom Brunet, I think he's not here, Professor John Kwakim, and Professor Queenby, are you here? Oh, yeah. And a guest here, Professor Kong from London. So I think we had a really, really great lectures, the most up-to-date information, and we're still having many questions, controversies, and I would like to start with some questions to each one of you, but let's say it's more your opinion. And it's a challenging question. So first I would like to go to Professor Baris Ata. You showed us very nicely the up-to-date guidelines by the ESHRE about secondary infertility. And in the end, you mentioned, basically we saw that those guidelines are talking about what not to do. It's not recommended, not what to do. And well, it looks like same years ago. But one thing is really interesting me, at least according also to your talk. You mentioned that looking for BMI is good. We can do it. My question to you, do you think it's the time to include obesity or maybe class 3, class 2 obesity in the definition of unexplained infertility? Or in other words, do you consider morbid obesity as explained infertility or unexplained? Why we don't include this important factor in the definition?
Thank you. It's a very nice question. I hope you can hear me well. And so what the data suggests, so where to start? The definitions are to be generalized, okay? So far, BMI itself or obesity itself, as long as the is ovulatory, has not been documented as a cause of infertility. What we know from IVF data is the BMI increases over normal. It is inversely related with clinical pregnancy rates, even if you transfer euploid embryos. But the problem is when people undergo weight losing or weight reducing interventions, despite they lose weight, despite they lower their BMI, interestingly, their fertility outcomes do not seem to improve similarly. Yes, it is a factor playing a role, perhaps, but those patients with that extreme BMI are relatively rare, so maybe would not be justified to include in the definition of infertility. It's a problem, and it's a problem we don't know how to solve. It's a problem that we can't solve by even weight reduction. But in general, it is a health problem. Besides fertility, besides the risk of miscarriage, it affects many other outcomes, including cardiovascular health, morbidity, mortality. So it should be addressed anyways. So I don't think it requires a different management for fertility.
I would like also to ask the other speakers to comment, but just to add my point of view. So in RPL, it is well known the association with increased risk for pregnancy losses. And I think what we are missing is studies that include this intervention. So, but to do it randomized clinical trial and to do it correctly. Now, of course, everybody agreed that lifestyle is important and we should do it. But let me ask you again, if you have an unexplained infertile couple and you know that the woman is with morbid obesity, would you take some time to try to lose weight, or you ignore it because what you just explained? and you will start, the treatment or the process. Would you give some time for this change? Professor Baris or anyone?
So, I agree with recurrent miscarriage. There's a strong association between miscarriage and increased body mass index. I think the difficulty with intervention is if people get pregnant during a phase of acute weight loss, for example, if they've had bariatric surgery, we know that they have an increased risk of obstetric or pregnancy complications, because whilst you're losing a lot of weight, we think a lot of people are vitamin and all sorts of deficient. So the standard advice is in the UK is if you do lose a lot, if you are in a phase of rapid weight loss, for example, after bariatric surgery, you should wait until your weight before you try again. So I think that's why the data is so difficult to work out. It's quite complicated about whether their weight's stable, about whether they've made up for vitamin deficiencies during a weight loss. And I think it's really hard to do a good quality randomized control trial in this area.
But we all agree that if we have a chance to do something with this BMI, as we had just heard, it is associated with everything, any medical problems. What I'm doing, I am talking about nicely and giving time for this point, well, because I jumped a little bit from unexplained fertility to the unexplained. We still have some time to do all the evaluation, to go for all the procedures, the blood test. This is the time that we can have something, even if it is 5 kilograms. I think it's better than to, the obesity level, and those people are very highly motivated. So in my experience, it's worth it. Professor,
may I comment again? So it should be available in the supplement issue of Human Reproduction for last year's ESHRE meeting. And I know on Focus on Reproduction, there's an interview with Richard Legros, who gave a very nice plenary lecture about this. So he summarized the available data. So as I said, it is possible to reduce weight, okay? So by nutritional advice, by exercise, by combinations. But in contrast to our expectations, at least for IVF outcomes, improve, okay, with weight loss. So that brings in several questions. Once every, say, I mean, to be political, maybe we don't use the name obese, but so every high BMI is not necessarily metabolically the same. Only into some sort of weight loss intervention, it doesn't have to be as severe as bariatric surgery. Maybe inducing some sort of metabolic stress in their body. That's one of the possible explanations why the reproductive outcomes do not improve as expected. Right? The only thing that clearly improves is an anovulatory PCOS woman. They become ovulatory, but everything else, none of the studies were able to properly show any benefits. So it becomes a multifaceted problem. If you see a patient who is already 40 years old, who has decreased ovarian reserve, who hardly gets pregnant, then trying to make her lose weight and withhold other interventions meanwhile may turn out to be counterproductive. I mean, younger person with a better ovarian reserve, I mean, yeah, she should try anyways for her own health otherwise, but for it needs to be individualized.
Yes, absolutely. Professor Joachim, would you like to comment on this and the inflammation properties of this obesity and reproduction failure?
Yes, obesity can be also related to the inflammatory immune response, but it's not all of them. There's a different type of obesity. So sorting out them is probably the one thing we have to do. And that's why the data is all diverse. However, the infertility, in my opinion, the treatment of infertility is not simply make them to get pregnant. they have to go through the pregnancy and deliver a healthy baby with a healthy mom. And the BMI is actually related to the many second, third trimester, and of course the recurrent pregnancy losses. The obesity and the infertility, the IVF work is not really related to. So dropping all those guidelines worrisome, because infertility treatment is to make them to get pregnant. So I'm kind of agree to Dr. Bashiri's idea. Probably we're making women to make them a little bit more healthier before they go through the infertility treatment. Usually in my clinic, we take about at least 2 to 3 months to make them to control their weight as much as we can do. Certainly can be a trouble with many different issues. So we're going through slowly while we're preparing as much as we can do. And it seems like it can be very helpful. However, the randomized trial and all other things are kind of currently very difficult to do. So we have to do more study in the future.
Thank you. Yes. Professor Christiansen, yes, please.
I think now have come new efficient drugs on the market, Wegovy and Saxenda, and you should try to do randomized prospective studies, randomizing obese patients with recurrent implantation failure or RPL to these efficient drugs in one group, and maybe an open trial with no treatment in the other group, or some placebo, because I think it's the only way that you really can get the information about the effect of weight loss in these patients. So I think we should now profit of these drugs coming on the market and do randomized studies.
Definitely. So I would like to move to the second talk that Professor Christiansen gave us. And again, you showed very nicely your very, very hard work with ESHRE since 2013 with the first ESHRE guidelines, and now 2023, the modified or the new edition. I want to ask you again your personal opinion regarding the definition. So we all see that the new definition is it also included non-consecutive, it also included biochemical, and we all know it changed the prevalence, of course, and we have, let's say, bigger group with advantage and disadvantages. So I want to take it one step ahead. Do you think there is a special group of women, couple, that you will recommend to do evaluation after one pregnancy loss? Are there a group of women that will have some benefit from early evaluation, or I don't know, full evaluation, whatever you include there, but after one pregnancy loss?
It's a problem with resources, but if you have a woman with a clinical autoimmune disease, I would definitively do some tests after one loss. And if it's a woman with family history with several sisters or mother with recurrent pregnancy loss, 3-4 losses, then I would also try to do some testing after one loss. The problem is that in my public clinic, you don't have the resources for it, but if I get a patient with one loss, especially a late loss or at least a loss after week 10, and with a family history or clinical autoimmune disease or some other serious disease, I would try to do some testing after one loss.
What about a woman 42 years old and one pregnancy loss? Would you recommend besides PGT or PGS, would you recommend for these 42 years old women without children to do any evaluation? Healthy women.
No. Not in public clinic, I will not be allowed to do it, but in private clinic, if they are going to pay for it, I might do it, but it's not possible in public clinic. We close when they have past 41 years.
So in Israel, which is a social system, again, we don't do it, but I think in 42 women, healthy women, one pregnancy loss, which is most probably because of aneuploidity, there is a chance of, let's say, 20, 30%, 25% that there is something in the background. And I don't feel wait discussion with the couple. Sometimes maybe endocrinological evaluation for those who are maybe simple, but I'm not sure I'm right. I just think that maternal age putting us in a different way than the younger. What are the other speakers think about it?
Oh,
yes, please, Professor Quimby.
Because I think that every miscarriage matters to all women and we should take it seriously. I also don't think it's sensible to do a huge number of investigations. So I think we need to compromise. So in our Tommy's National Centre for Miscarriage Research, we have this concept called graded model of care, which means you do investigations appropriate to the person. So that's right. So in your example, the minimum investigations, I would say, would be a full blood count and thyroid function test because they're very easy to treat, and possibly antiphospholipid syndrome tests if they're over 40, because, you know, they haven't got many more pregnancies to try. So I totally agree with that. And so our idea is when you've had a high number of losses, then it is appropriate to do things where we haven't got trials to prove treatment, like septum, screening for septums and immunological tests. But when you've had a small number of miscarriages, to do straightforward tests. And I really think it's time to change from this concept of waiting till you have to have 3 miscarriages before you get a test. And that's so unacceptable in the UK. We had our charity that funds us, called the Thomas Charity, had a petition, and we had 270,000 people sign up to the petition to say it's unacceptable to wait for 3 miscarriages before you got tested. So it's a big part of my national campaign. So I'm delighted that you brought that up. It's my passion.
Okay, thank you. I agree. Okay, other speakers want to comment before we move to the next question? Yes, please, Professor Joaquim.
Yeah, I totally agree, and I kind of echo to Professor Quimby. Simply because of the number, make them to wait even though they're older age. They have autoimmunity, and they euploid embryo transfer, or the karyotyping testing is all clear, pathology shows something abnormal, then I think they need to start some kind of investigation instead of squashing them to go through the exactly same protocol again and waste another embryo or the pregnancy.
Yeah, and let me just mention what Professor Henrietta Svaren-Nielsen said in the last WCRP, the 6th Congress that was held in Bangkok in February 2023. She gave him an amazing lecture. And the question that she put was, are we going to have this entity recurrent pregnancy loss in 10 years from now? And her answer was no, because numbers will not be matter, and each pregnancy will be important enough to adapt and to do the specific or personalized evaluation according to the other parameters. Okay, so if we don't have other questions for the audience, I would like to move to the third speaker, but he's not here. I do want to ask you, my dear colleagues and speakers, what is your attitude in regards to the emotional or psychological evaluation before planning a new pregnancy? So we have heard, and we all know how much they are sick, mentally, post-traumatic depression, anxiety, the male as well as the female. It's very clear, many studies showing this. So in my clinical practice, I don't separate this morbidity from the uterine morbidity or sperm morbidity altogether. And what I'm doing in this period of time of evaluation, 2-3 months, I insist, I convince the couple to go to let's say, emotional evaluation, meaning intervention too. I don't let them start new pregnancy before they, let's say, do something. And many of them will go to maybe social worker, others will go psychologist, 20% of them are going to psychiatry, and it's written in the literature. My opinion is to do it for everybody, TSH level. I'm doing before we start pregnancy, because once they are new pregnancy and they are not emotional balance as much as possible, they are terrified. So my question to you, how much do you recommend to wait? How much do you really insist to do this before a plan a new pregnancy? Yes, who wants to comment?
In about 20 years ago in United States, ASRM, American Society of Reproductive Medicine, recommend every infertility cases to go through psychological assessment. But then they withdrew. I think mostly the problem was a financial issue or cost related, and also it delays the cycle and they don't see the benefit and they withdrew. I did actually one of the study with my master's student regarding the PTSS scale in women with a recurrent pregnancy loss. And our controls were actually the psychiatry outpatient clinic patient, not the really normal population. However, my patient had an even worse score than psychiatry outpatient clinic. So it actually got into the national topic one time. So that much stress they are going through. So I think in my clinic, usually when patient has an issue, when we meet for the first time, we directly refer them out. We're not automatically send them to the psychological evaluation. But if they have a problem, they are sending to. In the United States nowadays, some of the depression, anxiety cases are done by the primary care physicians, especially after the COVID. It gets a lot more attention. A lot of them are already on some kind of care, not particularly through the psychologist or psychiatrist, getting some help from the primary care as well. The current status, and I do, totally agree. They need mental support.
I think family physician can do it very, very nicely. Specifically when they have good relationship and they trust him or her. But in my experience, those who do not have any support, minimal support, some of them will go to, I don't know, mindfulness or CBT. And those who did not do, and also they tell me, listen, we don't believe in that. It's not our way of life, whatever. I see them very, very hard time in new pregnancy. But when I'm talking with, other colleagues, some will still say, no, it's wasting of time. It depends on the couple. Professor Quinby, what do you think?
I think this is a really interesting question. So in the UK, a lot of people do go to what we call the general practitioner or family physician with mental health problems after miscarriage. But my problem is that they get misdiagnosed with depression because a lot of general practice is normal to grieve after a pregnancy. In the UK, if you have a stillbirth at term, you are allowed to grieve after that, and you get time off work to grieve, and people accept that you're a grief thing. But for some reason, culturally, a miscarriage, people aren't. So that's another part of the Tommy's campaign, to say that after a miscarriage, you should be allowed some time off work and should be allowed to time for grief. So I'm very keen on counselling, as long as it's steps that you should have you should be allowed to have a grief reaction after miscarriage. And I think this is where we have to be very careful about what is a grief reaction, what is an excessive grief reaction, what is actually PTSD. And I think that this needs to be done by really good expertise, and that's why it's very difficult to achieve.
Okay, any other comments from our speakers? Yes, Professor Christiansen.
So far, I have offered support, psychological support for my patients by giving good time for the consultations when they come the first time. I had at least 1 hour, sometimes more than an hour. They come back several times for talks, and when they become pregnant next time, I could offer them a lot of assurance scans, almost as many as they needed. And I think that's the best kind of psych give them, and also encourage them to try again and convince them that the prognosis is better than they believe themselves. Unfortunately, we have now been hit by severe budget reductions in my clinic, so now I'm not in the position to offer them all these consultations, all these time for talks, and allowed to give them one assurance scan during the pregnancy, where I could offer them 5, 6, 7 before. So it's really depressing, and it's going really the wrong way.
Mm-hmm. Okay, so we now, I'm sorry, we move now to the next talk. So our issue is the low molecular weight heparin. So we had 2 talks, Professor Quinby and the ALIVE-2 trial. And I was next talking about all the aspects of low molecular weight heparin, including the APLA, what is clear, including what is coming clear about the anti-inflammation properties. So I'm going to make Professor Quinby life difficult. I'm really sorry for that. And you know, when I found your study, I know it was published in one of the hematologist congresses as an abstract. Now I see it in the Lancet. What can I say? So I would like you to comment on the I'm sorry, it was the 1 second. 1 second. Yeah, I wanted to say disadvantage. I don't know why I lose the word. The limitation of the study. And the limitation of the study that you wrote very clearly, I don't know, of course it was published, everything is very clear, but how much do you think that there is a chance, if at least not include one single pregnancy loss, the results may be different? I'm not talking about different low molecular weight heparin drugs. I'm not talking, about the fact that you did not look for heartbeat earlier, but at least the inclusion criteria with one pregnancy loss. And maybe you don't agree with me. I want to learn from you.
Yeah. So for that trial criteria, everyone had 2 pregnancy losses and inherited thrombophilia. So when we designed the trial, we thought that we had picked the group of people who would benefit from low. And then we did do a sensitivity analysis so that even if you had 3 pregnancy losses, there was still no benefit. So we checked all that. And then people have suggested that we picked a low risk group, but actually only 70% of people had a baby and 30% miscarried again. So we didn't pick a low risk group. If you're a patient and you've got a 30% chance of miscarrying again, that's high. So I would argue that we did pick a high-risk group, because not only did they have pregnancy losses, they also had an inherited thrombophilia that was tested for very carefully. So we could not have. I was really, really hard work at countries. We had nearly 30 sites in the UK and 30 all over the world. You cannot have gone to more effort, and there was absolutely no difference. So I think, it's very, very disappointing, but I think we really need to move on. I don't think that there's, the is that some people in the standard care arm did receive heparin, but when we reanalyzed it, having removed those, there's still no difference. I know it's not very popular, but that is what I found.
That's true, but maybe
I wanted it to find something else as well, but it didn't. So yeah.
No, but maybe I'm wrong and I didn't understand. Did you include also one pregnancy losses in this group of patients?
Two pregnancy losses, and they were all started the heparin before 7 weeks and 0 days. So they were all less than 7 weeks, just early as well.
And okay, but you didn't look for genetic analysis of the product of conception for the population, did you?
It wasn't possible with all those units, no. So we yeah, but because there was such a large number of people, they can't have all lost abnormal pregnancies. Because it was, it was over 326 people. So you can't, if it did, just obviously it would only be expected to stop the loss of normal pregnancies, but there was absolutely no difference in the two arms. So we don't think that is an explanation for the results.
It says that it may be making it possible that when miscarriages were included. What does it mean?
No, yeah. So it was recurrent, but it was two miscarriages. So I think it was about 40% had two, and 60% of people had more.
So maybe there is something that it's not clear to me. What does it mean? It's sporadic. Okay. Any other questions and any other comments for this very important, very disappointing results? But let me ask you, are you going to change your policy, Professor Quimby? Are you going from today not to give low molecular weight heparin to women with the hereditary thrombophilia?
Well, we're also short of money. We're more short of money than Ole in Denmark. I don't know what he's complaining about, but stop testing. So because of the trial, I've stopped testing. So I've said, and then that money I think is better spent on things like I would like to have more mental health support, as you clearly do, and they clearly have in the States. So we all have limited budgets, and I think it means that is not a good way to. That's how I've interpreted it. So I'm not spending any budget on that or heparin. I want to spend the budget on other things, which I think we don't doubt will benefit the patients.
So talk and ask you, do you give low molecular weight screening for hereditary thrombophilia? Because there is something that goes with inflammation in this woman, and you think about the anti-inflammatory properties of this low molecular weight heparin. If you give in these circumstances, who will be the women that you may consider?
Oh, so I only give it for prevention of venous thromboembolic disease. So in the UK, there's been a massive drive to reduce pulmonary embolism and DVT in pregnancy. So we have a risk scoring system, which has things like age, things that you have talked about, which is age, body mass index, number of previous pregnancies. So if you were hit, you get a point for each thing. So for example, if you're over 35, you had a body mass index of over 35, and you had 3 pregnancies before, then I would give it from 28 weeks to prevent thromboembolism. So the inflammatory thing, I would say, was more likely to cause thrombosis than it is to cause a miscarriage, and I would use it in those circumstances. So probably not that dissimilar. We also have getting pregnant by IVF as a risk factor for thrombosis. So whilst I can argue a lot, the truth is, yes, I do give it officially for prevention of thrombosis. But if you've had IVF, you're older, you're high BMI, you've lost lots of pregnancies before, you will hit enough risk factors for and I give it for that reason. So yeah, you're right. So I kind of, I kind of probably do give it to the same patients as you, but for another reason. So it's not as different as making out. But I tried to give my talk, but deliberately one side or the other when I heard you were talking, so that the conference attendees would have an opportunity to see both sides of the coin. That's right. Yeah.
Thank you. Yeah. What are the other speakers thinking about? Are you going according to this important study in the Lancet to stop screening, and as a consequence to stop treat those patients, or you still again consider obesity or other risk factors of thromboembolism? Okay, now we have another reason. What is your way of practical day?
Lucky enough in here, I can measure the inflammatory immune response and the thrombophilia together. And from the beginning of our protocol, we believe the thrombosis and then the inflammatory immune response are basically hand in hand. Simply having a genetic trend does not cause the thrombosis in many cases. You need to have something to trigger. So what is the trigger point? Is that the bleeding, thrombosis and inflammation, or inflammation to the thrombosis, or bilateral? So that was a thought, and if we see the increased risk, then we give it to them. So, from this recent study gives us a really good idea about what we need to do, and it was a good data. I appreciate all these long years of effort, but then regarding the treatment and how to apply it, then probably we need to still think about it. But I think in many cases here in the United States, it still gives us quite a good information to us. So we're still treating the patient with the heparin, and we approach it pretty similar way than before.
Mm-hmm. I just want to mention that I mentioned this in my talk. Meta-analysis and systematic review 2020 from, I think, infertility and sterility from China, 86 studies showing very clearly the association with hereditary thrombophilia, namely factor 5, factor 2, and protein S, and recurrent pregnancy loss. If I take Professor Quimby's attitude, so what I'm doing, because there is association, I'm looking for to see if I have the 5 or 15% chance to find this thrombophilia. If I find it, I treat it to prevent thromboembolic disease. So even if recurrent pregnancy loss, there is a reason for me to look for thrombophilia disease. So maybe we're still on the same place, but of course this study make a lot of issues all over, as according to what I see. Professor Christiansen, what do you think? What did you change in your attitude?
Yes, we published a prospective study in fertility sterility 10-15 years ago, finding that carriers of factor 2 and factor 5 Leiden had, I think it was a 20% increased risk of new miscarriage compared with non-carriers, and it was in patients not receiving anticoagulation. But after the study, we think that these hereditary thrombophilia factors are risk factors for new miscarriage, but we have not used heparin for patients with first trimester losses. We have offered it to patients with late second trimester intrauterine fetal losses, and who were carrying hereditary thrombophilia factors. We have offered heparin to this group, but not to those with only early miscarriages, and will continue to do it in this way.
Just want to mention again what I showed in my end of talk about the properties of heparin physiologically. So I do know and do believe that this drug, these molecules has a very clear anti-inflammatory properties. But of course, we have to work more in more studies to show what is the combination, what is the formula, including the epidemiological characteristics of the couple, of the women, to decide if this drug can be with advantage. Okay, we are almost late, I think, according to time, but I want to move to our last talk to Professor Joaquim. And let me also challenge you and ask you a very, I don't know how to say this, a very not easy question. Okay, so you convinced me very clearly that natural killer cells are important, and all, you know, the effect of immunological drugs is there. We don't know exactly to whom, let's say this. My question, why so far natural killer cells evaluation, it doesn't matter now which test, okay, but why so far it's not coming to be guidelines? What are we waiting for? What is still missing to recommend it as a routine test? Because I don't know any other, you know, I don't know any other test that besides, you know, Anna. It's kind of a screening, but you showed very nice results. I know also the studies from others, from Christiansen and Quimby and Brossens, but I don't understand. We still not recommended, don't do it. It's not routine. What do you think? When is it going to happen? Or maybe not?
I guess there is a gap between the immunological understanding on the endocrinology side. So there is some gap as an IVF physician understand the immunology. That is one thing. And there is always some of the question about how does the NK cell actually working at the implantation site, and how the working directly to the trophoblast. That's been quite a bit of debate for the last few decades. And I think nowadays it's getting cleaner and more we learn about the angiogenic role of NK cell. And there are still ongoing studies regarding the HLA typing of the father, and then the KIR expression of the mother, or the HLA-C typing of the mother and the KIR expression. So there's quite a bit of study ongoing, and these studies are coming out, and then everybody's saying, since we don't know well, and how can we apply this one? I think as a scientist, I understand that point too. But then when we use the white blood cell count testing for the general infectious disease, when we apply that one for screen the cases, and although white blood cell count testing really did not give you exact findings about the ongoing infectious disease, we're still using it as a marker to screening. So that's why in this talk, when we set up the diagnostic testing, why are you using diagnostic testing for what, and what can we get it out of it? So that's my talk. And there's some scientific backup there, and then it shows the clinical course. It also shows the outcome of the certain treatment. So I think for the time being, NK cell testing can be a good guideline to select the patient who deserve the immunotherapy. In the future, if you have a better one, then certainly we need to move on. But simply squashing them because you don't understand or worry about the money and all other things, I don't think it can be really justified on my end. By worrying about that money, actually, the women are going through the pregnancy loss. Nowadays, when women go through the pregnancy loss, even simple hospital-related fees are over $18,000 in some cases. So when you compare those dollar amount, selecting the patient who has some evidence of those immune etiology, like even sometimes you get into quite a big discussion about running thyroid antibody and running anti-nuclear antibody, gets into the big discussion. But then when you see the outcome, and then when you go through losing the IVF cycle and losing the pregnancy, you're losing a lot more than what you're actually spending. So I think we probably need to change our attitude after a few decades of endless discussion about what testing can be done, what testing cannot be done. Don't run this, don't run that. I think guideline is telling basically don't do that, then instead of do this one. And I think we may have to kind of review one more time and what is actually beneficial for women's health in the future.
Thank you for this. Professor Quimby, Professor Christiansen, any comments for the immunology, for points from Professor Joachim lecture?
Yeah, yes, I mean, I think Professor Joachim's got a very good point. You know, the patients desperately want a reason for their miscarriage and find it very difficult to live without that. And therefore, if they want to be tested, that I think that's a very clear argument. And the other massive challenge we have is that when we were doing one of my recent trials, we asked patients what increase in the live birth rate they felt would be enough to have an immunological test and a treatment. And they said if our treatment only improved the chance of you having a baby 1%, they'd want it. And I think we've got this big problem between the patients and the statistics, and we need to find some middle ground. I think that's where the future is going to lie.
Mm-hmm.
Yes.
Yes.
So far, I'm not convinced about the usefulness of NK cell test because the study has been published. Many of them are too poor quality. It's highlighted by the new better studies coming from Innsbruck from Bettina Todd's laboratory, finding that having gone through a pregnancy will change probably permanently for many years your NK subsets, especially in the uterus, but also in the blood. So when you do case control trials of NK cells, you should compare primary recurrent pregnancy loss patients with patients who have never given birth. You should compare secondary recurrent pregnancy losses patients with patients who have previously given birth. And such studies have very rarely been done. You cannot compare bananas with apples. So we need better case control studies. And also the NK cell activity and numbers are very dependent on the hormones, progesterone especially, and estrogen. So you have to really, in some way, adjust the findings for the levels of hormones. So soon we'll publish a randomized control study of immunotherapy to patients with recurrent pregnancy loss, where we have tested for NK cells and T regulatory cells and all kinds of relevant cells in patients being treated actively and patients having placebo and tested before pregnancy and during pregnancy. Maybe this study, it will be finished in a few months. We have included almost all patients now, and maybe this study will convince me of the usefulness of using or testing for NK cells, but so far I'm not convinced.
There is a recent randomized trial done by the Japanese group, which is actually reflecting to change IVIG guideline. They measure the Treg cell and NK cell cytotoxicity assay after IVIG, and that randomized trial actually demonstrate the changes in those numbers. So you may see that.
Very interesting.
Mm-hmm.
And yeah, I think we have to finish. And I think this is the time to close the session. I'm not sure if the speakers were in the beginning when I started my talk. I want to ask you one more minute to mention very shortly what I said in the beginning. And this is what is happening in Israel right now. The big tragedy with the terrible terror attack with the Hamas here in Israel, in the country, in the settlements, with citizens, with more than 1,400 murdered people, children, women, elderly, 224 that were kidnapped to Gaza, it's nothing different from the Nazis. And it's really tragedy what happened in our every place here in Israel, looking, of course, to have peace for many years, but becoming so every place. And what I want to ask you as colleagues and friends, as physicians, please don't be silent. Please do what you can to condemn this terror and to understand that once this will be behind us and terror will be every place, we don't want to say, how did it happen? What did we do for this to prevent it? I will be happy personally with each one of you and really share this with your societies and universities and colleagues. I think this is humanity, and this is what we are as a doctors have to do, because what happened in October 7, you will not believe, and it is really, really as what happened with Hitler. And when I was young and during the years, I was asking myself every time, how come Hitler became conquering the world? How come, where was the world and where were everybody? And I think silence can bring this. Thank you very much for listening to me. Thank you very much for your participating in this Congress. And I hope also for the Ukraine people to have peace and to win your condition very, very soon. And hope to meet you next year in Ukraine, in Kiev, as we had before. Thank you so much and have a great weekend.
Bye.
Bye-bye.
Good afternoon, everyone, and welcome to the session 2 of the Recurrent Pregnancy Losses and Human Reproduction 7th Annual Conference. This session is named Evaluating the Diagnostic Landscape in RPL in Infertility Patients, and we will try to go through the different landscape evaluating the embryo, the endometrium, and also how to analyze the products of conception when a miscarriage happens. So let's start with the session, and I guess that I should introduce myself. My name is Nasser Al-Asmar, and I received my bachelor's degree in pharmacy. I'm graduated in a specialization in genetic counseling and clinical genomics, and I hold a master's degree in biotechnology of human-assisted reproduction at Valencia University in Spain. Also, I got my PhD in biomedicine and biotechnology at the same university. I was laboratory director at iGenomics USA in Miami, Florida, from its opening in 2012 until January 2016, when I became scientific advisor first in the USA and after that for Spain and Latin America. I am member of the permanent board of the Genetics Interest Group of ASEVIR, the Association for the Study of the Biology of Reproduction. And I am professor at the Masters of Biology and Technology of Mammal Reproduction at the University of Murcia, Spain. I've over 15 years of clinical and research laboratory experience, first at EV Valencia Clinic in Spain at the Preimplantation Genetic Diagnosis Laboratory, and after that at iGenomics at the Preimplantation Genetic Screening Laboratory, and then also at iGenomics in USA. This year, I had lectures at international congresses in several countries such as Brazil, Colombia, India, Singapore, Malaysia, USA, Spain, and many more, on all the different topics of reproductive genetics. Currently, I'm scientific director of the iGenomics Academy, part of the Vitrolife Group. So I guess that I should now start my presentation. So, hello again. As you know, I'm going to talk about the PGTA new features. But prior to that, I would like to thank the scientific committee again for inviting me to be here today, and also showing my small disclosure as a worker for iGenomics, part of Vitrolife Group. So let's move into the PGTA evolution. You all know about this evolution graph that I presented several times. We started with the PGTA in 1995 with the FISH technique. And at that time, we were able only to analyze certain panel of chromosomes, panels of 5, 7, 9, up to 12 chromosomes, but we were missing information. So starting in 2008 with the array CGH, and later on, 2010 and 2012 with the SNP array and qPCR respectively, we were able to analyze all 24 chromosomes, the 22 chromosomes and the sex chromosomes. Starting in 2013, we developed the tool of the NGS in our field, because this technique was used in other medicine fields before, but we started introducing in our field in 2013, and also incorporating the artificial intelligence in order to better diagnose uniform aneuploidy and also mosaicism. And starting in 2022-23, we are able right now to analyze another conditions that are the new features, that this is going to be the second part of my lecture. But let me start from the basics. You all know about the PGTA, but still controversy. So let me show you a small introduction regarding the aims and the indications for PGTA. Also, some of the papers that support the idea to use the PGTA, and then we will go with the new features that we can offer right now to our patients. So starting with the aims, we are going to do PGTA to assess the embryo viability, because we will improve our implantation rates, we will decrease our miscarriage rates, we will decrease the risk of an abnormal offspring, And also for certain type of patients, we are going to have better time to pregnancy, could be also cost efficiency. And there's also something that it's really hard to measure, that is the emotional burden having a miscarriage. So if we do PGTA, those miscarriages that are due to a chromosomal abnormality, that we do know that more than 50% miscarriage on the first trimester are due chromosomal abnormalities, even up to 60% in patients undergoing assisted reproductive techniques. So indications: advanced maternal age, recurrent pregnancy loss, that it's the congress that we are having right now, the conference, repetitive implantation failure, severe Mer factor, to have a prior pregnancy or child with a chromosomal abnormality, and also, why not, good prognosis patients that want to perform single embryo transfer, and they want to transfer this embryo that is going to have higher chances not only to implant, but also to have a healthy baby at home. Because remember that patients don't want to get pregnant, but to have a healthy baby at home. So let's talk about different papers regarding PGTA. This first one is the STAR trial, was a prospective randomized study in almost 1,000 patients under 40 years old or 40 years old, when the authors told us that they found a significant increase per transfer in ongoing pregnancy rates in women with 35 years old or older. And you can see at the table that the ongoing pregnancy rate at the control group was 37% versus almost 51% in the group of PGTA, being statistically significant. In this other study from the group of Professor Griffin, it was a retrospective study including almost 2,500 PGTA cycles, and almost 200,000 non-PGTA cycles, and then they were comparing both of them. And the authors found that there was a significant increase in live birth per all cycles for every age range, and this was more relevant in women over 35 years old. In this other paper from the group of Jan, they compared PGTA in young patients with almost 2,000 patients under 37 years old, and they described that there was no significant increase in cumulative live birth per patient in those women. But we all know that we are not going to have better cumulative live birth rate doing PGTA, and I will comment this later on. In this other study, also in young women, it was a retrospective cohort in 232 single embryo transfer patients 35 or younger in more 1,200 patients. And what the authors showed to us is that there was a significant increase in live birth per transfer in women with 35 years old or younger, and also in those patients going through egg donation program. This study I showed like a couple of years ago in this same conference, but it's really relevant for us because it was performed in patients with recurrent pregnancy loss. It was a retrospective study including more than 12,500 frozen embryo cycles in more than 10,000 couples with recurrent pregnancy loss. And what the authors found is that it was a significant increase in live birth rate and clinical pregnancy for every single age range, and it was more relevant in women with 42 years old or older. How about the outcome parameters? Well, in this paper, we can find that it was a decrease in time to pregnancy, and this is important because patients doesn't want to get pregnant tomorrow, but yesterday. So they found a decrease in the time to pregnancy and cost in patients with 42 years old or younger with at least one embryo. Obviously, we need at least one embryo in order to be analyzed. And also in this paper from Somigliana, they found cost effectiveness that increases with age and number of available blastocysts. It was superior for women over 35 years old and for those ones with 35 years old with at least 3 blastocysts available for analyzing. So talking about level of evidences, we have with the RCTs that doing PGTA, we found higher live birth rate per single embryo transfer. We can minimize the miscarriage due to chromosomal abnormalities. We reduce as well the abnormal pregnancies. We will reduce in some kind of patients time and cost, and there's apparently no impact in cumulative live birth rate, but this is something that we already know. We so far are not curing the embryos. Hopefully in the near future, we will be doing it because CRISPR-Cas or maybe another techniques that we are developing right now. But as again, so far we are not curing the embryos, but we are avoiding keeping doing transfers without pregnancies or pregnancies with a miscarriage that cost money, cost time, and also the emotional burden that I mentioned before. What are also a challenge that we have now in PGTA? Technology. We need validation for the platforms and validation for the algorithms that we are using. So we need to define the minimal resolution of each NGS platform to detect deletions, duplications, these small losses or gains, and identify the presence of mosaicism. It's important, you know, that it's a hot topic right now in our field, the mosaicism. So we need good platforms and algorithms in order to properly make the calls for mosaicism. So we need to create bioinformatic pipeline and diagnostic algorithms to avoid the subjectivity linked to the visualization of the genomic data. And I always explain the same. I used to be tons and tons of profiles, but if suddenly I receive a call from a physician telling me, Nasser, we transfer an embryo that you told us that it was euploid, but the ultrasound looks like that it's something weird, I can tell you that I'm not going to make the same diagnosis, not today, not the next few days, because as a human being, I'm subjective. But having an algorithm trained by ourselves, but this algorithm is going to make the same call today and the rest of the days. So this is the way that we need to make the calls. And this is what we do in our lab. This is an example of what we call smart PGTA. So we are trying to do automatization as much as possible, trying to reduce the possibility of a mistake. So once we receive the samples in our lab, we enroll the samples in our system that it's called Navision, and it automatically creates a working order. So the working order is put all in place to make us easier to have a traceability during the whole process, not losing this traceability. So being sure that whatever is getting in our lab, it's getting out with a proper result. So after that, we will do a semi-automated NGS protocol. We are again automating as much as possible in order to reduce the mistake. And after that, we are transferring the data to our bioinformatics server, and we are using our own diagnosis algorithm, smart PGTA algorithm, that is internally validated, and we publish this validation. And then we will do a diagnosis with the results that we will be transferring again to our system where a specialist from genomics will review and validate, and then we will create an automatic report that is automatic release to the IVF clinic. And we are minimizing the typing errors or whatever, doing things by hand. Those are some of the profiles that you already know regarding smart PGTA. On top, we have a normal euploid embryo. Then we have an example of aneuploid embryo, in this case with a monosomy for chromosome 2. Then in the middle, an example of a deletion, in this case in the P arm, the short arm of chromosome 5. Then we have a complex result we call complex between 2 to 5 abnormal chromosomes. And on the bottom, we have a chaotic profile. That means that looks like that never is when should be there. So mosaic embryos, and I'm going to stop only like 1 literal minute in here. And again, we have to do internal validation, technical validation to publish the validation in order to make the calls for the mosaics properly, what we do in our lab is that we put different thresholds. From 0 to 30% aneuploid cells, we call the embryo normal or euploid, because we do think that below 30%, we could be overdiagnosing mosaicism, and this could be noise from the technique. So we will call it euploid. From 30 to 50% of aneuploid cells, we will call low mosaic degree embryo. From 50 to 70% on aneuploid cells, we will call it high mosaic degree embryo. And over 70%, we will call the embryo aneuploid. So bear in mind that right now, the guidelines from the different scientific committees tell us that we must not tell an embryo that is mosaic as an abnormal, because we will be reducing the chances to the patient to get pregnant. We do know that low mosaics has a really good reproductive prognosis. So always having a genetic counseling, we should consider after transferring the euploid embryos, or if we don't have any euploid embryo to transfer, we might consider to transfer, always again, having before a genetic counseling, then transfer a mosaic embryo, even more with a low mosaic embryo. High mosaic embryo so far has bad reproductive diagnosis or reproductive results, but still has to be considered after a proper genetic counseling. So let's move into the second part of the talk, and this is the PETA new features. And we do know, again, that doing a PETA with a regular NGS, we will be able to tell if the embryo is euploid or aneuploid. But one of the limitations, and you all know that doing the NGS, is that when we call an embryo euploid, we don't know for sure if this embryo is diploid. This means that it has 2 sets of each chromosome complement. That is the normal one. But this embryo could be haploid, having only 1 set of each chromosome complement, or triploid, having 3 sets of each chromosome complement. And we do know also that the haploidy and triploidy are both compatible with the preimplantation embryonic development, and also that the triploidy can be found in around 10% of chromosomally abnormal spontaneous miscarriage. This should be lower if we use ICSI to do the fertilization, but keep in mind that between 5 to 10% of the miscarriage, spontaneous miscarriage, could be due to triploidy. So what is a Smart PETA Plus? We call Smart PETA Plus and those new features that I'm going to comment right now. So right now, what we can perform, not only in our lab, but in several genetic labs, is to perform first, obviously, the Smart PETA, that is the regular NGS that we are performing right now to know the chromosomal status of the embryo prior to make the embryo transfer. But also we can do a genetic pronucleus check and diploidy, and I'm going to develop in a few what this means. But also we can do what we call embryo quality control, checking for possible contamination on the tube, either external or internal, coming from the cumulus cells, and also perform a siblings quality control. That means that, and I will develop a little bit later, we can check that all the embryos that we have from the patients pertaining to this cohort are coming from the same source of sperm and oocytes. So how we do perform these parts from ploidy and maternal contamination, external contamination, and siblings QC? Well, we have a target NGS custom panel targeting 357 SNPs. And we do know that those SNPs are distributed through the genome and are frequently polymorphic between individuals. And the vast majority of these SNPs have only 2 different alleles. And this is how we can do the test for ploidy, for contamination, and for the siblings. So let's start with the ploidy analysis and plurinuclear check. And the thing is that this is what usually embryology sees. And you know that if we have a normal fertilization, usually we observe 2 pronucleus in the embryo. But if we have abnormal fertilization, we can see 0 pronucleus, 1 pronucleus, what we call 2.1 pronucleus, that means 2 pronucleus and 1 that it's smaller, or 3 pronucleus. This is all of them abnormal fertilization. And let me show you the difference in between when we analyze diploidy for normal and for abnormal fertilization. But prior, and this is the thing, is that even if we find a euploid result, the problem and the limitation with the regular PGTA is that the program normalizes the result. That means that if we have 3 copies of each chromosome, that it would be a triploid, the program normalizes it and make the call as a euploid normal. And if we transfer this embryo, we are going to have either on an implantation failure, a miscarriage, or a molar pregnancy, that we do know that most of the molar pregnancies are due to a triploid embryo. So, well, this study was performed in a normal fertilization, 2 pronucleus, from our colleague from Genomics Spain, Jose Mirabet. We presented this year in PGDIS in Paris, and we analyzed more than 1,000 biopsies in 2 different labs. And what we found is that the incidence of triploidy, it was low. It was below 2%. You can see it was, in this case, 1.86%. So if we have normal fertilization, we should expect low incidence of triploidy, but still there are around 2% that are going to be triploids. So we will have either a miscarriage or a molar pregnancy. We do know that abnormal fertilized oocytes in IVF are around 10% of the cases. And our colleague, Laura Girardi from iGenomics Italy, presented this work in ESRE this year in Copenhagen, in Denmark, and it's about to publish the paper. What we did in this case was to use 318 biopsies from abnormally fertilized oocytes. We performed the whole genome amplification, performed the NGS for aneuploidy, and for those ones that were euploid, then with an aliquot of the whole genome amplification, then we performed the SNPs to analyze the ploidy level. In this case, we obtained 42% of the embryos that were euploid, and analyzing when we had seropronucleus derived blastocysts, up to 93% were diploid. So we can rescue those embryos. From those that were 1 pronucleus derived blastocysts, almost 60% were haploid, but still 35% were diploid. We can rescue those embryos. And when we observe more than 2 pronucleus derived blastocysts, 66% were triploid, but still 33% were diploid. So we might rescue those blastocysts. So doing the ploidy analysis and genetic pronucleus check, we will have more diploid candidates for transfer after abnormal fertilization or no fertilization, and lower transfer of embryos with ploidy abnormalities. What could be the indications for pronuclear check? To rescue embryos following abnormal fertilization that usually in most of the labs are discarded, patients with a reproductive history of triploidy or haploidy, patients with recurrent miscarriage, and this is something interesting for all of us in this conference, patients with a complete or partial molar pregnancy, that we do know that to have another polar or complete or partial molar pregnancy, it's increasing in a few, but still there, and the patients don't want to go to the same way. And patients with severe malfactor or high rate of diploidy in the sperm. Those could be some of the indications. Let's move into the contamination analysis. And this is the study of the validation that we perform. As you can see, we design a laboratory mixes in order to obtain contamination from 20 to 80% ranges. And we did also in silico by bioinformatic mixes from 10 to 90%, obtaining 100% of sensitivity and almost 99% of specificity. And we will expect an incidence of contamination lower than 0.8%. So we do know that the contamination can mask the true chromosomal status of the tested embryo. So this could lead into a potential misdiagnosis. And doing the PGTA plus, smart PGTA plus, we will detect an admixture of exogenous DNA, either external or maternal DNA, and the detection ability for contamination will be between 10 to 90%. Those are the limits. And again, an estimated 0.8% of trophectoderm biopsies can be contaminated. So this is why we will be checking for this. Talking about sibling relatedness analysis, we again perform the validation in order to know in a same run which embryos pertain to each family, with a sensitivity again with more than 90% and a specificity again almost 99.8%. So now with those analyses, the expected incidence of sibling mismatch is really low. That is a good thing to know for our labs, but it's still there. Should be lower 0.2%, but it would be really important if we can catch this. So the embryo fingerprinting, we don't need additional samples from the egg or sperm provider. We don't need blood drawn from the patients. We will assess the genetic relatedness between the embryos in the cohort, confirming that all the samples analyzed are originated from the embryos fertilized by the same egg and sperm source. The apparent mismatch again should be lower than 0.2% of the samples. And these causes could be because the embryos derived from different donors, or there's a true mismatch in correct embryo biopsy tubed in the IVF lab or in the genetic lab. And this is good to know prior to release the report, prior to make the transfer, prior to talk with the patients. So just to conclude, I have to say that doing this smart PGTA plus, we will reduce the risk of miscarriage due to previously undetected abnormalities. We will increase the number of viable euploid embryos available for transfer. This enhances the accuracy by reducing the risk of misdiagnosis through the implementation of external and internal DNA contamination detection. We will provide definitive confirmation that all embryos within the same patient are genetically fully siblings, and we will ensure enhanced efficiency and quality control in the laboratory procedures conducted within your IVF lab, providing greater assurance. And prior to finish, I would like to thank all my colleagues in iGenomics, not only at the R&D team, but also at the clinical teams. And of course, I would like to thank you all for being here today with us. So I will be waiting for your questions in the Q&A session. Thank you very much. For the next lecture, I would like to introduce you Dr. Tiffany Stankiewicz, that is an endometrial specialist and senior scientific advisor at iGenomics. She's a seasoned professional with over a decade of clinical laboratory experience as an embryologist, certified by the American Board of Bioanalysts, ABB, as a technical supervisor TS in both embryology and andrology. Dr. Stankiewicz brings her expertise to elucidate the endometrial test, encompassing the endometrial receptivity, the endometrial microbiome, and the chronic endometritis molecular test. Currently, Dr. Stankiewicz is the endometrium product director at iGenomics, part of Vitalife Group. So Tiffany, please, whenever you want, the stage is yours.
Hello, My name is Tiffany Stankevich, and I would like to thank you for attending this talk today and inviting me to speak on optimal implantation solutions preparing a healthy and receptive endometrium. As a disclosure, I am the endometrial product director at iGenomics, which is part of the VitraLife group. So let's jump right into this talk. I'd like to share with a shocking statistic, I think, in my opinion, is that live birth rates following IVF today are still only 25 to 30% per started cycle worldwide. Now, we know that implantation is a significant rate-limiting step in human reproduction and IVF. So the implantation process itself hinges largely on two essential players, the embryo and the endometrium. So for years, we have a focus on optimizing the embryo. This is evident with insemination techniques, so the introduction of intracytoplasmic sperm injection, for instance, optimizing our culture media, optimizing our incubators, optimizing our freezing techniques, moving from slow freezing to vitrification, which has much better survival rates, and introducing more advanced technologies such as PGTA for aneuploidy screening. But even in advanced technologies such as PGTA, we see that implantation failure still occurs about out of 1 of 3 of these cases. So for that reason, we need to look to the other player, which is the endometrium. Now, it's obvious looking at the periconceptional space that the endometrium is an integral part of implantation. From the moment that the embryo encounters the endometrium, it's going to encounter the endometrial microbiome, or the bacteria living within the endometrium. From there, maternal embryonic crosstalk needs to occur between the implanting blastocyst and the endometrium itself. Endometrial receptivity is important since an implanting blastocyst can only implant into a receptive endometrium. And then if this all goes well, hopefully we have good deciddualization and placentation. So for today's talk, we're going to focus on the endometrial microbiome and endometrial receptivity. So since the endometrial microbiome is the first introduction that the embryo has to the endometrium, this is where we're going to start. So the Human Microbiome Project was launched in 2008, and this highlights the importance of different microorganisms such as bacteria and their genomes in human health and disease. Identification of dysbiotic or pathogenic microbiomes may be key to improving clinical outcomes in various areas of medicine, including IVF. Some fun facts: humans have 10 times more bacteria than human cells in our body. In a person weighing 70 kilograms, approximately 1 kilogram is made up of bacteria. A high abundance of bacteria is found especially on the skin and digestive tract. And between 20 to 60% of this bacteria, depending on their location, are not culturable under standard laboratory conditions. Now, bacteria present in the urogenital tract make up 9% of the total human microbiota, and most of them are not easy to culture. A normal vaginal microbiota is defined as the presence of bacterial species of the Lactobacillus genus that are commonly associated with a healthy genitourinary status. The vaginal microbiota typically changes throughout the menstrual cycle, and these changes can lead to several pathologies that could have implications for both reproductive and obstetric processes. Now, we know that the microbiota is a continuum throughout the female reproductive tract, where we see in the vagina, it's mostly composed of lactobacillus and has a very high biomass. Now, this biomass is going to decrease as you move up to the ovaries. However, the diversity of bacteria present is going to increase. Now, recent research has identified the existence of an endometrial microbiome and has demonstrated that dysbiosis of the uterine cavity is associated with poor reproductive outcomes in assisted reproductive treatment patients. So let's look here at the first figure on the left. What we did in this earlier study back in 2016 is that we took endometrial fluid and vaginal aspirates from the same woman at the same time. And what we found was that the endometrial fluid contained bacteria that wasn't present in the vaginal aspirate and vice versa. So this showed that the endometrial microbiome was unique and not just simply carried over from the vagina. So we now know that the endometrium bacteria should be there, and it's not sterile as we had once assumed. Now, we went on to look at the endometrial microbiome and subsequent reproductive outcomes in patients. And what we found was that women with a high presence of lactobacillus, as signified by the blue color here, and very little other bacteria, particularly pathogens, had a higher associated live birth rate versus those women with poor reproductive outcomes. These women, you can see, had much lower levels of lactobacillus, again, the blue color, and much higher presence of other bacteria, particularly pathogens, such as Gardnerella, as signified by the red color. In fact, bacteria such as Gardnerella, Streptococcus, and Staphylococcus were associated more strongly with poor reproductive outcomes. Now, in the same paper in 2016, we went on to perform a pilot study in which it suggests that pathogenic variations of the endometrial microbiome could play a role in infertility. So here, 32 patients underwent a personalized embryo transfer as guided by the ERA for receptivity. And we divided it based upon their endometrial microbial constituents at time of endometrial biopsy. And we had a lactobacillus dominated group where we saw primary lactobacillus, so 90% or more, and very little or to no pathogens. And then we had a non-lactobacillus dominated group where it was less than 90% lactobacillus, and the presence of other bacteria was there. And what was found that there was a significantly higher pregnancy rate, implantation rate, ongoing pregnancy rate, and live birth rate per transfer in the lactobacillus dominated group versus the non-lactobacillus dominated group. We also saw a difference in miscarriage rates between the two groups, although this was not statistically significant. So in the group that had a high presence of lactobacillus, a miscarriage rate of 16.7% was observed, whereas the group with a lower level of lactobacillus and higher presence of other bacteria, including pathogens, had a 60% miscarriage rate. So not only does it appear that the presence of pathogens, associate with poor implantation failures, but also poor maintenance of pregnancy as far as increased miscarriage rates. Now, there have been other groups that showed that lactobacillus is the most abundant genus in the endometrium. So I think it's clear that we know that the endometrium is not sterile as we had once assumed. And I think a great way to show the effects of the endometrial microbiome on reproductive outcome is to highlight a case report that I share here. Now, this is from the same patient, and we had endometrial fluid taken in the cycle that led to the miscarriage versus endometrial fluid that was taken when the patient was 4 weeks pregnant. So it was unbeknownst to both the patient and the provider at the time that she was actually very early in pregnancy. But this gave us the first glimpse of the endometrial microbiota in early pregnancy. And we can really see a difference between the bacterial profiles in the miscarriage versus the pregnancy. So in miscarriage, we have very low presence of lactobacillus as signified by the dark magenta color, and a high presence of other bacteria. We can see a lot of diversity here, particularly with pathogens. Now, when we look at the microbiome at time of pregnancy, we can see quite the opposite. So a very high presence of lactobacillus and very low presence of other bacteria was here. So I think this is just a beautiful example within the same patient, how the microbiome can really affect reproductive outcome. Now, I think the best example of pathology caused by an altered endometrial microbiome is chronic endometritis. This is something that we're all well aware of, which is the persistent inflammation of the endometrial lining mainly caused by bacterial infection with common pathogens that include Staphylococcus, Streptococcus, Enterobacteria, Enterococcus, Mycoplasma, and Ureaplasma. Now, patients are usually asymptomatic and thus seldom diagnosed and treated. The prevalence rates are estimated to be anywhere between 0.8 to 19% in the general population, 30% in the infertile patients, and upwards of 60% in recurrent implantation failure and repeated pregnancy loss groups. Chronic endometritis may influence the reproductive function, decreasing success rates in ART and increasing obstetric complications. And we know that it's not detectable by ultrasound. So the gold standard for diagnosis has been histology, though hysteroscopy and microbial culture have also been classically used. And the most frequent treatment is antimicrobial therapy with broad spectrum antibiotics. So this is what we need to focus on here, just to keep in mind broad spectrum antibiotics, and we'll see why in the next slides. Now, as I said, 3 classical methods used have been histology, hysteroscopy, and microbial culture. However, these methods provide inconclusive or misleading results in about 80% of cases. So while we see that histology tends to underdiagnose the disease, hysteroscopy tends to overdiagnose chronic endometritis. Now, microbial culture to some degree does allow for objective diagnosis. But however, since between 20 to 60% of bacteria cannot be cultured under standard laboratory conditions, we can sometimes see false negatives being reported. So this is really where molecular assessments such as the Emma and Alice test shine, because it allows for an objective result. So we can see which bacterial DNA is present in the endometrial biopsy sample, which allows for a more targeted antibiotic treatment versus what I mentioned before, the use of broad spectrum antibiotics, which may not even target the bacteria present in the endometrium, not to mention, leading toward antibiotic resistant bacteria. So I think we need to all do our part, not only to optimize a patient's microbiome more effectively, but also reduce the use of broad spectrum antibiotics. Now, on top of this, the molecular platform can do something beyond microbial culture in that it can detect bacteria, even those that are not able to be cultured. So we see less false negative rates when we consider this. On top of that, we have a very short turnaround time with a molecular method versus something like microbial culture, where we need to rely on the bacteria to grow and proliferate. With molecular, it's a matter of hours in order to see the bacterial DNA present. Now, I mentioned a few times the Emma test. So Emma stands for endometrial microbiome metagenomic analysis, and this is a molecular assay that's used to determine whether the uterine microbial environment is optimal for implantation. So this is based on detecting and measuring the amount of DNA present in endometrial samples. So here we looked at 4 species of lactobacillus. So again, lactobacillus is a good bacteria. They act as a safety net to prevent the bad bacteria pathogens from growing. We look at reproductive tract pathogens. And then we also look at chronic endometritis causing bacteria. And this we refer to as our Alice test. So Alice specifically looks for chronic endometritis, where Emma is a full microbial view that includes Alice. Now, I like to bring this, I want to introduce, this is a recent ESHRE good practice recommendation for RAF. And what we see here is that Emma and Alice can be recommended for patients suffering from RAF to investigate chronic endometritis, because chronic endometritis, as mentioned, has been associated with RAF and RPL groups. So again, an intervention, or I should say investigation, that is part of the ESHRE good practice recommendation. Now, what do we do when we find pathogens present in the endometrium? How can we ensure proper treatment? And I think we went over the fact that, broad spectrum antibiotics are not always going to be the most effective route. So I would like to share with you a recent publication from a group in Japan led by Dr. Iwami. And here, what they were doing is determining if the analysis of endometrial microbiome and its recommended treatments have positive impacts on pregnancy rates in patients with RAF. So this was a prospective cohort study in a single center from Japan that included 195 women with RAF. They used the EMA test in order to analyze endometrial biopsies. And the primary outcome here was cumulative clinical pregnancy rate after 2 additional ETs. Now, what they found was that 1 in 4 patients needed antibiotics to treat a pathogen detected on the EMA test. And 90% of the antibiotics administered in this study were not broad spectrum, but are instead targeted to the specific pathogens detected. Again, this is the advantages with a molecular technique such as EMA. And they compared the study group, which was those patients who underwent the EMA test and corresponding antimicrobial treatment, versus the control group who did not undergo any microbial testing. And what they found was significantly higher HCG positive rate, clinical pregnancy rate, ongoing pregnancy rate, and delivery rate in those patients who underwent microbial testing and any subsequent treatment versus those patients who did not go under any treatment. So I think the conclusions here is that the vaginal and endometrial microbiome are different. Lactobacillus is the most abundant genus in the endometrium. A lactobacillus dominant endometrium is associated with better reproductive prognosis in IVF patients. The presence of pathogens in the endometrium is associated with implantation failure, recurrent miscarriage, preterm birth, and the endometrial microbiota composition before embryo transfer could be a useful biomarker to consider, offering an opportunity to further improve diagnosis and treatment strategies. So now moving on to the other topic, which is endometrial receptivity. Now, we know that there are various changes occur throughout the menstrual cycle, where we see varying biological functions activated accordingly. Now, it's important to remember that the embryo can only implant in the endometrium with a receptive phenotype, as indicated by the window of implantation that occurs during the mid-secretory phase. Now, in most women, this is going to be between days 19 to 21 of the menstrual cycle. Now, homing in on the window of implantation further, this was first proposed in the mid-1950s, where various lengths have also been proposed since then. So earlier studies suggested that the window of implantation lasted about 10 days. Later studies suggested 2 days. And now molecular studies are suggesting an average window of implantation duration of 29 to 36 hours. Now, we can all agree that the window of implantation concludes upon the initiation of stromal cell deciddualization, subsequently permitting trophoblast invasion and placental formation. Now, we ask ourselves, when is the best time to transfer an embryo in IVF cycle? And we should not ask not if, but again, when. When is the best time? So typically we transfer after 5 full days of progesterone exposure in an HRT cycle. This would correspond to about 7 days from LH surge or HCG trigger in a natural cycle. Because again, this would equate to approximately day 19 and 21 of the days where the window of implantation lies in most women in natural menstrual cycles. So what has been the standard endometrial preparation for IVF transfer? Well, we assume that the window of implantation is constant in all women, which of course now we know that is not to be true. We have to consider the effects of supraphysiological steroid levels and control ovarian stimulation cycles and the potential deterioration of endometrial receptivity. That's why usually if we see high endogenous progesterone levels prior to HCG trigger or retrieval, this usually will yield the need for an all-freeze cycle. We monitor hormone levels, so standard it would be estrogen and progesterone. And then I would say probably all of us look at the assessment of endometrial thickness by transvaginal ultrasound. We want to see a nice thickness of the endometrium around 6 to 12 millimeters prior to progesterone administration. Now, there have been methods of inducing or finding receptivity that include endometrial scratching, though in the Cochrane review, this shows that's not a very effective technique. Histological dating has been used in the past, so have biochemical markers. Now, probably the most advanced technology is going to be utilizing transcriptomics, which is the study of full range of messenger RNA or mRNA molecules expressed from genes or organisms. The analysis of gene expression patterns in particular tissues under distinct conditions allows not only for diagnosis of pathological conditions such as cancer, but also physiological processes such as endometrial receptivity. And a prime example of this would be the ERA test or endometrial receptivity analysis, the original endometrial receptivity test in IVF. And here it analyzes by NGS or next generation sequencing the expression of 248 genes related to endometrial receptivity to determine the optimal day for embryo transfer for each specific patient. So this allows for an actionable directive for a more personalized approach to embryo transfer and provides enhanced synchrony between an implanting embryo and a receptive endometrium. So the ERA test itself is supported by over 30 publications, but the main indication is recurrent implantation failure. And I'd like to share some studies here with you. So this was an earlier study back from 2013 in which we looked at the receptivity rates between RAF patients and control. And we see that about 1 in 4 RAF patients have a displaced window of implantation, where our control group, which were patients without RAF, had a displacement rate of only about 12%. Now, what was interesting here is that when we adjusted the window of implantation based upon the patient's personalized time of receptivity, the RAF had similar outcomes to those of the control group. So again, we were showing that for many of these patients with RAF, it was just simply finding their personalized window of implantation and personalizing transfer based upon this timing. I like to also share another case report. I think these are very profound and highlight highlight the advantages or the biological processes backing these tests. So in this particular case, the patient had underwent 7 failed cycles. You could see fresh, frozen, HRT, natural, even 3 of them using oocyte donation, and always had a failure. Now, she did undergo the ERA test, was found to be displaced by 2 days, transferred on P+7, so about 160 hours of progesterone exposure. 2 embryos were transferred, and she had successful twin pregnancy and live birth. So again, just further highlighting how important endometrial receptivity and personalizing embryo transfer can be for some patients. In a recent publication, again, looking at RAF patients, a group wanted to assess RAF patients who underwent ERA versus those who went under traditional FET, in which they found significantly higher implantation, pregnancy, and clinical pregnancy rates in patients who underwent a personalized embryo transfer versus a standard embryo transfer. And then there have been recent meta-analysis, again, showing the benefit in patients with RAF. So one from Liu et al. In 2022, showing that PET guided by ERA significantly increases the chance of pregnancy for non-receptive patients with RAF and endometrial origin. A more recent meta-analysis from earlier this year by Glovjowski et al. They showed that in women with RAF, PET might improve the clinical pregnancy rate. And then just about a month ago, there was a meta-analysis comparing the effectiveness and safety of 36 therapies or interventions for pregnancy outcomes with recurrent implantation failure, in which ERA was one of the 36 therapies assessed, in which it showed improvement for implantation rate, live birth rate, and when used with PGTA, reduced miscarriage rates. Additionally, this year at ESHRA, it was presented improved outcomes in patients with one or more failed transfers, where we saw a significantly higher pregnancy rate, ongoing pregnancy rate, and live birth rate versus patients who underwent a standard embryo transfer. And then more internal data, again, showing significantly improved outcome with the addition of personalized embryo transfer with euploid embryo transfer following PGTA. So again, ESHRA good practice recommendation for RAF also showed that ERA can be recommended to patients suffering from RAF to investigate endometrial function. And then to further solidify, our group is this year launching a multi-center perspective non-selection study for endometrial receptivity analysis in patients with previous implantation failures. So we are looking forward to starting this very large endeavor and to have the results hopefully sooner than later to share with everyone. And conclusions here, because I'm running out of time, is that endometrial factor plays a key role during the implantation process, and we cannot always solely rely on embryo for success. Although most women are receptive at the standard window of implantation, some of them reach receptive phenotype earlier or later, showing a displaced window of implantation. And to increase the probabilities of getting pregnant, it is important to synchronize a competent blastocyst with a receptive endometrium through personalization of embryo transfer. So I hope to show you that a healthy and receptive endometrium is indeed at the heart of implantation. So thank you again for allowing me to speak today and for your attention.
Thank you, Tiffany. And last but not least, let me introduce you Dr. Miguel Milan. Dr. Milan serves as the prenatal director at Igenomics, and he earned his degree in biology in 1999 and completed his PhD in 2007 at the University of Valencia, Spain. With over 25 years of experience in clinical and research laboratories, Dr. Milan began his career in the molecular neurobiology unit at the University of Valencia and joined the preimplantation genetic diagnosis unit at IBI Valencia in 2006. In 2015, Dr. Milan joined the prenatal division of Igenomics, taking on the responsibility for the integration and development of the unit and the non-invasive prenatal testing service. As an author, he has contributed to numerous books, chapters, and scientific articles in international journals, and has actively participated in numerous national and international conferences. Dr. Milan is also involved in various training activities and disseminates results and special cases in prenatal genetic diagnosis. Dr. Milan, please, whenever you want, the stage is yours.
So good afternoon, everyone. And well, first of all, let me thanks to the scientific committee for giving me the opportunity to be presenting here today. And we are going to talk about the usage of cell-free DNA in the analysis of products of conception. And as you can see in the subtitle, we think that with this new approach, we can cover a gap in the study of aneuploidies in pregnancy loss. This is my disclosure. And well, as a super brief introduction, all of you know that there are dozens of factors described in the scientific literature that can be the cause or can contribute and increase the likelihood of suffering or having a miscarriage, a pregnancy loss. But among all these factors, there is only one that yet accounts for 50% of all the miscarriages. We are talking about aneuploidies, and these figures could be even higher, up to 60% in the IVF population. If we talk about the general obstetric population, it's well known that this is not a rare event. So 15 to 25% of all the pregnancies could end in a pregnancy loss. Regarding according to the scientific and professional guidelines regarding the management of these cases, nothing is recommended regarding testing. So there is no recommendations in testing or start testing in patients when they have an isolated miscarriage based on different reasons. Perhaps 4 good reasons could be the ones that you have in this slide. So the first one is that the likelihood of having another consecutive miscarriage are quite similar to the starting point. So 15 to 25% to have another consecutive miscarriage. Obviously, testing costs money. And obviously, if some of this testing is genetics testing, you need the fetal remains, and getting these fetal remains many times is through invasive or surgical procedures that they have risks associated, although they are low, but they have risks, and some doctors, they don't want to to assume those risks with the patients. And even if you take the risk and you perform the sampling and you perform the genetic analysis, if we think globally, the most standard testing all over the world is the karyotyping due to different reasons, because it's classic, because it's what is feasible, or because it's what is included in the systems, in the public health system, or covered by insurance companies. And the problem with this kind of genetic testing, that is a wonderful testing, don't get me wrong, but regarding the pregnancy loss has several limitations that in some cases you are managing an information that could be misleading or plenty of uncertainties and cannot help a lot in the reproductive management for these patients. Some of these limitations are the ones that you can see in this slide, and some of these limitations can be overcome with the usage of molecular techniques like the next generation sequencing or the chromosomal microarrays, in which, for example, no cell culture is required. Sometimes the tissue that we get is not so vital, so it's not growing, or is growing so slowly. The turnaround time getting the results for the management of the case is shorter. In the case of the molecular testing, the percentage of informativity is way better. So we are talking that with the karyotype, we are getting some, on average, 50% of the cases are informative. With the molecular approaches, is more than 80. In the case that we are performing the sampling with hysterembryoscopy, we can reach virtually to 100%. We don't have any sort of false negative due to maternal site contamination, because with all these techniques, with the molecular testing, usually we perform STR analysis just to identify if the DNA that we are isolating from the tissue is from the mother or from the fetal tissue. And in case we use, for example, chromosomal microarrays, we are getting greater resolution. So much better, but still doing the analysis in the fetal remains. What is the problem? The problem, and this is our experience, and for sure is your experience, and it's been described in many, many different articles, and this is just an example. One fantastic article that I recommend you to read if you can is a work from Dr. Tanya Slagher-Hadwick. And even if you want to get the tissue in all your cases, there is a percentage of them in this article. They described that it was like a third of all these cases in which it's impossible to get the tissue just to perform the analysis. So you lose the opportunity to know about the genetic status of this miscarriage, okay? And that it should be convenient just to have an alternative a technique that is tissue independent, just to understand what is happening. In this part of the slides, you can see that whenever you want to perform the analysis, this is the percentage of cases in which you don't have access to this tissue. And when you perform the analysis, there is a percentage of cases in which what you are analyzing is maternal cell contamination. So no clue, no information for the clinical management, okay? But we are talking, the subtitle of this talk was covering a gap. And the gap, it's an important gap. So we can define the gap as all those patients in which they suffer or they have an spontaneous pregnancy loss, and in which the management is not surgical management. They are not going to go through a dilatation and curettage or aspiration or a private evacuation, getting the tissue just for the analysis. So they are going to have the misoprostol or the cytotec pill to have this evacuation privately at home, and they are not going to recover this tissue for analysis. So no information for those cases. When you talk with doctors and you say, okay, would you like to know the aneuploidy status of this miscarriage? The answer is always yes. So we are losing, or these patients remain untested all the time. And even if you take the tissue, as we were saying before, there is a percentage of cases in which no information is going to be available. So this is the gap number 2. So important percentage of patients in which doctors would like to have the aneuploidy testing done, but it's not feasible because they don't have the tissue, the fetal remains, available for analysis, or this tissue is not it doesn't have the quality or the quantity, that is needed for the analysis. What we know, what is the alternative that we are describing today? And for sure, you've heard something in different conferences before this one, is the usage of the cell-free DNA that is circulating in the maternal bloodstream to perform this kind of analysis. So the procedure, as you can see in this slide, is simple and straightforward. It's just to take a blood sample, a peripheral blood sample, in which we have the plasma, the blood plasma. There we have the cell-free DNA with all the DNA from the maternal organs and tissues. And if this woman is pregnant, obviously there is one tissue that is releasing the cell-free DNA to the maternal bloodstream, that is the placenta. And with all this, what we can do, and this is the regular procedure for the NIPT, for the non-invasive prenatal testing that you already know, at the end of the road, what we are doing is a bioinformatic analysis just to assess if the ratios of the chromosomes that we are analyzing are correct, or there is an anomaly that we can detect in the maternal bloodstream. If this can be applied not only for ongoing pregnancies, but in miscarriage, this is something that several groups, we have the experience of performing the NIPT in cases that, at the beginning, everybody thought that it was an ongoing pregnancy, but when they performed the sonographic examination on week 12, they discovered that the fetus was arrested before, several weeks before, and the analysis with the NIPT that was requested to different laboratories, was informative with normal or abnormal results. And additionally, we have the experience of those cases in which we have an ongoing pregnancy with an ongoing fetus, but in which we have a vanished twin. And this vanished twin is well known. That is the first and most important factor contributing to the false positives in non-invasive prenatal testing. And the reason is because although this fetus has been arrested, the cell-free DNA or the DNA from these remains are, released to the maternal bloodstream and can be absolutely detected. But the question is, okay, we detect this DNA, but how reliable is it? So what is the performance? How many cases can escape to the analysis? This is something that should be assessed. The scientific evidence, so the number of articles describing the experience of using the cell-free DNA in the maternal bloodstream, it's different. So it started in 2014 with the description from Cecilia and collaborators that the cell-free DNA from the miscarriage could be detected. Then the group of Yuval and colleagues and Dr. Antonio Borrell described in 2020 with a good casuistry of cases what was the experience with very positive results, and later on different laboratories and different scientific or research groups described their experience. This is one of the last studies, is the one that I mentioned before, that I strongly recommend you to read this article. It's a Lancet, and it's a fantastic work with about 1,000 cases, or 1,000 miscarriages. And I think that tomorrow in session 6, you have the lecture of Dr. Tanya Hardwick explaining their results. And finally, we published our evidence and our experience with the usage of cell-free DNA in cases of pregnancy losses using a single algorithm. Based on that experience, we decided to perform a clinical validation, but not with a single algorithm of analysis, but with a dual algorithm of analysis, with an adapted one that is a proprietary algorithm in iGenomics with more than 150 cases, as you can see in this slide, in which we studied in parallel the DNA content or the DNA information from the fetal remains. That this is an active service that we have for years at iGenomics at my center, and we dissected and processed this tissue. We isolated the DNA, we obtained the genetic information, and we assessed if this information is maternal or not, taking along with this tissue the blood sample from the mom in an extract tube, just to discard or confirm by STRs the fetal origin of the sample. And then with this plasma in the maternal blood sample, what we did is just to perform an NIPT, as a regular NIPT is performed with the platform that we are using in our laboratory. And at the end of the road, what we did is a different bioinformatic approach using this dual algorithm analysis. And at the end, we assess the concordance between the information with the invasive POC analysis with the non-invasive POC analysis, getting an 88% of concordance once triploid cases were taken out of this comparison, because what we wanted at that stage was just to compare apples with apples. And you know that the triploidy or the ploidy, changes in ploidy, is a limitation in all the NIPTs except one platform that can perform the analysis with SNP information. Okay, so 88% of concordance is quite important in this point, just to point out that the accuracy could be importantly improved in all the scientific evidence that you can find today in the scientific literature. These are the 4 main studies and experiences with the groups that are published, the results in the scientific literature, and you can see how the accuracy using the basic and native NIPT algorithm could be importantly improved when the algorithm is adapted for miscarriages. This is our experience too, and you can see how this, on average, for all the laboratories, explaining the accuracies, it seems that this adaptation can improve. You can have more than 10% increased accuracy, and this increased accuracy is important because the more reliable is the result for the miscarriage information, the better the reproductive counseling you can give to your patients in the future. Okay. Well, why choose to do a non-invasive POC test or using the cell-free DNA in the future for your patients? Well, the first reason is because it's non-invasive. So it's, as I said, it's simple and straightforward. And many doctors around the world, they don't know or they don't want to perform a surgical management or evacuation, doing DNC, stereoscopy, or whatever, or they don't want to touch the structure, and they rather prefer the patient to have the evacuation privately at home. Secondly, because it's going to be faster. So if you compare with the conventional karyotyping that is taking like 1 month, here we can have, and we have results as early as 1 day, 2 days, 3 days. But in general, we can think that the normal TAT in the future is going to be the one that you have for the NIPT service. So I mean, between 1, 2, 3 to 7 working days, okay? Because in addition, the informativity rate is so high. If you compare again with the karyotype, you can see that the karyotype is well established and accepted, that the informativity rate is around 50%. And you can see as this is improved with the new molecular techniques working directly on the fetal remains. We go to the range of 80 to 90%, close to 100 if we use hysteroembrioscopy. But you can see is using the cell-free DNA have figures that are quite comparable to the ones using these molecular approaches and way better than the one with the karyotype, okay? If we stratify this non-informativity in the different weeks of gestation when the fetus was arrested, you can see how the non-invasive POC gets more informativity, above all in these early stages, week 5, week 6 of pregnancy. And then there is an stabilization up to week 10, and from week 10 onwards, it seems that it's more informative using invasive POC. So this is valuable information that we have to, keep on going and getting this result with more cases just to define better, but it seems that the NIPOC is going to be a good solution for early pregnancies. Regarding the test limitation, the test limitation combines the limitation of any molecular testing, like could be the PGTA or the CMA. That means you can see in these points their limitations, along with an additional limitation that is the one corresponding to the non-invasive prenatal testing, because we are doing the analysis in the maternal bloodstream. And although it's weird to find cases like these cases that I'm describing in the last point, from time to time we can have a maternal condition that is maternal, is not from the placenta or the fetus, and can confuse the aneuploidy colon. So this could happen in case you know that the mother has an abnormality in the karyotype. There is something to take into account before testing. So regarding who can benefit from this new approach, obviously, and I want to be clear in this slide, and don't get me wrong, this cell-free DNA for me is an amazing advance and an amazing alternative where before we have nothing. But in case you are comfortable as a doctor, whenever you have a miscarriage, doing a DNC or an invasive sampling, surgical sampling, and collecting this tissue and performing the analysis directly in the tissue, this is the way to go, because it's the reference, is the gold standard. And in case you get informativity in the fetal remains, it's going to be the best, okay? But for those cases in which the management was just, just to give the pill, give me misoprostol or Cytotec, and to have the private evacuation and not having the possibility of testing, now you have an alternative that is highly accurate, simple, and straightforward. Suitable for 3 different situations. It could be suitable. The main recommendations for the of the professional guidelines is only for recurrent miscarriage. So this could be applied and this could be done in the future in recurrent miscarriages. But obviously, there is plenty of articles and evidence in the scientific literature regarding and describing what is the benefit in every single, pregnancy loss, not in recurrent miscarriage only, but in early pregnancy losses and isolated pregnancy losses, regarding how testing and knowing the reason for the miscarriage can psychologically alleviate the distress that caused this early miscarriage. And additionally, it gives you prognosis when you want to talk with your patients, because at the end, if you have an aneuploid miscarriage, it doesn't matter that it's isolated. When you have an aneuploid miscarriage, obviously, is not a maternal factor. And every one of us is at risk of having these kind of events because every one of us has abnormal gametes, and we are, in this lottery all together. So it's a good prognosis because it's the embryo, it's not the mom who is producing this specific miscarriage. Third, it could be suitable. Above all, we think it could be positive for patients undergoing assisted reproduction treatments and having a miscarriage. Why? Because as I told you, one of the limitations in these techniques is that the cell-free DNA miscarriages cannot detect triploids. And although in the ongoing pregnancies from week 10 onwards, it's weird to find this rare to find a triplet pregnancy that is ongoing. In the case of miscarriages, it accounts for about 5% of all the miscarriages. The cause is a triploidy. But in the case of the patients with going through an IVF treatment, because everything is more controlled, everything, the fertilization, the pronuclei production, the number of them, everything. How is the sperm many times? How is the sperm in the male, etc. There are less triploid miscarriages, and these figures can be reduced from 10.5 or even in the case of the IVF population, 1.5%. So being a limitation is less limitation. And additionally, the NIPOC, this non-invasive POC analysis could be or maybe a new decision-making tool. Why? And this is a real situation. I remember a call from a patient saying, okay, I performed an NIPT because the sampling was, beyond the week 10. We got the result, it was abnormal. She had a miscarriage, and she told me, doctor, is there anything that it can be done on, in my case, because I'm an IVF patient. I went through an IVF cycle. I have some embryos frozen, and I don't want this to happen again. For me, this is a drama, and I don't want, to happen this again. So is there something that it can be done? The reality is that for this patient, perhaps the regular, depending on the medical records, obviously, but the most common management would be to select the next embryo as per the morphology or whatever the criteria is going to be for this patient and transfer this. If this patient doesn't have a native indication for PGTA or non-invasive PGTA, so it's another transfer again. But this woman has said that she doesn't want to have another miscarriage again. For her, it's a drama. So we have to think that for this kind of patients, they have a burden trying to get pregnant at home, a psychological burden that then when they go to an IVF center, this burden, we have to add things. So it's not a psychological burden anymore, not alone. So it's going to be psychological, physical, and economic burden. She succeeds, and then she has this early pregnancy loss. So again, more psychological burden. What is the reason? We don't know, because strictly following the professional guidelines recommendations, nothing is going to be done, nothing is going to be tested. So we are going to your cohort of embryos that we already know that this cohort of embryos is going to be, mixed with euploid and aneuploid ones, and we are going to try again. But she said that she didn't want to go through this again. So it could be a good tool just to perform a non-invasive POC, well, a POC analysis, but since in many places and in many occasions to perform a DNC and go through this invasive procedure is going to be, not that simple as the NIPOC. Perhaps this approach could help us just to perform the analysis in the case, and just to figure out if there was an anomaly. In case there is no anomaly, just to allows you just to review the medical history of this patient and to decide what you want to do again, to transfer by morphology or whatever you want to do. In case you detect an aneuploidy, obviously the reason is the embryo. And obviously, she doesn't want to get another aneuploid embryo again. So a PGTA could be a good strategy, a PGTA or a non-invasive PGTA, just to, that the PGTA, the non-invasive PGTA, is not creating haploid embryos, but it's telling you information regarding what are the embryos that most likely are haploid and that has the greater successful likelihood for the next transferences. Okay, so this gives you an order just to reduce the likelihood of having what she doesn't want to have, that is a miscarriage. This is only for isolated pregnancy losses, but what happens in cases of recurrent miscarriage? In cases of recurrent miscarriage, it could be a good tool just to give perspective. Why? Because as you can see in this example, all these 4 patients are recurrent pregnancy loss patients, okay? Recommended by the guidelines to start doing testing on them, but patient number 1 and patient number 2 are equivalent because both of them, they had 2 miscarriages and the last one was analyzed and the result was normal, okay? Patient 3 and 4 are equivalent because the same, they had 2 previous miscarriages, consecutive miscarriages. The first one, I don't know because we didn't do anything, and the second one was an haploid. So they are equivalent. The recommendations for the first one, obviously, it seems that there is a problem with this woman. And based on the last information, we can recommend an ASRM workup, analyzing all, thrombophilias, endocrine factors, or structural uterine factors, but the couple's karyotype, whatever. Okay. In the case of 3 and 4, exactly the same. It seems that this is an haploid, the last one, so it makes sense that we can help this patient and this couple by doing a PGTA and selecting haploid embryos. But look what happened. What happens when we have perspective? And these perspectives could be easier to get if we have a non-invasive POC, this cell-free DNA analysis that is simple and straightforward. So we can have information from all the pregnancies or all the miscarriages in these women. And you can see as now number 1 and number 2 are not equivalent anymore. So it makes sense to perform the ASRM workup in patient number 1, but perhaps not in number 2. And how patient 3 and 4 are not equivalent anymore, and how the PGTA make a lot of sense in patient number 3, but not in number 4. Now the equivalent patients are number 2 and number 4. And what we have to think about is if this information is reliable and this information from miscarriage number 1 and number 2 is different, perhaps there is no consistency in the reason for the miscarriage, and perhaps this was serendipity. And again, this is a punctual, an infection or something that was punctual. And perhaps patient 2 and patient number 4, they are not yet, recurrent miscarriage patients. And we need a third event just to know what is the way that we should go with these patients, okay? And just to conclude, let me read these take-home messages that I think is quite important in couples who have miscarriages to find out the reasons that are behind these miscarriages. And we know that 50% of the causes are haploid. So I think it's quite important to start analyzing miscarriages whenever we want to find out the cause by the factor that is more frequent, and this is the genetics, okay? Point number 2 is that the non-invasive POC represents a new technical approach, allowing genetic testing in a group of patients that so far have always remained untested. So this opened this opportunity to all those doctors that they were willing or they would like to have these results, and before there were no technical approach to do so. So now it's feasible. The simplicity and accuracy of this new approach may help our patients first to alleviate the psychological distress, improve the clinical management to reduce future miscarriages. This applies especially in IVF patients without a clear indication of PGTA or non-invasive PGTA, and obviously gain perspective when a woman becomes a recurrent pregnancy loss patient. We are talking about knowing the genetic information, not only from the miscarriage number 2 or 3 onwards, but having all the information and the big picture in front of our eyes, just for a proper management of this patient. Before it was more difficult. because technically it was more complex, but now it's super simple and straightforward. And it's of paramount importance to understand the test performance metrics to give a proper genetic reproductive counseling to our patients. So it's quite easy that from now onwards, since we are getting more and more experiences from different research groups in the scientific literature, that many laboratories can be encouraged to launch new services and offer this service to you, to the clinics and to the doctors. But I think it's quite important for them just to have a proper, experience verifications and validations, just to give you reliable information regarding the sensitivity, specificity, accuracy, because this is important information for the pre-test counseling, for this interview that we may have with our patients or with your patients, just for them to understand what are they going through and what is the reliability of the results that they are getting in terms of aneuploidy, false positives, false negatives, and non-informative cases too, okay? And that's all. Thank you very much for your attention, and I'll be glad to answer any questions that you may have. Thank you very much.
So thank you very much, Dr. Stankiewicz, Tiffany, if I might say it, Dr. Milan, Miguel, if I might say as well. And thank you for your beautiful lectures. And we were moving from the embryo to the endometrium and also to analyzing these products of conception in a non-invasive way that it's perfect right now. So let me start with you, Miguel, talking about the non-invasiveness, because we were the other day in a conference and the physicians were like actually eager to start doing the non-invasive POC. So my question would be, do you think that non-invasive POC is going to overcome the invasive POC? You explained already a little bit already on your lecture, but could you develop a little bit your thoughts on this?
Sure. Good afternoon. So no, I don't think so. I think that there is this is a fantastic alternative. Not alternative. This is a fantastic tool for those cases in which to take these fetal remains is not feasible. So whenever you can do it and you can get these fetal remains, we are doing the analysis with 100% pure DNA from the fetus. If the DNA testing by STRs tell us that this is fetal, so there is no better analysis than the one that we can do this way, okay? But the reality, and this is the reason why our group and others have, expressed their experience using cell-free DNA and all this, all this situation, this new alternative, is because it's quite common around the world. We don't have to think about our situation in our country, but we have to think wide. And around the world, it's quite frequent that the management in case of early pregnancy losses or repetitive pregnancy losses is just to give the medical treatment, the misoprostol or the cytotec, just to have your private evacuation at home. So in those cases, you have two situations. Number one is that you are not doing any sort of testing, okay? That this is the most common. Or you can get by yourself privately the fetal remains and send this to the laboratory. And in those cases, even willing to have a testing in the fetal remains, the percentage of non-informativity is so high. It's so high, especially in early, weeks of gestation. For example, for instance, week 5, week 6, is too high. So I think that for those cases, or for those cases in which you receive the fetal remains and you see that the only thing that you have is blood counts and things that you are recognizing that the likelihood of having a non-informativity in the direct analysis is high. So this could be a good alternative just to get reliably information about the causes of this miscarriage. So it's not a substitution. I don't think it's going to be a substitution, but it could be a good partner in this trip.
Okay, cool, perfect. And Tiffany, you were explaining us about the importance of the endometrium, and we know that the endometrial receptivity analysis, the ERA, it's more for patients with implantation failure. Although there are some patients with a misplaced window of implantation that can cause biochemical miscarriages, right? Higher chances to have biochemical miscarriages. But we are at the recurrent pregnancy losses conferences. So I would like to focus a little bit more on the microbiome, because having an altered microbiome, even more having infections such as chronic endometritis or other infections, can cause these recurrent pregnancy losses, right?
Correct. Yeah. I mean, it's upwards of 60% prevalence rates. We see chronic endometritis in patients with recurrent pregnancy loss. So the microbiome is certainly an important area to study, particularly for those patients who had previous pregnancy loss, because it could be as simple as a dysbiosis or a pathogenic problem that can be effectively treated. So we actually have a clinical directive to improve for these patients. And you saw in one of the studies we showed, or of course you're quite familiar with it, but a big difference in miscarriage rate for those patients who have an optimal microbiome made of primarily lactobacillus versus those who don't, who have bacterial pathogens such as Gardnerella and Streptococcus presence. So we know that these bacteria have an effect and could potentially be leading to miscarriages.
So, and following this path, I think that lactobacillus is so important, but I think that it's more important because it doesn't allow to another pathogens colonize the endometrium, right? And that can cause this infection and the miscarriages.
Yeah, so I always like to say lactobacillus are like the safety net or the night guards. They keep the bad guys away, which would be your bacterial pathogen. Necessarily having a high presence of lactobacillus that leads to good outcomes. We know in microbiomes where there's very little biomass, so because there's an objective here that we need to keep. It's making sure the bacterial pathogens are omitted, allowing for an optimal microbiome, preferably with lactobacillus to be there to keep that constant.
Okay, thank you. And Miguel, did you say from the 5th week of gestation that can we analyze with the non-invasive POC for the chromosomal status of the miscarriage?
You are right. Yes, what we included in our clinical validation is from week 5.
Whoa! Yeah. So and you show the table because the no-call rates for the invasive POC in those weeks of gestation is really high.
Yeah.
So on this part, and this is I've been asked in ASRM this last week that they were asking about. We say that okay, it's so similar to the NIPT invasive prenatal testing, and why then we can get a result from a 5th week of gestation, but with the NIPT 10th week and onwards?
Well, two different things. The first thing is that you have to take into account that the informativity rate, what we got is less fetal fraction. So the fetal fraction on average in the product of conceptions that we've assessed in our study is like half. So if the average in ongoing pregnancies beyond week 10 is like on average in the period 6, so the activity beyond the week 10 is only 1% in our case, for example, and here for the POC is like 10%. So 10% non-informativity is so high in ongoing pregnancies. So what you want is just a tool that is useful and you don't have to repeat the analysis again and again and again. Number one. Number two, the clinical utility of this sometimes is not clear. Why? Because the only condition in which you can rely a lot with the results that you can get in NIPT whenever is abnormal is a trisomy 21. The rest of conditions that you can test, including sex chromosome aneuploidy and so on, if I see an anomaly, this could be a confined placental mosaicism, and I'm for sure I'm asking the physician. I'm having a conversation with the physician and with the patients just not to have a CVS analysis. Obviously, not to terminate the pregnancy because the positive predictive value for the rest of conditions other than trisomy 21 is not 190%, is below 80%, sometimes 50 or 10%. So it's important amniocentesis that can only be performed on week 16 onwards. So imagine the anxiety that the patient is going to have if you know the results on week 6 and she has to wait 10 weeks just to perform the procedure, but 4 more weeks, week 20, just to get the final results. So it's a long time, make no sense from the clinical point of view, just to test so early. And additionally, because what we have in a product of conception, once the fetal is 5%, 6%, this percentage of fetal fraction, most, cells that are dying are releasing this fetal DNA to the maternal bloodstream. So this is a lot of DNA from a small structure. I don't know if you follow my explanation. Mm-hmm. In case this is an ongoing pregnancy, in an ongoing pregnancy of the cytotrophoblasts, that this is a small part of the placenta, are releasing the cell-free DNA. So most probably in week 5, 6, get is lower than 5% of non-informativity and reliability less than this, 90% informativity. So we will fall in 50% non-informativity or less, and this makes no sense.
I see. So a perfect explanation. I mean, and Tiffany, when we find a patient with a recurrent miscarriage and we control for chromosomal status of the embryo, would you strongly recommend for a physician, because in our audience today we have a lot of physicians, to perform a study of the microbiome, and if so, what would be the technique? Because we are moving from the NGS to a real-time PCR with a target panel. What was the reason to do this movement?
Yeah, so the reason that we introduced an upgraded panel is really based upon our experience over the last 5 years with next generation sequencing. And I think this, coming from iGenomics, we're dedicated to science and we're dedicated to always evolving and improving and offering better products and better testing for patients out there. And the advantage with the RT-PCR is that we're actually able to now provide results at the species level, where previously with NGS, we were giving the genus, but now we can go a step further and give species level reporting. Now, why is this important? Well, it's important because it allows us to get an even more targeted treatment when it comes to the antimicrobials that we're giving. So maybe we have 2 different species of, say, Streptococcus, and one will be more effectively treated by one antibiotic, whereas the other one will be more effectively treated by another antibiotic. So this allows our microbiologists and our team to give a more targeted recommendation when it comes to antimicrobial therapy. So not only are we optimizing the outcomes further for the patient by getting them to an optimal microbiome much sooner, but I think we're also doing our part in general to prevent antibiotic resistance when we have targeted antibiotics versus broad spectrum antibiotics, which is super important.
Okay, that's great. That's great. And we have to finish now, but I would like to ask you, Miguel, for your personal opinion. I mean, and tell us whatever you think. Of course, because you know that for the recurrent pregnancy losses, usually they say, no, you have to wait until the third one. There is a paper from Dr. William Kutte, you know, from 2018, talking about, okay, after the first, but the second one, you have to test, and it's better to test first for the chromosomal status of the products of conception, because we will get more than 50% of those miscarriages. Would you test from the very beginning, from the first one? You were explaining that on the slides, and for me also makes sense, but would you recommend to our physicians here now, the medical teams, to start testing at the very beginning?
So it's difficult. I can give you my opinion, but it's difficult just to recommend something when the people that is managing everything with the patient are the doctors. So they have to understand.
Just your opinion. I'm asking just
Yeah,
for
no,
your opinion.
my
Obviously,
opinion as a geneticist, you know, that we always are willing to knowing everything. For me, just to have perspective is valuable. Gives you a lot of information regarding what can be miscarriages that are happening. So whenever you have something that is consistent, then you have clues, you have information just to, you know, the future treatment. And the best example is whenever you have a patient doing PGTA for a long time, and sometimes you have that the indication is PGTA, and you observe that normal. So I think that having perspective, we are gonna, you know, avoid that some patients go through PGTA procedures that are unnecessary, because the reason is. So whenever we have a recurrent miscarriage patient, if we have the history, we can determine, is there something consistent? Yes. So if this consistent in this way, this is the solution. If this consistent in the other way, we have another work. In case we have to, you know, keep on going and having more data just to understand what is the direction. Perhaps we need, with 2 consecutive miscarriages, we need a third miscarriage just to understand if 2 are normal. Perhaps we have this mix, and the problem is the mom. And we have serendipity. And the second was abnormal just because serendipia, because we have abnormal gametes. But there is a maternal, problem that is arising with the third one. Do you see my point? And the same the other way around. So if we have 2 abnormal miscarriages and only 1 normal, obviously we have a repeated condition, and perhaps PGTA could be a good strategy for them. But again, this is my opinion, and I'm geneticist, and for sure I'm biased, but makes sense. For me, make a lot of sense.
okay, so I think that we went through all the landscape. We checked for the chromosomal status of the embryo, and we do know that this will help to analyze the embryo, will help to our recurrent pregnancy patients. Also, we check for the endometrium. We observe that it's really important to analyze, to know that the patient infection, no pathogens at all. And also in cases and happens that miscarriages, it's important to know the condition and why this happened, to have the information, but also for the emotional burden of the patients, right? So I guess that it's time to close not only this session, but also this first day of recurrent pregnancy losses and human reproduction 7th annual conference, where we started with a great pre-course of artificial intelligence, with and infertility, getting the hope, and this last session that we have just finished. Please don't miss tomorrow, the second day of the conference. I can tell you that there will be a lot of interesting. And I would like to thank again to all of our speakers, including, of course, Dr. Tiffany Stankiewicz, Dr. Miguel Milan, for being here today. And also, of course, to all of you for staying with us. And wishing peace for all of the world, including, of course, Ukraine and Palestine. I must say goodbye to all of you and have a great end of the day. Thank you very much for your attention. Thank you and goodbye.